I know you all are waiting for complete organic chapter. Guys, are you ready? Guys, are you ready? I think you all are ready, guys. Yes, I think I'm on live. I am live. Voice is very low. அப்படியாடா voice low இருக்காடா? Can you please check everyone? Voice lower or it is okay? Voice lower, voice echo அடிக்குது லைட்டா. எல்லாருக்கும் எக்கோ இருக்காடா? இல்லனா உன்னோட சிஸ்டம் ப்ராப்ளமா? It's low. Let me check. Okay. Now I will check again. இப்போ I will check again. இப்போ I will check again. இப்போ no sound. Perfect. இப்போ clear தானே? பட் எக்கோ எடா ஃபோன்ல இருந்துடா எக்கோ. இப்போ clear? இப்போ ஓகே தானேடா? I want 100 live, okay? 100 students live ல இருக்கணும். எல்லாரும் QCA session like பண்ணுங்க. எல்லாரும் QCA session like பண்ணுங்க. சீக்கிரமா ஃபாஸ்டா லைக் பண்ணுங்கடா. எல்லாரும் ஃபாஸ்டா session like பண்ணுங்க. I think இப்போ வாய்ஸ் clear தானே? So எல்லாரும் session fast-ஆ like பண்ணுங்க. Come on, quick. New subscriber. Yes, hello. Aisha. Yes, Aisha, am I audible? Audible தானடா? இப்போ எல்லாமே perfect தானே? இப்போ எல்லாமே perfect தானே? Start பண்ணலாமாடா? Organic chemistry. So we will finish all the organic chemistry chapter. பக்காவா எல்லாமே finish பண்ணிடும். Okay? எல்லாமே finish பண்ணிடும். Okay? Clear-ஆ? So complete-ஆ இன்னைக்கு organic chapter finish பண்ணிடும்டா. So எல்லா chapter-ம் சொல்லுங்க உங்களோட most difficult organic chapter எது? Most difficult organic chapter. So அதில இருந்தே ஸ்டார்ட் பண்ணலாம். most difficult organic chapterல இருந்து உங்களோட most difficult organic chapter எது? most difficult organic chapter. most difficult organic chapter. all chapters. General organic chemistry. Aldehyde ketone carboxylic acid. Ma'am, sound double-ஆ கேக்குது. Sound double-ஆ கேக்குதாடா? Vetri batch பத்தி. So that Gobika ma'am already சொல்லியிருக்கல. Ma'am 11th chemistry organic. Yes. Kashifa already Neet like commentல சொல்லியிருந்தது. 11th chemistry organic chapter கொஞ்சம் difficult-ஆ இருக்குன்னு. So we can check that chapter also da. Okay? Okay? Clear-ஆ? So start பண்ணலாமா? GOC. Everyone is saying GOC. Then we can start with GOC. Guys, are you ready? So I thought GOC எடுக்க வேண்டாம்னு நினைச்சேன். But எல்லாரும் GOC தான் கேக்குது. Then we can start with GOC. Guys, are you ready? Guys, are you ready for GOC? Guys, are you ready for GOC? Guys, are you ready for GOC? I want 100 live watching. Come on, QCA. Okay, I want to see 100 live watching quickly. 100 இருந்தா I will start now. Okay, I will start GOC. 100 Q ka 100 இருந்தா I will start GOC. GOC. Okay, so actually GOC is very simple. Okay, concept clear and the GOC is actually very simple now. So we can start with GOC. Guys, are you ready? I think you all are ready, so we can start. Okay, so tell me now, what is a organic reaction means? Tell me what is a organic reaction. Tell me quickly what is a organic reaction. What is a organic reaction? Ma'am, buffering. No, it's not buffering. No, yes. So what is a organic reaction? What is a organic? Yes, it is base only, da. It is base. We are starting from GOC. GOC is the base of organic. Okay, that is actually organic chemistry. So I am taking organic chemistry means bond breaking and bond making. So I am writing here organic conjugate. Okay. Organic chemistry. Ilana actually chemical reaction. So what is chemical reaction? So I will write chemical reactions means bond breaking and bond formation. Okay, and bond formation. Bond making and bond formation. Okay, bond break agu at the same time la ma'am ma'am oh video is buffering. Happy. Thank you so much. Thank you so much. Advance. Thank you. Video stuck kada. Video stuck. No da, video is not stuck. I can also see here. Eda video stuck illa da. Video is not stuck. Video stuck allada. No da. Video is not stuck. Okay. Stuck dana. Adu eppadi enakku paaka mudiyude. Yes, GOC 11th order chemistry தான். GOC 11th order chemistry தான். GOC isomerism எல்லாமே isomerism actually எல்லா சாப்டர்லயும் இருக்கு. So GOC isomerism IUPAC எல்லாமே 11th order chemistry தான். Hydrocarbons எல்லாமே 11th order chemistry. Okay? Sometimes. Okay, I don't know. இப்போ clear தானடா? இப்போ clear தானே? Now perfect. Then we can start. If it is perfect, we can start. So bond breaking and bond formation is actually chemical reaction. So bond break new products are forming. That is actually chemical reaction la. So when you consider bond breaking, okay, when you consider bond breaking means it is actually two type. Okay, it is actually two type. One is homolysis bond breaking, another one is heterolysis bond breaking. Okay, so homolytic fission, okay, homolytic fission nu sollala illana heterolytic fission nu sollala. Okay, homolysis or homolysis homolytic. So I will write here. Okay, bond breaking is actually two types. So I am writing here bond breaking is actually two type. Breaking is actually two type. One is homolytic cleavage and another one is heterolytic cleavage. So there is two type of bond breaking. Bond break agradhu. Voice is not clear. Guys, ma'am stuck buffering. Please check network. So no, it is visible only. Here I can see. I am checking. Let me check. Here I can see. It is clear dana. I am checking. Let me check. Here I can see. It is clear dana. Harder. Perfect. Yes. Yeah, come on now. So homolytic cleavage is there and heterolytic cleavage is there. Okay, there is two type of bond breaking. One is homolytic cleavage and another one is heterolytic cleavage. So here we are discussing, okay, in GOC we are discussing different type of effects, okay, different type of electron displacement effect, okay, electron displace agu and effect da nama GOC la paaka porudhu, okay. I think its voice is clear only da guys. I'm checking. Yeah, I can see. Yeah, clear. Perfect. Yes. Yeah, come on now. So, hello. 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 I don't know. So, hello, everyone. Is it clear or not? Hello. Yeah. Now I think it's clear. Yes, Gopika ma'am is also here. So we can start. It's clear now. Okay. Okay. Yes. Okay da. So bond breaking is actually two type. Ellarum quick session like பண்ணுங்க. எல்லாரும் quick session like பண்ணுங்க. எல்லாரும் quick session like பண்ணுங்க. Okay. So we can start. I think we can start the session. We can start the session. Okay. So we can start. I think perfect le. Ipo perfect danada. Ipo perfect danada. Ipo perfect danada. Yes, yes. Just a second. Idu just sort pannatunda. Okay, we can start anyway. So bond breaking. Okay. So bond breaking is actually two type. One is homolytic cleavage. Another one is heterolytic cleavage. Okay. So what is bond breaking? What is bond breaking? Ippo clear? Am I audible? Am I audible? Am I audible? Am I audible? Okay, perfect. Okay. Still echo irukada? Still. Yes, clear. I think clear. We can start. Okay. No, perfect, ma'am. Okay, we can start. Oliver just rejoin panipare. Okay. Oliva just rejoin panipare. Okay. So bond breaking is actually two type. One is homolytic, another one is heterolytic. So guys, what is homolytic means? Tell me what is homolytic means. So we know that homo means it's something same. Yes, homo means something same. So homo or homolytic fission. Okay, homolysis cleavage we can say, homolytic fission we can say. So what is actually homolytic fission or homolysis cleavage? So it is very simple. When you consider a bond AB, okay, AB bond irukku. Here A is sharing one electron and B is also sharing one electron. Okay, A is sharing one electron and B is also sharing one electron. While the bond breaking time, okay, in bond breaking time, what will happen? This electron, okay, B oda electron B oda பக்கத்துல போகும். Okay, B oda electron B oda பக்கத்துல போகும் and A oda electron A பக்கத்துல போகும். ஒலிவா உனக்கு தான் பிரச்சனைன்னு நினைக்கிறேன், பாக்கி எல்லாமே பர்ஃபெக்ட். அப்போ எகெயின் செக் பண்ணு இயர்ஃபோன் என்ன படி யூஸ் பண்றேன்னா. Okay, so I think echo voice. So let me call Akshay. Let me call technicians, okay? Just a second, just a second. Hello. Hello. In Studio 5 there is some mic issue. Perfect. Can I continue the class? So I called technicians. Okay, they will come right now. Okay, everything is perfect now. So some students are saying it's echoing. All perfect. Anyway, we can start it. Okay, they will come. Okay, they will come and they will check. Hello. Yeah. Yeah, now he is doing that. Akshay. Yeah, he's here. Yeah, he is here.
Now see.
Hello. Eda, இப்போ audible? இப்போ echo இருக்கா? Can you please check? இப்போ echo இருக்கா? No. Hello, is it clear now? Da? No, ma'am. Now perfect, ma'am. Okay, I think it's perfect, yes? Ipo perfect dane? Yes, perfect. Okay. Why?
Yes, sound is there.
Okay. Okay. Is it clear now?
Speak to
Hello guys, is it clear? Yes, all perfect. Yes, clear. Okay da, then we can start. Apurv, no Apurv. No ma'am. No, perfect. Okay, no issue ma'am. Yeah, it's clear now. Yes, da. So we can start then. So AB, okay, AB bond irukku. What will happen? In the bond break ஆகும்போது, okay, in the bond break ஆகும்போது A share பண்ணி இருக்கிற இந்த 1 electron A பக்கம் திருப்பி போகும், okay, and B share பண்ணி இருக்கிற இந்த 1 electron B கிட்ட திருப்பி போகும், okay, bond breaking timeல, okay, so it's a covalent bond தான், it's a covalent bond. So covalent bond break பண்ணும்போது என்ன நடக்கும்? Covalent bond break பண்ணும்போது என்ன நடக்கும்டா? Simple. Covalent bond break பண்ணும்போது என்ன நடக்கும்? So இந்த A ஓட electron A ஓட பக்கத்துல போகும், B ஓட electron B ஓட பக்கத்துல போகும். That means it is the equal distribution of electron, okay, it is the equal distribution of electron. So bonding sigma bond, okay, இங்க pi bondல உங்களுக்கு homolysis heterolysis பார்க்க முடியாது. Normally நம்ம எப்படி சொல்லும்? Homolysisல மட்டும் தான் சொல்லும், okay, that means sigma bondல தான் சொல்லும், okay, are equally distributed bonding. So equally distributed between bonding atom, so that electrically neutral intermediate. Then what will be the product? Tell me, what will be the product of homolysis or homolytic fusion? So tell me, what will be the product? It is very simple. A free radical and B free radical. So you will get, okay, you will get A free radical and B free radical in homolysis fission or homolytic fission. Okay, clear? Clear? Then we are moving to heterolysis. Okay, we are moving to heterolytic bond breaking or heterolytic bond cleavage. Then tell me, what is heterolysis? So heterolysis means it is different, okay, heterolysis means it's not equal. Homo means it's equal, so hetero means it's not equal. Then what will be the product of heterolysis? We can assume A and B. We can assume A and B is there, okay, clear? A and B is there. So A is sharing, okay, A is giving 1 electron and B is also giving 1 electron, okay, so then AB bond is forming, okay, AB bond is forming. Then what will happen? What will be the product? So heterolysis na, heterolytic cleavage na, இங்க bond break பண்ணும்போது electronegativity ஓட basisல தான் bond breaking நடக்கும், okay, so we can assume that electronegativity of, okay, so I will write electronegativity of A is more than electronegativity of B. So electronegativity of A is more than electronegativity of B. Then what will happen now? Electronegativity of A is more than electronegativity of B. Then what will happen? Simply I will tell you. What is electronegativity? Do you remember what is electronegativity? What is electronegativity? What is electronegativity? Tell me quickly in the chat box. What is electronegativity? How many? Hey, stop this, okay? I want to finish all the chapter, that's all. So come on, tell me, what is electronegativity? No, from basic I am starting now. From basic I am starting. Attraction of pair of electron, Apurva is saying, inversely proportional to atomic radii. So I am asking electronegativity. Just you can write the definition, okay? You can write the definition. So electronegativity means, okay, electronegativity means, it's very simple now. Electronegativity, what is electronegativity? It is the ability of an atom, okay, it is the ability of an atom. It is the ability of an atom to attract the shared pair of electron. Yes, I can see. It is the ability of an atom to attract shared pair of electron. So, inga electronegativity யாருக்கு ஜாஸ்தியா இருக்கு? A க்கு ஜாஸ்தியா இருக்கு. Okay, you can see electronegativity in A order the electronegativity is more. Then what will happen? So A will attract this 2 electron while bond breaking. So what will happen here? A will form A negative, that means A anion, and B will form positive because B donate the electron. Yes, B donate the electron, A accept the electron. Okay, so A minus and B plus. Okay, A minus and B plus. Clear? A minus and B plus. So that means we can say that in the case of heterolysis or heterolytic bond breaking, what will form? Simpler anion and cation will form. Okay, what will be the product in heterolytic bond breaking? The anion and cation will form. So we can consider a carbon. Okay, we can consider a carbon group. So here I am taking carbon is there 1, 2, 3 and one group. Okay, I am not taking atom, I am taking a group G. Okay, here the group G. So we can assume that the electronegativity of G, okay, electronegativity of G is more than electronegativity of carbon. Then what will be the product? Tell me what will be the product. Tell me what will be the product here, da. Tell me what will be the product. Come on. Carbanion, carbocation. Carbanion or carbocation? Tell me. Carbanion or carbocation? Tell me quickly. Carbanion kadikuma, carbocation kadikuma. G is anion and carbon is cation. Here I can see. Yes, very good. So here you will get carbon. Okay, electronegativity G kida jastiya irukku. Okay, so electronegativity is more in G group. Okay, it's maybe group or atom. So then what will happen? So here carbon is sharing one electron, G is also sharing one electron. So in the two electrons, G pakka hogu. Okay, then what will be the product? Carbocation and G minus. Okay, and G minus. Very good. We will get carbocation. Okay, we will get carbocation. So I will give you another example. So carbon and I will take A. Okay, so here I am saying electronegativity of A is less than carbon. So the electronegativity of carbon is more than A. Okay, electronegativity of carbon is more than A. Then what will happen? Tell me quickly, da. Tell me quickly. So what will be the product? What will be the product? Yes, carbanion will produce. Yes, very good. So you will get C minus because inge enna electronegativity carbon ku da adhigama irukku. Then what will happen? Carbon will accept that 2 electron. Okay, so carbonic enna negative charge and A oda charge enna da? A oda charge is positive. Is it clear? Is it clear? Tell me, is it clear or not? So when you consider heterolytic bond breaking, okay, when you consider heterolytic bond breaking, what will be the product? Carbocation and carbanion. Or we can simply say that what will be the product? What will be the product? The product will be, okay, the product will be simple da. The product will be kyukka solunga. The product will be anion or cation. Okay, the product will be anion or cation. Everyone quickly like the session. Okay, everyone quickly like the session da. Okay, I hope it's clear. Idu varaikum clear dana? So our target is 500 likes. Okay, so here, okay, some important notes are there. So ellarum proper parunga. Any covalent bond can break in both homolytic and heterolytic manner. So when you consider bond analu, okay, covalent bond analu, namukku homolytically break pannala, heterolytically break pannala. First important point. Then heterolytic bond breaking takes place in polar solvent. Okay, heterolytic bond breaking enga irukku? So polar solvent நமக்கு தெரியும் ஒரு reaction நடக்கணும்னா reactant மட்டும் போதாது. Okay, reactant மட்டும் போதாது. So we need a medium, ஒரு medium தேவை. Okay, so we need a medium. That medium is actually solvent. Okay, so what is polar solvent? Thank you so much. What is polar solvent? When you consider water, So when you consider water we can consider as a solvent. Okay, so water la hydrogen na namakku theriyum, hydrogen is partially negative, oxygen is partially negative, hydrogen is partially positive. Okay, here you can see two poles. Okay Bunny, is it clear? You can see two poles. Okay, minus irukku plus irukku. Soda simple ah sollala, inge enna irukku, it is a polar solvent. It is a polar solvent. Okay, is it clear? So two poles irukku, two charge irukku, two charge separation irukku. Okay, so that is a polar solvent. Water is a polar solvent. Okay, when you consider water, water is a polar solvent. I hope it's clear. Then next, homolytic bond breaking take place in gaseous phase or non-polar solvent. Okay, homolytic bond breaking enna either gaseous phase la nadakkum illana you can see. Okay, you can see in non-polar solvent. You can see in non-polar solvent li nadakkum. Then next is bond energy. What is bond energy da? So we are discussing about bond breaking. Yes, we are now discussing homolytic bond breaking, heterolytic bond breaking. So what is bond breaking da? So bond breaking means we need we should give an energy, yes, to break the bond. Okay, we should give the energy to break the bond. So then what is bond energy means? Minimum energy required to break the bond in homolytic cleavage. Okay, so bond break பண்றதுக்கு தேவையான minimum energy தான் actually bond energy. Okay, so in the bond break பண்ணனும்னா we should give energy. So that energy is actually bond energy. I hope it's clear. Then we are moving to electron displacement effect. Okay, so what is electron displacement effect? Yes, after this we will start IUPAC. Okay, இந்த செஷனுக்கு அப்புறம் இந்த சாப்டர் ஃபர்ஸ்ட் ஜியோசி, அதுக்கப்புறம் IUPAC, அதுக்கப்புறம் ஐசோமரிசம், அதுக்கப்புறம் ஹைட்ரோகார்பன்ஸ். இதுதான் என்னோட பிளான். ஸோ அதுக்கப்புறம் பாக்கி so on சாப்டர்ஸ் இருக்கு. ஓகே, so yes, now we are going to discuss about electron displacement effect. Okay, electron displacement effect. So when you consider electron displacement effect, there is mainly two type of electron displacement effect. Okay, so one is permanent effect, another one is temporary effect. Okay, so one is permanent effect and another one is temporary effect. So what is permanent effect? Ma'am, it's very simple. Permanent effect means it is permanent only. What is temporary effect? Yeah, obviously, guys, it's temporary only. So, in your NEET syllabus, okay, உங்களோட NEET syllabusல permanent effect மட்டும்தான் இருக்கு, temporary effect இல்ல. Okay, permanent effect மட்டும்தான் இருக்கு, temporary effect இல்ல. So, what is permanent effect? So first one is inductive effect, another one is resonance effect, and third one is hyperconjugation effect. Okay, and temporary effect la electromeric effect, and another, there is one more temporary effect, that is inductomeric effect. So inductomeric effect. Okay, so there is two different type of effect. Electron displacement effect, one is permanent effect. What is permanent effect? Inductive effect, resonance effect, hyperconjugation. Then what is temporary effect? Temporary effect is not there in your syllabus, so it is electromeric effect and inductomeric effect. Okay, so actually this permanent effect are very important. Okay, permanent effects are very important. So which is most important permanent effect? Tell me, which is most important permanent effect? Tell me quickly da. So which is most important permanent effect? Tell me quickly, come on da. Resonance. Guru, not hyperconjugation, resonance. Okay, resonance is most important permanent effect. Okay, so after that hyperconjugation. Okay, after that hyperconjugation, then inductive effect. Okay, then inductive effect. Most important is resonance, then hyperconjugation, then inductive effect. Is it clear now? Is it clear? So first we are discussing about inductive effect. Okay, so base la irundhe start பண்ணலாம்ல. So base la irundhe start பண்ணலாம்ல. So base என்ன? Inductive effect தான். Okay, base என்ன இருக்கு? Inductive effect. So what is inductive effect? Inductive effect is a permanent effect. Okay, inductive effect என்னடா? Permanent effect தான். Inductive effect means permanent displacement of electron. What is happening there? Permanent displacement. Electron order displacement is happening. Okay, so permanent displacement of sigma electron in a covalent bond because of any atom or group is known as inductive effect. So inductive effect எப்படி denote பண்ணும்? I வச்சு தான் inductive effect denote பண்ணும். So inductive effect is a permanent effect. Okay, so it is a permanent effect and inga what is happening? Displacement of sigma electrons. Okay, sigma electrons தான் என்ன inductive effect show பண்ணும். Okay, inductive effect யாரு show பண்ணும்? sigma electrons. Okay, pi bond அப்ப sigma like inductive effect இல்ல. So அது உங்களுக்கு தேவையே இல்ல. Inductive effect ன்னு கேட்கும்போதே அது sigma bond single bondல தான் பார்க்க முடியும். Okay, so நாம இப்பவே minus I plus I படிச்சு போகும். Okay, don't worry, minus I இப்பவே by heart படிச்சு போகும். Okay, so clear ah? Don't worry பண்ணி. So இப்பவே we will by heart. Okay, what is minus I group, what is plus I group? Okay, don't worry. So by heart பண்ணலாம். Okay, no worries bunny. So first we are discussing about minus I effect. Okay, minus I effect. What is minus I effect means? So when you consider a group, okay, carbon is there, 4 carbon is there. So I am taking a group G. So what is the speciality of this group G? What is the speciality of this group G? Group G is minus I group. Okay, that is electron withdrawing group. So this minus G is a electron withdrawing group. So then what will happen? So in the central you can see central G is sharing one electron. Okay guys, G is sharing one electron. G is sharing one electron and carbon is also sharing one electron. So normally electrons எப்படி இருக்கணும்? Center of the bond ல இருக்கணும். Okay, so you can see எப்படி இருக்கணும்? Electrons center of the bond ல. But okay, but G is more electronegative. G is more electronegative. Then what will happen? So G is more electronegative means G attract the electron. Okay, so G oda attraction strong ah irukum. Then what will happen? So in the electrons complete G kitta pogadu. Okay, complete pogadu because anga sharing la da irukum. But கொஞ்சம் G ஓட பக்கத்துல இருக்கும். ஓகே, சோ கொஞ்சம் டிஸ்பிளேஸ்மென்ட் தானே, சோ கொஞ்சம் G ஓட சைடுல இருக்கும். G இங்க தான் இருக்கு. ஓகே, G ஓட சைடுல எலக்ட்ரான்ஸ் இருக்கும். சோ தட் இஸ் because it is a electron withdrawing group. சோ இந்த கார்பனோட எலக்ட்ரான் என்ன கொஞ்சம் G ஓட பக்கத்துல இருக்கும். சோ இது ஃபர்ஸ்ட் கார்பன் மட்டும் இல்ல, up to 3 கார்பன் வரைக்கும். So then I will repeat again, no worries. So up to 3 carbon வரைக்கும். So that means இது வரைக்கும் minus I effect என்ன feel ஆகும். Okay, minus E effect என்ன up to 3 carbon வரைக்கும். Okay, up to 3 carbon வரைக்கும் minus I effect feel ஆகும். Okay, up to 3 carbon வரைக்கும். Clear ah? Yes, definitely. So you can see, you can feel this. You can, not you can. So for this carbon can feel up to, this carbon can feel minus I effect up to 3 carbon. Okay, minus I effect can feel up to 3 carbon. Okay, clear? Up to 3 carbon. Clear? So minus I effect can feel, okay, up to 3 carbon. Okay, it can affect up to 3 carbon. After 3rd carbon, this minus I effect is negligible. Okay, after 3rd carbon, this minus I effect is negligible. Is it clear or not, guys? Is it clear or not? So what will happen? This G will get partial negative charge. Okay, this G will get partial negative charge. Okay. No, branch we are not discussing the branch we are not discussing, about chain only we are discussing. Okay, so here G will get partial positive. Yes, I will repeat again, no worries. Okay, G will get partial negative charge and carbon will get partial positive charge, and this carbon will get 2 delta positive. This carbon will get 3 delta positive. Ma'am, delta is increasing, number of delta is increasing. No, delta means small. 2 delta means small, small. 3 delta means small, small, small. Okay, is it clear? So, I will repeat, Joseph. So, inductive effect means, okay, inductive effect means it is the displacement. So, permanent effect, it is the, you can see the displacement of electron. Okay, you can see the displacement of electron. So, first one is minus I effect. What is minus I effect? So, atom or group of atom which withdraw the electron. Okay, so here you can see this G group is withdrawing the electron. Okay, it's withdrawing the electron. It's withdrawing the electron of the sigma bond. Okay, of the sigma bond towards themselves as compared to hydrogen. So just a second. So here when you consider minus I group, okay, when you consider minus I group, we will compare with hydrogen. Okay, we will compare this minus I group when you consider plus I group. So here I will show you. Okay, this is not plus I, this is minus I. This is minus I. This is minus I only. This is minus I. So minus I we will compare with hydrogen. Okay, last one is hydrogen. So last one is hydrogen. We are comparing this with hydrogen. Okay. So what is G? G is a electron withdrawing group. Okay. G is a electron withdrawing group. So G will withdraw the electron. Okay. So G will attract the electron of carbon. Okay. So G will attract the electron of carbon. So what will happen? So central irukku vendiya electron yaar pakkathula poi irukku? G oda pakkathula poi irukku. So in the bond mattum illa up to 3 carbon you can see minus I effect. Then what will happen? So here central la irukka vendiya electron enna? I will show you again. Okay, so you can see this minus I effect. When you consider plus I effect, okay, plus I effect is also up to 3 carbon. Okay, this effect also you can see up to 3 carbon. Is it clear, da? Is it clear? Tell me, is it clear or not? Tell me in the chat box, is it clear or not? Is it clear or not? I will discuss everything. Okay, don't worry, Asad. Clear? Any doubt? Then we are going to by heart this minus I group. Okay, we are going to by heart this minus I group. It's very easy. Okay, very easy, guys. Are you ready? I think you all are ready. So yes, I can see. So first one is nitrogen groups. Okay, I will give you some trick to remember. Okay, nitrogen group first. NF3, NR3, NH3, everything is cation. Okay, here you can see everything is cation. So NF3, NR3, NH3, adukapra again NO2. Okay, again NO2 and CN. Okay, cyanide group. Is it clear? Idu varaikku okay thane? Ellame 5 groups, starting 5 groups ellame nitrogen groups. Okay, nitrogen irukku. Okay, first NF3, then NR3, ellame cations. Okay, NF3 plus, NR3 plus, NH3 plus, NO2. And after that, CN. Okay, idu varaikum padicho. Is it clear now? So up to CN varaikum clear dane. Then we are checking carboxylic acid, COOH. Okay, COOH. After that, halogens. So halogens order enna? Halogens order I am writing. Halogen order is fluorine, chlorine, bromine, iodine. Okay, fluorine, chlorine, bromine, iodine is the order of halogen group. Then we are moving with OR group, OH group. Okay, OR and OH group. After that, chlorine, fluorine, chlorine, bromine, that is the order da. So I can see fluorine, bromine, no, fluorine, chlorine, bromine, iodine. Okay, clear? Yes. So after that sp, okay, sp means that is triple bond. Okay, after that you can see sp, triple bond. After that you can see NH2. This is NH2, this is NH3 plus. Okay, this is NH2. Okay, after that benzene group and double bond. Okay, so by head panalama again. எதுல 800 and something கிடைச்சிருக்குடா, எதுல 800 and something டா. So first, so எல்லாரும் இந்த minus I group பார்க்காம எல்லாரும் உங்களோட chat boxல குயிக்கா ரைட் பண்ணுங்க. So எல்லாரும் minus I group குயிக்கா உங்களோட chat boxல ரைட் பண்ணுங்க. I will check. Okay, first எல்லாமே positive nitrogen group. Okay, NF3, NR3, NH3 and after that NO2 and after that NO2 க்கு அப்புறம் Cn. Okay, clear? அதுக்கு அப்புறம் யார் வருது? Carboxylic acid. Okay, அதுக்கு அப்புறம் carboxylic acid. அதுக்கு அப்புறம் யார் வருது? Once again. Okay, I will tell again. So first nitrogen group. அது first a nitrogen group with the cations. Okay, NF3, NR3, NH3 எல்லாமே plus. Okay, NF3 plus, NR3 plus, NH3 plus. Okay, NF3 plus, NR3 plus, NH3 plus and after that NO2. Okay, after that NO2 then என்ன வருது? Cn வருது. அதுக்கு அப்புறம் யார் வருது? COH வருது. அதுக்கு அப்புறம் ஹாலஜனுக்கு அப்புறம் OR and OH. Okay, OR and OH, simple. Okay, OR and OH. அதுக்கு அப்புறம் யார் வருது? Triple bond. So triple bond க்கு அப்புறம் double bond இல்ல, triple bond க்கு அப்புறம் NH2. Okay, NH2 இங்க you can see this is NH3 plus, this is NH2. Okay, this is NH2. After NH2 benzene. So after benzene double bond. Okay, clear? I will check. NF3 plus plus, don't forget to write plus. Okay, NF3, NR3, NH3, NO2, can COH, chlorine, fluorine, chlorine, bromine, iodine, chlorine, fluorine, bromine, iodine. So I will check here. Bromine, iodine, and OR, OH, triple bond and NH2, arene, yes, and double bond. Yes, very good. Ma'am, one last take block chemistry. Yes, block chemistry. Which block you want? So NF3, NR3. Yes, correct. Susmita, Guru, NF3, NR3. You write NRS. NR3, NO2, CN. Yes, very good. CN. So here, Susmita, CN is missing. Okay, CN is missing. NO2, can, you write can. Okay, clear. COH, X, OR, H, triple bond. After that NH2, CN, COH, X, OH, OX, OR, OH, SP. Okay, SP and after that SP ke appra enga pochuda? Joseph, Jenny. NF3, NR3, R3 ada, NR3 da, NR3. So where is NF3, NR3, NH3? I can't see NH3 here, Jenny. So Jenny konjam kuda edit பண்ணனும். Yes, Kashifa, Divya, yes, Idya, Lapsi, Bunny, loading ma'am. எப்போ load ஆகும்? It's showing loading. Yes, very good. Very good da. So எல்லாரும் சீக்கிரமா செஷன் லைக் பண்ணுங்க. Very good. Correct தான். Okay, சீக்கிரமா எல்லாரும் செஷன் லைக் பண்ணுங்க. Then we are moving to plus I group. Okay, we are moving to plus I group. So proper பாருங்க, what is plus I group? Okay, what is plus I group? So what will happen da? So this is our carbon 1 2 3 4. Okay, 1 2 3 4 and this is our group G. Okay, this is our group G. What is the speciality of this group? What is the speciality of this group? Here in minus I group, G is a electron withdrawing group. Then what is G here? Tell me what is G here? Electron donating group. Okay. Here G is ready to donate electron. Okay. Electron donating group. So what will happen? I will tell you. G is ready to give electron. Okay. Just take my electron. Okay. Take my electron. I will ready to give you electron. Okay. So I will ready to give you electron. Okay. So then what will happen? What will happen? So what will happen da? So what will happen? This G will get, okay, G will get partial positive charge. Okay, G will get partial positive charge. When you consider this carbon, carbon will get partial negative charge. This carbon will get delta delta negative. This carbon will get triple delta negative. Is it clear? So what will happen? G is ready to donate electron and here carbon is accepting the electron. Okay. So carbon is getting negative, partial negative charge. It's not complete negative charge, partial negative charge. And here G is giving electron. So G is getting positive charge. Is it clear, guys? Is it clear? Is it clear? Is it clear or not? Is it clear? Super. Clear. Clear, electron donating group. Okay. Yes. Asat, correct. So we are discussing the plus I group. Okay. We are discussing about plus I group. So proper parunga. So minus I group la you can see starting with enna irundhathu. Start enna pannirukku? Cations irundhathu. Okay. Cations. You can see here cations irundhathu. Inge enna irukku? Here you can see anions. Here you can see anions. Okay, here you can see ellarum seekrama session like pannunga. Okay, so here you can see anion CH minus. Okay, so start pannalama, by heart pannalama. CH minus, sorry, CH2 minus, NH minus, okay, O minus. Okay, first 3 group minus group anions da. So that means I will repeat CH2 minus, NH minus, O minus, COO minus, and after that it is tertiary carbon. Okay, tertiary carbon. After tertiary we can say secondary carbon. So after that you can say primary. Okay, chain or primary carbon is there. Okay. So next you can see here. So here you can see it is isotopes of hydrogen. Okay, isotopes of hydrogen. Clear dane? Clear. Any doubt? Is it clear? Come on guys. Seekrama sollunga. In the order quick-a எழுதுங்க. In the order quick-a எழுதுங்கடா. Yes. Then we can write together. So ellarum chat la எழுதுங்க. CH2 minus, NH minus, O minus. Okay, CH2 minus is very important. Okay, CH minus, CH2 minus, NH minus, O minus. So after that inga irundhu hydrogen போயிருக்கு. Carboxylic acid la irundhu ஒரு hydrogen போயிருக்கு. So distance, okay, distance increase ஆகுது. Okay, so இங்க இருந்து hydrogen போயிருக்கு. So it is after என்ன வருது? Carboxylic acid ல இருந்து hydrogen போயிருக்கு. So COO minus. And after that tertiary, secondary, primary. After that carbon ஓட isotopes. Okay, clear? எல்லாரும் quick-ஆ write பண்ணுங்க. Okay, chat box ல. Then we are moving to application of inductive effect. Okay, we are moving to application of inductive effect. Okay, application of inductive effect. Is it clear da? Clear. Another application of inductive effect. What is application of inductive effect? So first one is stability of carbocation and carbon free radical. Okay, stability of carbocation and carbon free radical. Okay, stability of carbocation and carbon free radical same irukku. Okay, same irukku. And next is stability of carbanion. Okay, carbanion oda stability different way la irukku. Okay, idoda stability carbocation and carbon free radical oda stability same ah paakum, and stability of carbanion different ah irukku. Okay, so and next is acidic strength and we will discuss basic strength. Clear ah? Start பண்ணலாமா? Start பண்ணலாமா? Yes, Asad. Yes, that's me. I will give you, I want Hyderabadi biryani. Okay, I want Hyderabadi biryani. So first one is stability of carbocation and carbon free radical. Okay, stability of carbocation and carbon free radical. Okay, hey, not today da, ennoda birthday illa da inneki. So first one is first rule. Okay, there is 3 rules for stability of carbocation and stability of carbon free radical. Okay, so stability of carbocation and stability of carbon free radical ku 3 rules irukku. Okay, so 3 rules irukku. So first rule we are discussing. First rule, yes, I will definitely come to Chennai. Okay, so next time. Okay, so first one, okay, rule 1. So rule 1 is electronegativity. Okay guys, okay, electronegativity. So electronegativity, what is electronegativity means ada? So namakku theriyum carbocation irukku, carbon free radical irukku. Okay, after result definitely I will come down. So carbocation and carbon free radical oda stability we are comparing. Ena first electronegativity base பண்ணிட்டு compare பண்ண போறேன். Okay, electronegativity base பண்ணிட்டு compare பண்ண போறேன். So we know that, okay, we know that S character directly proportional to electronegativity. Clear? S character directly proportional to electronegativity. Clear ada? Okay, menu eda, menu exam ku aprom illa eda, நான் சொன்னது menu exam ku aprom party, like neat crack பண்ணதுக்கு அப்புறம். Okay, neat crack பண்ணதுக்கு அப்புறம் party இருக்கு, நீங்க neat crack பண்ணதுக்கு அப்புறம். Okay, so yes, so S character, okay guys, S character directly proportional to electronegativity. Okay, clear? So Jenny, what is this? So S character directly proportional to electronegativity. So electronegativity நமக்கு தெரியும் double bond, triple bond and single bond irukku. Okay, double bond, triple bond and single bond irukku. When you consider triple bond means that is sp character. Okay, sp character. And when you consider double bond ஆகும்போது அது என்னடா sp2 character. And when you consider single bond, okay, when you consider single bond, that is sp character. Okay, sp character. Is it clear? So there is 3 type of bond. நமக்கு தெரியும் double bond இருக்கு, single bond இருக்கு, triple bond இருக்கு. Triple bond இருக்கும்போது that is sp character. And I want to kick. So triple bond இருக்கும்போது sp character, double bond இருக்கும்போது sp2 character, and single bond இருக்கும்போது sp character. Okay, sp character. Is it clear? So S character directly proportional to electronegativity. Clear? So as electronegativity of carbocation increases, so electronegativity increase ஆகும்போது what will happen? Stability of carbocation or carbanion will decreases. So I am writing here stability of carbocation or carbon free radical is inversely proportional to electronegativity, guys. It is inversely proportional to electronegativity. So appo இதுல electronegativity இல்லனா இதுல s character யாருக்கு s character இல்ல electronegativity இல்லனா stability யாருக்கு ஜாஸ்தியா இருக்கும் triple bond-ஆ double bond-ஆ single bond-ஆ stability யாருக்கு ஜாஸ்தியா இருக்கும் so எல்லா points-உம் பார்க்கணும் s character directly proportional to electronegativity so s character எங்க ஜாஸ்தியா இருக்கும் sp ல தான் s character ஜாஸ்தி அதுக்கு அப்புறம் sp this is sp3 okay guys so 3 எழுத மறந்துட்டேன் sp3 so S character எங்க ஜாஸ்தியா இருக்கும் sp ல அதுக்கப்புறம் sp2 ல அதுக்கப்புறம் sp3 ல so when you consider stability of carbocation it is inversely proportional to electronegativity so stability of tell me stability எப்படி இருக்கும் yes we can write the stability so stability யாருக்கு ஜாஸ்தியா இருக்கும் sp3 because அங்க s character கம்மி தான் okay sp3 க்கு ஜாஸ்தியா இருக்கும் guys sp3 க்கு ஜாஸ்தியா இருக்கும் stability is more in sp3 okay and after that sp2 so I am writing you are writing the character of s okay character of right s so I am writing so I will write again okay I will write again stability of carbocation or carbon free radical என்ன இருக்கும் sp3 and sp2 after that sp do you have any doubt you can ask okay any doubt எதாச்சும் doubt இருந்தா கேளுங்க I will sort okay I will sort ma'am doubt இருக்கு அது எப்படி so I will make it clear எதாச்சும் doubt இருந்தா கேளுங்க clear 50 degree yes correct because here we know that in case of sp la s character is 50% okay and sp2 la s character is 33% and sp3 la s character is 25% correct yes very good bunny me only da me நான் தான் என்னோட note prepare பண்றது I am writing I am making the note everything I am making okay is it clear then we can I hope it's clear I hope it's crystal clear then we are moving to a question guys I think you all are ready for the question so the question is here chill do it all clear yes all clear you guys are saying all clear then do it the question do the question yeah I will drink water 3/2 what is 3/2 3 or 2 so write the minus I effect minus I order okay minus I group order you can write so what is minus I order we can write together okay tell me so quick ah solunga first is NH sorry not NA NF3 plus and after that NR3 plus after that NH3 plus so 5 nitrogen family இருக்குல்ல so நான் இங்க இருந்தே ஸ்டார்ட் பண்ணலாம் okay I will start from here first one is NF3 plus and after that NR3 plus and NH3 plus and after that யார் வருதுடா NO2 I'm writing CO2 NO2 and after that CN after that COOH and after that fluorine chlorine bromine iodine okay X so so inga parunga check பண்ணலாம் so அவங்களோட question என்ன so which of the following has minimum minus I effect okay minimum minus I effect கேட்டிருக்கு okay we can check so inga COH இருக்கு so COH is here so I am writing COH and COH NR NR3 plus NO2 NO2 is here fluorine yes fluorine so correct answer என்னடா it is Yes, correct, correct, correct. You guys are correct. So who said 2 or medico student? 2 or 3? 2 or 3? 2 is COOH. Okay, carboxylic acid. Carboxylic acid க்கு அப்புறம் தான் யார் வருது? Halogen group வருது. Halogenல fluorine, chlorine, bromine, iodine. Then I will give you next question. I think you all are ready for the next question. So the next question is here. Yes, yes. So the question is here. Confused, ma'am. What's your name? What's your name? Durga, yes, ma'am, ready. SBK 50. Oh, you are late. Sudan. Sudan தான் கேட்டிருக்கல. So what is the question? Which of the following correctly represent plus I effect of substituent? Yes. So yes, correct. Yes. One தான். உங்களுக்கு தெரியும்ல அந்த ஆர்டர் தெரியும்ல? Yes. So இங்க first rule தான் சொல்லியிருக்கு. Rule 2ம் 3யும் பாக்கி இருக்கு. ஓகே, ஃபர்ஸ்ட் ரூல் தான் சொல்லியிருக்கு. ஸோ ரூல் 2 அண்ட் ரூல் 3. ஓகே, ஸோ ஃபர்ஸ்ட் ரூல் ஆல்ரெடி முடிச்சிட்டேன். செகண்ட் ரூல் இஸ் ஆக்சுவலி இம்பார்ட்டன்ட். ஓகே, ஸோ இஃப் ஃபர்ஸ்ட் ரூல் ஃபெயில்ஸ், ஓகே, ஃபர்ஸ்ட் ரூல் ஃபெயில் ஆகும்போது வி ஷுட் செக் செகண்ட் ரூல். ஓகே, இஃப் ஃபர்ஸ்ட் ரூல் ஃபெயில்ஸ் யூ ஷுட் செக் செகண்ட் ரூல். வாட் இஸ் செகண்ட் ரூல் டா? So if electronegativity is same, okay, when you consider, okay, first rule fail ஆகும்போது அப்போ என்ன? electronegativity same ஆகும்போது you should check second rule. Okay, you should check second rule. So if electronegativity is same, then stability of carbocation and carbocation and carbon free radical follows tertiary, secondary and primary. Okay, so tertiary is more stable, then secondary, then primary. Okay, primary is very less stable. Okay, when you consider the stability of primary, secondary and tertiary carbocation, tertiary is more stable than secondary, then primary. If rule 1 and rule 2 fail ஆயிடுச்சுனா you should check rule 3. What is rule 3? Stability of carbocation or free radical is directly proportional to plus I and inversely proportional to minus I group. Okay, so that fails. ஏடா சேம், ஓகே, electronegativity சேம் ஆயிருக்குன்னா ரூல் 1 இஸ் ஃபெயில் ஆகும். ஸோ என்ன ரெண்டுமே என்ன டெரிஷரி இல்லைன்னா ரெண்டு மாலிக்யூலுமே டெரிஷரி இல்லைன்னா செகண்டரினா யூ ஷுட் செக் தேர்ட் ரூல். தேர்ட் ரூல் என்ன? கார்போகேட்டையான் is direct. Carbocation or carbon free radical directly proportional to electron withdrawing group and inversely proportional to directly proportional to electron donating group and inversely proportional to electron withdrawing group. Is it clear? Is it clear, guys? Then I will give you next question. I think you all are ready for the next question. So the next question is here. Hey, tomorrow is not my birthday, da. Tomorrow is not my birthday. Who is saying? Who said that? Tomorrow is not my birthday. சும்மா சொல்றேன். So tell me, what is the correct answer? Shalini, Kashifa, Apur. And can you tell me the reason also? Can you tell me the reason? Share the reason also. Priya, Ramu, yes, ma'am, doubt. Yes, tell me the doubt. Okay. So here, heterolysis of propane. So when you consider heterolysis means what will be the product? When you consider heterolysis means what will be the product? Heterolysis la enna product irukku? Enna product kadaikum heterolysis la? Heterolysis la enna product kadaikum? Homolysis la namakku theriyum. What will be the product in case of homolysis? Free radical will be the product. In case of heterolysis, okay, in case of heterolysis, what will be the product? Carbocation and carbon free radical, or we can say that anion and cation. Okay, anion and cation will be the product. Okay, anion and cation will be the product. So you guys are saying 3, then I will directly check 3. Methyl, anion in ethyl carbocation. Yes, correct answer is yes, correct. Baki ellathileyume free radical irukku, and ethyl free radical, and here also free radical is there. Free radical means that is not the answer. Okay, so when you consider heterolysis, cleavage means the product will be anion and cation. Okay, anion and cation. Yes, I will tell you again. So when you consider heterolysis, okay, Ganesha, so when you consider heterolysis oda product எப்பவுமே cation and anion தான். Okay, cation and anion தான் heterolysis oda product. Homolysis oda product is free radical. So Ramu is saying what is free radical? I will tell you what is free radical. So chlorine, okay. So chlorine bond bond la chlorine is sharing 1 electron, and this chlorine is also sharing 1 electron. So inga bond break agumbodhu, okay, inga bond break agumbodhu what will happen? So in the 1 electron chlorine kitta pogum, in the 1 electron chlorine kitta pogum. This chlorine will form free radical, this chlorine will form free radical. In the 1 electron, in the chlorine oda 1 electron da, okay, adu free radical nu sollu. Okay, clear Ramu? Okay, then we are checking next question. Find the correct order of stability of carbocation. Come on, da. Could like as well. Yes, sure. Adum nadakala. Okay, adum form agala. Aisha rise. Yes, it will also form. Okay, so you can write the answer. Guru is saying 3. Ganesha saying 1 question mark. Okay, 1 not doubt. Pavitra is saying 2. And I wish you happy Vishu to all. Happy Vishu everyone. Today in Kerala we will celebrate Vishu. Yesterday you guys celebrate Tamil Nadu la ellarume ena New Year celebrate பண்ணிருக்கல. So எல்லாருக்குமே happy New Year. Okay, happy New Year and happy Vishu. Yeah, thank you so much. So Vishu oda special என்னன்னு கேட்டா class தான், mega marathon. So it's a like New Year. Okay, it's a New Year. Happy wish you everyone. And it's Malayalam New Year. Okay, it's Kerala New Year. Tamil New Year yesterday irundhathu. Okay, April 14th ku Tamil New Year irundhathu. So இன்னைக்கு Kerala New Year. Okay, anyway, I wish you happy Vishu and happy New Year to everyone. Okay, என்ன அப்போ என்ன கேட்டிருக்கு? Yes, you guys are saying 1 2 3. Oh, Asat, you are from Kerala le? So now you are settled in Trichy. Yes, Asat? Yes, I am a Malayali da. Yes, I am a Malayali. Asat now settled in Trichy alla da. We will celebrate Ugadi. I know Ugadi. Ugadi last month, like March la dana Ugadi. I'm from Cali. Oh, I'm also from Kozhikode. I'm also from Kozhikode. I'm also from Kozhikode. Okay. Ugadi. I know you. I know Ugadi. March 19th. Okay. From. Hi Tanu. How Tanu? Yeah, I know Tanu. I'm from Telangana. Okay. Here I can see Telangana students, Malayali students. I'm from Kollam. Moonar, ma'am. Oh my god. So I think either South Indian channel announce pannala. Here I can see Kannada students, Telugu students, Malayali students, Tamil students. Kannada also Ugadi, ma'am. Oh, yes, I know. Ugadi. Yes. Only in Bangalore. So I actually, Nanu ipa actually Bangalore la irukku, Palakkad. I'm from Karnataka, from Pondicherry. Pan India channel. Yeah. Pan India channel change pannala. E road. Canadian. Okay. In Tamil Nadu. Okay, nice. South India NEET Vedantu, ma'am. Yeah, we can change the name to South India NEET Vedantu. Yes, that's a good idea. So I will also come da. I will also definitely come. Okay. So naanum varunda. So inga class irukalla. So class ellam mudinju. I'm from Andhra Pradesh. Yes. Oh my god. Andhra Pradesh, Telangana, Karnataka, Kerala. So any other South Indian states? Okay, definitely I will. From Delhi. Oh my god. That's so nice. From Delhi also. From Delhi. From Delhi. So we can either change pannala. Pan Indian channel convert pannalanda. Charminar. Hyderabad Charminar. Ma'am, Tamil Nadu. Okay. Okay, nice. Anyway, it's so nice. So இவ்ளோ students இருக்கு pan Indian students இருக்கு எனக்கு. Nice. From Chennai. High tech city. Yeah, எல்லாமே high tech city students. Okay. Yeah, it's so nice. So உங்களை எல்லாரையும் பார்த்தது. Hometown is Jammu. Really? From Dubai. From Dubai also, ma'am. Oh my god, Alappuzha. Yes, Gobika ma'am is from Alappuzha. I'm from Calicut. So yes, okay. So எல்லாரும் session quick-ஆ like பண்ணுங்க. Okay, எல்லாரும் session quick-ஆ like பண்ணுங்க. எல்லாரும் session quick-ஆ like பண்ணுங்க. Okay, all India in live chat. Yes, all India in one live chat. Okay. Okay, now find the correct order of stability of carbocation. Okay. So there is one more rule. Okay, I will tell you one more rule. That is DNP rule. Okay, that is DNP rule. DNP rule. What is DNP rule? So first நீங்க என்ன பார்க்கணும்டா? Yes, all India students I have. So definitely நான் அப்படிதான் சொல்லுவேன். எனக்கு all India students இருக்கு. டெல்லியில இருக்கு. All Indiaன்னு சொல்ல முடியாது. துபாயிலயும் இருக்குல்ல. So yes. So DNP. Yeah, என்னோட like face is actually not only face, my scalp is actually ரொம்ப oily. High oily தான். I don't know. இவ்ளோ oily எப்படி produce பண்ணுதுன்னு. So DNP rule. What is DNP rule? Distance, number, power rule. Okay. Distance. So I'll write here. Distance, number and power. First you should check distance. Okay. First you should check distance. Then you should check number. Then you should check power. Okay. Normally நம்ம என்ன check பண்ணும்? Power தான் check பண்ணும். Okay. நம்ம normally we will check power. Okay. So first என்ன check பண்ணணும்? Distance தான் check பண்ணணும். Distance is more important. Okay. All Asia students. Okay. Yeah. It's correct. So distance is, so inga parunga, this is carbocation. Okay, this is carbocation. So here I am writing carbocation. And இங்க எந்த group இருக்குடா? Which group is present here? Tell me which group is it? Minus I group or plus I group? Which group? Yeah. Yes, tell me which group is present here, minus I group or plus I group? Obviously, it is minus I group. So here you can see chlorine is there. Chlorine means obviously it is minus I group, minus I, minus I, minus I group. So I am writing minus I group. Okay. So here it is carbocation. So I am writing, guys, stability of carbocation. Stability of carbocation or carbon free radical is directly proportional to, tell me, directly proportional to, come on, come on, come on, come on. Yes, very good. Plus I effect and inversely proportional to minus I effect. Okay. So that stability of carbocation directly proportional to plus I effect and inversely proportional to minus I effect. Okay. Here you can see everything is here chlorine. Okay. Only chlorine is there. So chlorine is there means chlorine is actually minus I group. Okay. Chlorine is actually minus I group. So stability of, if chlorine is there means stability will decreases. Okay. If chlorine is present means stability will decreases. Is it clear, guys? Is it clear? Is it clear? Ma'am, எப்போ முடியும்? எல்லா சாப்டரும் finish பண்ணும்போது முடியும். லஞ்ச் பிரேக் இனியும் டைம் இருக்குடா லஞ்ச் பிரேக்குக்கெல்லாம். ஸோ என்ன மைனஸ் ஐ குரூப். ஓகே, மைனஸ் ஐ வரும்போது வாட் வில் ஹேப்பன் டா, ஸ்டெபிலிட்டி டிக்ரீஸ் ஆகும். இங்க என்ன இருக்கு, எல்லாமே மைனஸ் ஐ குரூப் தான். Okay, clear? So here you can see there is no minus I group. Okay, when you consider this molecule, okay, fourth molecule, when you consider fourth molecule, there is no minus I group. There is no minus I group means it is more stable. Okay, because if minus I group present means stability will decreases. So there is no minus I group means stability is more. Okay, so fourth தான் stability ஜாஸ்தியா இருக்கு. So எல்லாமே fourth தான் first இருக்கு. Okay, then next யாரு வரும், so we can check next one. Okay, we can check next one. So when you consider, so this is our carbon, first carbon, second carbon, third, fourth position la chlorine irukku, first, second position la chlorine irukku. Here you can see 1 2 3, third position la chlorine irukku. Okay, so here இது fourth position la தான் chlorine இருக்கு. Okay, chlorine என்ன, you can see in fourth position, that means distance is more. So distance is more means because it's minus I group. Okay, stability will become more. So after fourth, 4 is more stable than third. Then here it is 2 and it is 3. So 3 la தான் என்ன distance ஜாஸ்தியா இருக்கு 2 விட. Then what will be the next option? 1 then 2. So what is the correct answer? 3 1 alla 3 1. Yes, correct answer is 3 only. 3 is the correct answer. Is it clear, guys? Is it clear or not? என்னடா ட்ரீட், ஆர்கானிக் ஃபுல் செஷன், அதுதான் விஷுவோட ட்ரீட். You are eating and watching. Nice. So when you consider stability of carbocation, is it clear, guys? That question clear illa? Do you have any doubt? Then we are moving to stability of carbanion. Okay, we are moving to stability of carbanion. So there is some rule for stability of carbanion also. So rule number 1 is, if electronegativity increases, okay, electronegativity increases, stability of carbanion also increases. So I am writing electronegativity is directly proportional to stability of carbanion. Okay, carbanion. So இது carbocation ஓட just opposite. Then we are checking rule number 2. So here you can see which one is more stable, tertiary, secondary or primary. Tell me quickly, tertiary, secondary or primary. I am from Kozhikode but live in Qatar. Okay. So tertiary, secondary, primary. Which cation is more, which anion is more stable? Which anion is more stable? Primary. After that secondary, then tertiary. This is our second rule. So then we are checking third rule. What is third rule? So stability of carbanion is directly proportional to minus I effect and inversely proportional to plus I effect. Is it clear, guys? So stability of carbocation and carbon free radical order just opposite the stability of carbanion. Is it clear? Is it clear, guys? Is it clear? Which relation rule or example? So, and this one, okay, priority order DNP rule. Okay, first you should check distance, then you should check number, then you should check power. Okay, first you should check distance, then number, then power. Is it clear? I hope it's clear. That I don't know. I want to rule number 1. Okay, rule number 1. Okay. So here, okay, we already discussed here. Adanala. So again, discuss pannala. So நமக்கு தெரியும்டா electronegativity. So சொல்லும்போது I will tell you here. Okay, I will tell you here. We know that triple bond, double bond and single bond இருக்கு. So here I am explaining triple bond means this is sp, this is sp2 and sp3, and we know that electronegativity increases with the increase in electronegativity increases with increase in S character. So if S character increases, electronegativity will also increases. So inge yarukku S character adhigama irukku. So here one more point, electronegativity increases, stability of carbanion will also increases. So I will write another one more point. Stability of carbanion, stability of carbanion is directly proportional to electronegativity. Clear? So you can write inga yarukku electronegativity jastiya irukku. We know that electronegativity S character. Okay, S character inga dhaan jastiya irukku. So electronegativity order. So stability of carbocation. This is stability of carbanion. Okay, is it clear? Clear ada? Ipo clear ah? I forgot your name. Is it clear now? Is it clear da? Is it clear? Someone clear? Someone? Yes, everyone quickly like the button. Quickly hit the like button, guys. Previous slide, this slide, this one. Yes, always. Okay, so triple bond varumbodhu triple bond da. Okay, because S character odathu vechu sollu. Okay, yes. So guys, we are moving to next acidic strength. So guys, what is actually acidic strength means? We can consider, okay, we can consider HA. Okay, it's an acid HA. So HA will produce, okay, HA will produce H plus and A minus. Okay, acid na enna, we know that H release agano. Okay, H anga irundhu pogano, that is actually acid. Okay, S character means hybridization la S percentage evlo irukku, sp la 50% S irukku. Okay, sp2 la 33% S irukku, 33.3%. Okay, 33.33%. Okay, and sp3 la 25% S character irukku. Okay, Okay, I hope it's clear. Yes. Then when you consider acid HA, okay, so HA na H plus form agu, A minus form agu. Okay, it will form H plus and A minus. Okay, H plus A minus form agu. Then what will happen? Da? So it's very simple. I will tell you. So H plus, okay, or acid strong aganuna. Okay, acid strong aganuna. This should be stable. Okay, this stable in the A minus stable irunda, this acid will become strong acid. Okay, this acid will become strong acid. How this strong acid, every strong acid form ago, A minus stable irunda. Okay, stability just A minus order stability just irunda. What will happen? HA will become strong acid. Okay, HA will become strong acid. So that means we can say that acidity is directly proportional to minus I group and inversely proportional to plus I group. So acidity is directly proportional to minus I group and inversely proportional to plus I group. Clear? I hope it's clear. Then we can move to, I will give you one question. You can do this question. Do it quickly. Do the question once again, ma'am. Okay. So I will tell you what is acid means. Acid means it should donate proton. Okay, it should donate proton. So here proton donate பண்ணனும்னா என்ன stable இருக்கணும்? இந்த A minus stable இருக்கணும். Okay, A minus should be stable. So A minus கிட்ட, okay, A minus is attached with a plus I group. So assume that A minus is attached with a plus I group. Then what will happen? So A minus ku already minus charge da irukku. Okay, A minus ku ennada already minus charge irukku. So what will happen? So again or minus I group varumbodhu minus I group oda speciality and it's ready to donate electron. Okay, it will donate electron. So already minus charge irukku. Okay, electron density is more. So again என்ன ஒரு group, okay, பக்கத்துல ஒரு group வந்துட்டு it is ready to give. Again electron means what will happen? Stability will reduces. Okay, so stability என்ன reduce ஆகும். Suppose இங்க we can assume ஒரு plus I group இருக்கு. Okay, minus I group இருக்கு. Then what will happen? Hello Grishma. So minus I group irukku. Then what will happen da? If a minus I group is present means what will happen? Simple da. So minus I group is ready to accept electron. Okay, it is a electron withdrawing group. Then what will happen? Already electron density jastiya irukku. So or minus I group varumbodhu what will happen? Minus I group will withdraw the electron. Okay, so இங்க already electron density ஜாஸ்தியா இருக்கும்போது so here minus I group is ready to withdraw the electron, so stability will increases. So that is the reason acidic strength is directly proportional to minus I effect. If minus I group is there means acidic strength is more and inversely proportional to plus I effect. Is it clear now? Is it clear now? Is it clear now? Then I will give you question எங்க போச்சு? You can do the question guys. I'm English ma'am. Yeah. I will definitely explain in English. Okay. So should I explain again, Oliva, or is it enough? Should I explain again or it is enough? Listen, that question I will tell you. So Ka means acidic strength. Okay, acidic strength they are asking. Ka means acidic strength. Try once, okay, I will explain again. Okay, try once, I will explain again. Oliva, okay. Should I explain the question again or should I explain that concept again? Concept. So I will tell you what is acid means. I will explain again. So listen carefully, okay. So what is acid means? Acid means hydrogen donate pannu. Okay, it will donate hydrogen. So here hydrogen, here HA is donating hydrogen and what will happen? H plus and A minus will form. Okay, H plus and A minus will form. Okay, A minus, what is A minus means? What is A minus means? A minus means already it's accepted electron and electron density is more. Okay, electron density is more in A minus. So assume that 1 plus I plus I group is attached with minus A group. Okay, so here a plus I group. What is plus I group means? It is electron donating group. Okay, it is a electron donating group is attached with minus I group. Okay, then what will happen? Minus I. Then what will happen? Obviously, this minus I will ready to donate the electron. But when you consider A already have high electron density. Okay, A already have high electron density. So again, I is giving electron. So electron density is more. So stability will be less. Okay, stability will become less. So if I group is attached with minus A means stability will become less. Clear? Clear, Ovia? No, Oliva. So when you consider minus I group, so minus I group is an electron withdrawing group. Okay, it's an electron withdrawing group. Then what will happen? So already electron density is more. Okay, so here I will, okay, minus I group will accept that electron density. Okay, so minus I group will accept that electron density. Then what will happen? Stability will increases. Is it clear, guys? Is it clear? Is it clear? Oliva, clear? Clear? Concept clear, Dana? Then I will show you question. Then you can write the question now. Then you can write the question now. Read the question. Ka means acidic strength. Okay, try, just try. Okay, just do a try. Okay, Tanu, or try dana, try pannu. Yeah, I'm good, da. So it's very simple. Acidic strength is directly proportional to minus I group and inversely proportional to plus I group. That's all. You can check and tell me the answer. Try once. Okay, try once and try. So Tanu is saying 2. I also want to check the. I also don't know. Srinivasa is saying 4. Pavitra is saying 2. Here Durga is saying 3. Joseph is saying refuse. Okay. Someone is saying 2, 3. Mana 2, I can see. Yeah, Joseph, it's okay. Three, two, I can see lots of answer. Let me check. Okay, I also don't know. Let me check. So the order of Ka is in following compounds. So inga konjam compounds irukku. So what is acidic compound? Ka means it is, you should check the acidic strength. Okay, Ka means it is acidic strength. Okay, so here what will form? Okay, it's very simple da. H plus will form, O minus will form, H plus will form, OH minus will form, H plus will form, O minus will form, H plus will form, O minus will form. Clear? First step. Okay, acidic strength means it will donate H plus only. Okay, it will donate H plus. Okay. Okay. Is it clear? So everyone quickly like the session. No, which one wrong da? So it's correct only. No, it's so what will happen? I will tell you. So here you can see chlorine is there. Okay, 2 chlorine is there. So I will use different color. Okay, I will use different color. Chlorine is there. Here NO2 is there. Here also NO2 is there. And here also 2 chlorine is there. Okay. So guys, what is the character of chlorine? No. Joseph, it's clear. Correct only da. It is correct only. What is wrong? Tell me what is wrong. It is correct only. Acidity is directly proportional to minus I effect and inversely proportional to plus I effect. It is correct only. It is correct. Yeah. So listen carefully, guys. Listen carefully, guys. Okay. His name. Okay, your name. Okay. Rufus. What is your name? Ruff. I forgot. Oh, name. I thought this. Okay, what is your name? Rufu. Rufu, yes. Rufu. I don't remember your name. What is your name? Okay, got it, got it. Okay, I thought he's talking about this. Okay, he's talking about his name. So, yes, so here you can see what is the character of chlorine. Chlorine is minus I or plus I. Is chlorine is a minus I character or plus I character? Electron withdrawing group or electron donating group? Rufus. Rufus. Yes, obviously chlorine is minus I group. This is also minus I group. This is also minus I group. This is also minus I group. And there is one more group, okay, NO2. What is the character of NO2? Is it electron donating or electron withdrawing? Plus I or minus I? How to find that we already discussed in the starting already discussed in the starting, okay. So yaar plus I group, yaar minus I group nellame explain pannite, just check pannu, okay. So tell me, what is the character of NO2? NO2 is also minus I group, okay. Clear? We know DNP rule. Do you remember DNP rule? Distance, number, power, okay. Distance, number, power, okay. So everything is minus I group means, okay, everything is minus I group, okay. So here inga H plus is forming, O minus is there, okay, H plus and O minus. So this is our first carbon, okay, this is a first carbon la 2 minus I group is there, okay, 2 minus I group is there. Really, Joseph? So then what is the pronunciation? So tell me. So this is the first carbon. So here you can see only one NO2 group. When you check power, NO2 ki da power enna kammiya irukku, powerum kammiya irukku. So what will happen? Chlorine, okay, when you consider chlorine, okay guys, NO2 ki power jastiya irukku, okay, NO2 oda power jastiya irukku. So when you first we will check distance, okay, distance is our first priority, guys. Distance is our first priority. Here also idu first carbon la da irukku, this is also first carbon la da irukku. Distance is our first priority. So distance rendume first carbon la da rendu group me irukku. Then you should check second priority. What is second priority? Number of group is the second priority. Here you can see 2 chlorine is there. That means 2 minus I group is there. Here you can see 1 minus I group is there. Which one is more prior? Either more stronger or which one is more stronger? Which one is more stronger? Tell me quickly, which one is more stronger? Rufus. Am I right? Rufus. Which? Yes, this one is more stronger. So I am writing 2 first. So after that da enna varudhu? First one. So second one, first one. So idu check பண்ணும்போது எப்படி வருது? This is first carbon, second carbon. This is also first carbon. This is also second carbon. Is it clear? So second carbon la first distance பார்த்தாச்சு, ரெண்டுமே 2 தான் வருது. Okay, 2 தான் வருது. Okay. So that second one is number. So number. So here second priority என்ன? Number. இங்க 2 chlorine வருது, இங்க 1 NO2 வருது. So next யாரு வருதுடா? Next high acidic strength யாருக்கு இருக்கு? Next high acidic strength யாருக்கு இருக்கு? Fourth one. Okay, so I am writing 4, then 3. What will be the correct answer? Tell me. What will be the option 3? Option 3, 2, 1, 4. Yes, correct answer. Rufus correct தானே? Rufus clear தானே? Rufus clear தானே? Fourth இல்லடா? Fourth 2, 1, 4, 3. Yes, 3 only. 3 is the correct answer. 3 is the correct answer. Okay, 3 is the correct answer. Is it clear, guys? Do you have any doubt? Is it clear? So, guys, again, who is saying 4 da? Who is saying 4 again? Is it clear? Rudra, yes. Then we are moving to hyperconjugation. So hyperconjugation, so in between the questions ellame irukku, so do maximum questions. Okay, in between the questions irukku, you can do maximum questions. Okay, rubidium enada. So then we are moving to next displacement effect, that is hyperconjugation effect. Okay, then we are moving to next displacement, electron displacement effect, that is hyperconjugation effect. Okay, what is hyperconjugation effect? Basic strength also we discussed. No, just opposite of that. Okay, yeah, we don't discuss. Okay, so adoda just opposite da, acidic strength oda just opposite da varunda. So acidic strength la ena acidic strength directly proportional to minus I da. Inga enna directly basic strength is directly proportional to plus I. Okay, inversely proportional to minus I. And basic character is directly proportional to electron density. If electron density is more means basic character is more. Okay, so electron density is more means basic character is more. So basic strength is inversely proportional to electron negativity. Okay, basic strength is inversely proportional to electron negativity. Next is conjugate base of weak acid is not strong, but that of strong acid of weak. So here I already mentioned. So conjugate ion na enna oru base la irundhu form agra ion illana acid la irundhu form agra ion da conjugate ion. Okay, so inga enna, so acid la irundhu oru anion form aayirukku. Okay, so that is conjugate ion. Conjugate base we will call. Okay, so base avlo important illa, acid da important. Okay, acidic strength is more important. Okay, so nam base miss panniten theriyala. Okay, so yes, we are moving to hyperconjugation. So after hyperconjugation I will give you, after hyperconjugation konjam kuda content poguttunda. So hyperconjugation la like this hyperconjugation is also called, okay, also called no bond resonance, Baker-Nathan effect and sigma pi resonance. Okay, sigma pi effect, sigma pi resonance, Baker-Nathan effect and no bond resonance. Okay, so idu ellame hyperconjugation oda names da. Okay, idu ellame hyperconjugation oda names da. And there is some condition for hyperconjugation. Okay, there is some condition for hyperconjugation. So first one, at least one alpha carbon should be there. Okay, at least one alpha carbon should be there and that alpha carbon should be sp3. Okay, at least one alpha carbon irukanum, that alpha carbon should be sp3. Okay, and second point, that alpha carbon should contain at least one alpha hydrogen. Okay, so alpha carbon contain should one alpha hydrogen. Is it clear da? Is it clear? Lunch break after this session, after this chapter I will give you. So is it clear? So idha condition. You can see hyperconjugation in carbocation, carbon free radical and alkene. You can't see hyperconjugation in carbanion. You can't see hyperconjugation in carbanion. Is it clear, guys? Is it clear? This is very, very, very important. Okay, so last year, like a few years back, PYQ check panna theriyum, idu related the same question vandirukku. So hyperconjugation is applicable only in carbocation, carbon free radical and alkene. Okay, is it clear? Is it clear? Okay, so session paathe class enna saapdalamla, it's very easy. So I will tell you simply. Okay, I will tell you very simply. So ivlo venda, so I will tell you very simply. Hyperconjugation. Okay, they will ask number of hyperhepsi, full name Rufus. Yes, I will call Joe, that is better. Okay, I will call Joe. Yes, So find the number of hyperconjugation structure. They will ask find the number of hyperconjugation structure. So what is the number of hyperconjugation structure? It's very simple da. It's very simple da. Okay. So find the number of hyperconjugation structure. You just check alpha hydrogen number. Okay. Just check alpha hydrogen. எவ்வளோ alpha hydrogen இருக்கு. Pre-slide லடா. அதோட explanation தான். அது உங்களுக்கு தேவையில்லை. So இது ஒரு trick, easy trick இருக்கு. Okay. Okay. So alpha hydrogen. Okay. Alpha hydrogen, number of alpha hydrogen தான் என்ன hyperconjugation structure. அப்போ calculate பண்ணலாமா? So we can start. So find the number of hyperconjugation structure. First molecule, second molecule, third molecule, fourth, fifth molecule, sixth molecule, seventh molecule. You can write. Quickly write in the chat box. Quickly write in the chat box. 1, 2, 3, 4, 5, 6, 7 இருக்கு. So find the number of hyperconjugation structure. Write the number of hyperconjugation structure. Kadikala? It's very simple. Calculate how many 𝐂𝐻𝐴𝐻 లేదు silent ఉండు రా బాబు. So you can write. So how many alpha? This is your carbocation. Okay, this is your carbocation. So carbocation containings. Okay, here you can see this is your carbocation la evlo. Okay, so carbocation la next carbon is this. Okay, this is the next carbon. So in the carbon la evlo hydrogen irukum? 2 hydrogen is there. So you can see 2 hyperconjugation structure. Okay, here I am writing hyperconjugation structure is 2. You can write how many hyperconjugation structure is there. So it's very simple. This is carbocation. So this is alpha carbon and this is also alpha carbon. Okay. So alpha carbon contain alpha hydrogen. Okay. Alpha carbon contain alpha hydrogen. Okay. So 1, 2. Here also 1, 2. So total hyperconjugative structure is 4. Clear? Here I can see. Yes, very good, Aisha. So here this is your carbocation. Okay, this is your carbocation. So and this carbocation contain one alpha carbon. This alpha carbon is not sp3. There is no, very good, there is no alpha hydrogen. So we can say that this carbon is actually sp2. Okay, this carbon is actually sp2. So 0. Okay, next we can consider this one. I think you got the point. Yes, I think you got the point. Yes, is it clear da? Is it clear what is hyperconjugative structure? What is hyperconjugation structure? Yes, because of double bond. Okay, so I already mentioned that. Okay, I already mentioned that. Here I have mentioned that. So at least one alpha carbon that should be sp3 nu sollirukku. Okay, that should be sp3. That is very important. Okay, that should be sp3 nu mention pannirukku. I already mentioned that. Okay, then you can, I will give you next one. So you can write the answer. Okay, you can write the answer. Okay, so it is alkene molecules. Okay, it is alkene molecule. Feeling hungry? So after this hyperconjugation and resonance, I will give you break. It's 12:54 only da. It's 12:54 only da. Now it's 12:54 only da. Now it's 12:54 only da. So everyone like the session. I want to see 300 plus likes. Okay, because I'm doing mega marathon. So I need energy, you know. I need energy. Yeah, health is important. Yeah, definitely health is important. You can have, so you are in your house. So you can have, Amma is there. 6 minutes more for lunch. Who said, Vasant? Okay, so we can check. Okay, we can check. This is your double bond. Okay, so double bonded carbon da. So double bonded carbon ke next carbon. Okay, next to double bond carbon, that is alpha carbon. So this is your alpha carbon. So this alpha carbon contains 3 alpha hydrogen. So hyperconjugative structure is 3 here. So when you consider this one, this is a alpha carbon and this one is also alpha carbon. This alpha carbon contains 3 alpha hydrogen. This alpha carbon contains 2 hydrogen. So total hyperconjugative structure is 5. So when you consider this one, this molecule, so this is your alpha carbon and this one is also your alpha carbon. So 3, 3, 6. Hyperconjugative structure is 6. Is it clear, guys? Is it clear? Is it clear? Then we can move to next question. Okay, next question, next concept. So this is free radical. Write the hyperconjugation structure of free radical. Write quickly in the chat box. And pre-slide ellame like. So, idoda explanation da. So, explanation is actually not necessary. So, here, okay, pre-slide and idukku what difference, okay, I will tell you. This is carbocation, okay, ellame carbocation. And this is double bond, alkene, okay, this is alkene. And this is carbon free radical. Avloda difference. Onnume difference illa. Carbon free radical and carbon free radical is there, carbocation is there, alkene is there. Okay, because hyperconjugation is applicable for carbocation, carbon free radical, and one more point, that is free radical and alkene. Is it clear? Yes, I can see answers. Very good, guys. Very good. I hope it's clear. Then we can move to application of hyperconjugation. So, application of hyperconjugation. Okay. Application of hyperconjugation. First one is stability of carbocation and carbon free radical and stability of carbanion to compare bond length. Okay. So, first one is stability of carbocation and carbon free radical. Which, okay, here you can see 3 carbocation is there. Okay, this is carbocation 1, this is 2, this is 3. So, write the stability order. Okay, listen carefully. Write the stability order. It's very simple. Just calculate the number of hyperconjugative structure. So, how many hyperconjugative structures are there? Here 1, here also 3, here also 3. So, here I am writing hyperconjugative structure is 6. Sorry, here it is 9. Okay, so here tell me how many hyperconjugative structure is there. So, this is your carbocation. This is your alpha carbon. This alpha carbon contain 3 hydrogen. This alpha carbon also contain 3 hydrogen. Total hyperconjugative structure is 6. When you consider third carbocation, so third carbocation only 1 alpha carbon is there, 1, 2, 3. So it contains 3 alpha hydrogen. So hyperconjugative structure is 3. Which one is more stable? Which one is more stable? It's very simple. Number of hyperconjugative structure is more, stability will increases. Okay, number of hyperconjugative structure is more means stability will also increases. Okay, so I'm writing here number. I'm writing here number of hyperconjugative structure is more means stability is also increases. Stability is also more. Is it clear? Is it clear? So which one is more stable? This is more stable than this, than this. Okay. Is it clear? Is it clear? Oliva, is it clear? Diva, Divya, Pavitra, Susmita, Guru, Srinivasa, Aifa, Rufas, Joe. I will call Joe. Joe. Is it clear? Is it clear? I hope it's clear. Then here also, here you can check. Here you can check. Tell me which one is more stable. Which one is more stable? Do you have any idea? Second one, which one is more stable? Which one is more stable? Which one is more stable? First one or second one? Which one is more stable? Yes, Preeti? Both. Both. Guys are saying Apur. You skipped. No Apur. Apurva or Apurv? Apurav. Yes, Apurav. I'm saying Apurv. Apurav. Apurvav. Yes. You guys are saying one is more stable. Let me check. Okay. Let me check. So here, how many alpha hydrogens are there? Here 1, 2, 3. Here 1, 2. Here also 1, 2, 3. Here also 1, 2. Here also 1, 2. So hyperconjugative structure is actually 5. Here also hyperconjugative structure is actually 5. Then 5, 5. Then what should I do? What should I do? Here you can see, two groups. Okay, two groups you can see. Okay, NO2 and CN is there. Okay, NO2 and CN is there. Which one is more stable? So just, okay, neenga enna pannanum? You should check if hyperconjugative structure is same. Okay, if hyperconjugative structure is same, then you should check inductive effect. Inductive effect. Okay, so what is that? NO2, it is minus I group, and CN is also a minus I group. So I'm going to write stability of carbocation is directly proportional to minus I and inversely proportional to plus I. Do you remember? This relation? Do you remember this relation? Yes, got it, Aisha. Do you remember this relation? Stability of carbocation is directly proportional to minus I and inversely proportional to plus I. Okay. So, idhula power da DNP rule paakalam. DNP rule la, so distance, same distance da, number 1 da, NO2 1 is there and CN is also there, you can see 1. Then you should check power. So power yarukku jastiya irukkuda? Power yarukku jastiya irukku? NO2 ka or CN ka? NO2 or CN? Yes, NO2 ki da power jastiya irukku. Okay, NO2 oda power da jasti. So then I can write this is more stable. Is it clear, guys? Is it clear? NO2 is more stable. Is it clear? Clear? NO2 is more stable. I hope it's clear. Then here ingiyum konjam questions ella irukku, so you can do all these questions. Then we are moving to resonance effect. So ipo break venuma illana resonance effect in the chapter mudinjadukku appuram break poduma? Ipo break venuma illana suppose இருக்குதா CN la more stable, suppose NO2 2 la irunda, yes number. Okay, DNP rule check பண்ணலாம். Okay, apurva so DNP rule தான் check பண்ணனும். Okay, so number ஜாஸ்தியா இருந்தா that is more stable. Okay, after finishing break வேணுமா இல்லனா after the break வேணுமா? Complete the chapter, ma'am. Chapter finish பண்ணலாம். When the chapter will complete, maybe 1 hour la we can finish this chapter. After chapter, yes. So lunch, ma'am. So most of the students சொல்றது என்னன்னா chapter finish பண்ணதுக்கு அப்புறம் lunch போதும்னு. So resonance honaika bandu, ma'am. Yes, resonance is also there. I want to take resonance also. Okay, so we can take resonance. Okay, break after that. Okay, After chapter. Okay, yes, most of the students are saying after chapter we can take break. I'm sorry, Ganesha. Okay, then we can start. So, resonance effect. Okay, we are discussing about resonance effect. So, what is resonance effect? What is resonance effect? So, when a single Lewis structure, so I will tell you, okay, what is resonance. So, when you consider benzene structure, okay, when you consider benzene structure, which one is benzene structure, okay, which one is benzene structure? So, tell me, which one is benzene structure, A or B? This is A, this is B. Which one is benzene structure? Yes, application completed, application completed. This only the application. Stability. Stability. Both is actually benzene only. Okay, so this is actually resonance structure. Okay, so when you consider some molecule, okay, we can't explain the property of that molecule using one structure. Okay, we can't explain the properties of that molecule using one structure, so we will use different structure. Okay, we will use different structure, maybe more than one structure. Okay, 2 structure, 3 structure for that. So that is actually resonance structure. Okay, that is actually resonance structure. So when a single Lewis structure is incapable to explain the properties of molecule, then we need 2 or more structure. Okay, we need 2 or more structure to explain the property of that structure. Okay, we will use 2 or more structure. That is actually resonance. Okay, so these structure are called resonating structure. Okay, these structure are called resonating structure. I'm confused. You told electron withdrawing. Carbocation is directly proportional to electron donating, right? So I will tell you. Okay. So what is your doubt, Aisha? Carbocation is directly proportional to electron donating. So electron donating means that is a positive I, and inversely proportional to minus I group. Yeah, correct. Where I told it, where I told. Where? Oh, it's correct. So correct. Acidic character சொல்லும்போது confuse ஆயிட்டேன். Correct. It is correct only. Plus I and minus I. Correct. Okay. Then upper answer லையும் சின்ன like change வரும்டா. So here you can see minus I character. Okay guys, listen carefully. So minus I minus K character. The stability of carbocation is directly proportional to minus I and inversely proportional, directly proportional to plus I and inversely proportional to minus I. So this is also minus I, இது minus I group தான். So power பார்க்கும்போது இங்க தான் power கம்மியா இருக்கு. Okay, so it is more stable. Okay, this molecule is more stable. Yes, correct Aisha, correct. Clear? I hope it's clear. Then guys, resonance. Yes, correct தான். So அங்க ஹரிபரியில அப்படியே தப்பு பண்ணிட்டேன். Okay, yes, clear? Yeah. So resonating structure are hypothetical structure but must be valid Lewis structure. So resonating structure எப்படி இருக்கும்? It's a hypothetical structure. Okay, it is just hypothetical structure, but என்ன இருக்கும்டா? But it is valid Lewis structure. So இது actually hypothetical da. Okay, so it's a imaginary structure. Okay, but it should be obey Lewis structure. That means carbon க்கு 4 bond தான் இருக்கும். ஓகே இல்ல இது ஒரு இமேஜினரி ஸ்ட்ரக்சர் தானே, ஹைப்போதெட்டிக்கல் ஸ்ட்ரக்சர் தானே, அப்போ ஒரு 5 பாண்ட் போடலாம், அப்படி போட முடியுமா? நோ, இட் இஸ் நாட் பாசிபிள். ஓகே எஸ் இட் இஸ் எ இமேஜினரி ஸ்ட்ரக்சர், பட் என்ன போட முடியாது? So it should follow Lewis structure. Okay, it should follow Lewis structure. Okay, so that's very important. Resonance hybrid is the actual structure. Okay, then I will tell you what is resonance hybrid and all. So resonance hybrid is a stable structure. So stable structure means energy is less. Okay, so energy is less. Yes, I am Malayalis. So resonance hybrid is lowest energy, so it is more stable. Okay, resonance hybrid or stability is more. Why? Because energy is less. Okay, why? Because energy is less. Okay, then idoda resonance structure we can draw. Okay, we can draw the resonance structure of this molecule. So carbon is there. Yeah, carbon is there. So two oxygens are there. Okay, 2 oxygens are there, it's identical. Okay, so I am drawing the same oxygen here, 1 oxygen, 2 oxygen. So inga oxygen mele negative irukku, adu inga varubodhu inda oxygen mele negative irukku. Okay, and inga double bond irundhathu, adu inga double bond aita. Okay, and carbon mele positive, because 1 carbon da irukkala. So here you can see 2 oxygen. What is this change between, what is the difference between these two structure? What is the difference between these two structure? Tell me, is there any difference da? Is there any difference? Is there any difference? Break, ma'am. Preeti, most of the students in the session in the chapter முடிஞ்சதுக்கு அப்புறம் break போதும்னு சொல்லிருக்குடா. So that's the reason. Okay, Ganesha will cry. So position of pi electron, but actually this is this two structure are same only, same molecule, there is no difference. Okay, so charge same da, 2 inga double bond irukku, inga double bond irukku, inga 1 oxygen mela negative charge irukku, inga 1 oxygen mela negative charge irukku. Here you can see carbon mela positive, here also you can see carbon mela positive is there. Okay, so this is actually resonance structure. So I am going to draw the hybridization structure. Okay, hybrid structure. So partial double bond. Okay, I am drawing partial double bond. Carbon, only 1 carbon is there and it is positive charge. Okay, it is positive charge. Here you can see only 1 negative charge is there. Okay, so only 1 negative charge is there. So I can't do pool போட முடியாதுடா. So இது இப்போ finish ஆகும்டா, இப்போ finish ஆகும். Okay, so என்ன minus 1 negative charge, 1 negative charge தான் இருக்கு. So இங்க total எவ்வளோ oxygen இருக்கு? 2 oxygen இருக்கு. So 1 negative charge is sharing 2 oxygen. So here also 1 negative charge is sharing 2 oxygen. This is actually resonance hybrid. Okay, this is actually resonance hybrid. Okay, this is actually resonance hybrid. Resonance hybrid. Clear? So this is the resonance. It has same structure. Okay, this is the same structure, but in a double bond la change vandirukku, double bond oda position la சின்னதா change வந்திருக்கு, அவ்வளோதான் difference. Okay, அவ்வளோதான் difference. அதுதான் என்ன resonance structure. This is actually resonance structure. So இங்கேயும் double bond இருக்கு, இங்கேயும் double bond இருக்கு. Partial double bond draw பண்ணிட்டேன். I am just drawing the partial double bond. This is actually resonance hybrid. Okay, this is actually resonance hybrid. So inga you can see only 1 negative charge is there. Okay, 1 negative charge is there. This oxygen, okay, oxygen, 2 oxygens are there. So this oxygen is sharing 1/2 negative charge. Okay, minus 1/2. So this also sharing half negative charge. Okay, clear? பாரதியாரே அப்படி சொல்லியிருக்காடா. ஸோ இதுக்கப்புறம் இப்போ முடியும்டா, ஒரு half an hour, ஒரு 1:30 1:45க்கு சாப்பிட்டா போதும்ல. என்னடா ஸோ இப்போ ஃபினிஷ் ஆகும்டா. So when you consider CO3, okay, CO3. So when you consider CO3, so CO3 the high resonance structure we can draw. Okay, carbon is there, 1 2 3. Oxygen is there. So either double bond oxygen. So either endome single bond oxygen. In the single bond oxygen negative charge. So next time drawing, carbon is there. So 𝐂𝐴𝐤𝐿. So here it is double bond oxygen. It is single bond oxygen. It is also single bond oxygen. Negative charges there. Okay. So next. What is next? So I will draw next is, this is actually resonance structure. Okay. So this is actually resonance structure. I want to complete organic chapter da. So next enada, carbon. So oxygen, double bond, and ingot oxygen. You can see 2 negative charges are there. Okay, 2 negative charges are there. So listen carefully. அப்ப எப்படி பண்ணணும்? 2 negative charge இருக்கு, 3 oxygens are sharing. So 2 negative charge இருக்கு, 3 oxygens are sharing. So 2 negative charge இருக்கு, 3 oxygens are sharing. Is it clear? Is it clear guys? CO3 2 minus soda resonance structure, resonance hybrid எல்லாமே clear தானே? Is it clear? Then we are moving to next. That is condition for resonance. Okay, so resonance follow pananuna, it should obey some condition. Okay, it should obey some condition. So first condition is all participating as atom must be in same plane. Okay, all participating atom must be in same plane. And next is conjugation. What is conjugation? Conjugation, you can see, okay, you can see negative single double, positive single double, lone pair single double, free radical single double, alternate double bond. Okay, you can see it's very important guys. So proper parunga, where you can see conjugation. If negative single double is there, conjugation is there. You can say positive single double is there. Yes, conjugation is there. Lone pair single double is there. Yes, conjugation is there. Free radical single double is there. We can say conjugation is there. Alternate double bond is there. Conjugation is there. There is one more condition. That is back bonding. Okay, back bonding. What is back bonding da? So here B contain, okay, A and B contain 2 lone pair. So B is ready to donate that lone pair and A is ready to accept that lone pair. A should have vacant orbital. A kitta enna irukku? Vacant orbital, you can see, and B contain lone pair of electron. Okay, so in the elements illa in the like conditions ellame irundha, we can say it will obey resonance. Okay, it will show resonance. Yes, definitely I will share the PDF also. Okay, so type of conjugation I will explain here. Okay, direct. So resonating structure. Okay, resonating structure da. So listen carefully. Minus single double. Okay, minus single double, resonance is there. Okay, resonance is there. Then what will happen? Okay, back bonding, explain again ma'am. Okay, I will explain again. Back bonding means here we can just assume. Okay, so you can see adjacent side la there is 2 atom A and B. So A la what is there? A contain vacant orbital and B contain lone pair of electron. So here B is ready to donate that lone pair of electron, and when you consider A is ready to accept that electron. Okay, A is ready to accept that electron. Clear? Okay. Then we are checking, draw the resonance structure. How we will draw the resonance structure? How we will draw the resonance structure? Negative single double, resonance is there, okay? Negative single double means resonance is there. Then what will happen? This negative charge inga varum. So this double bond break aayi oxygen kitta pogum. So I will draw. Inga it will form double bond. And oxygen mela it will form negative charge. Okay, clear? So this is the resonating structure. Okay, then what is that resonating structure of this molecule? So we know that oxygen is more electronegative. So in the double bond break agum, oxygen pakkam pogum, because oxygen is more electronegative. So this double bond will break and here it will form double bond. Okay, so idudha. So resonance eppadi irukunda? So here it will form double bond. Okay, it will form double bond. Clear? It will form double bond. I hope it's clear. Then we are checking here positive single double. Yes, resonance is there. Positive single double, resonance is there. So what is the resonance structure? Simple da. So this double bond will break and it will form double bond here and it will form positive. Okay. So what is this? 1, 2, 1, 2. 3, 4. Am I right? 1, 2, 3, 4. Yes. It will form double bond here and positive charge here. Clear? Clear? Resonance. Yeah, she is also in Kerala. Larin Mamo also in Kerala. She is also in Kerala. So I hope it's clear, Illada. Clear? Second please, second one. So yeah, so when you consider second one, okay, second one is alternate double bond. Okay, alternate double bond la inga enna nadagum, we know that oxygen is more electronegative. Okay, oxygen is more electronegative atom. So this double bond will break and adu enna oxygen ku pogum and in the double bond break aayi adu inga double bond form agum. Yes, inga na double bond again I drew. Okay, inga 1, 2, 3. So inga oxygen, this is the structure. Okay, clear? O negative, yes, oxygen mela negative varum. Clear danada? Again ma'am. Okay, so I will repeat again. So what will happen? So here you can see alternate double bond. Okay, here you can see alternate double bond. What will happen? So this double bond will break. Okay, double bond will break and oxygen will minus O minus. Okay, oxygen will form O minus. And this double bond break aayi, electron will come this side. So it will form double bond. So inga double bond form aayirukku, in the double bond break pannite it will form O minus. Is it clear guys? Pakka. Yes. So then, okay. Draw the resonating structure. Guys, are you making the notes? So, guys, are you making the notes? Guys, are you making the notes? Guys, are you making the notes? Now at least break, ma'am. Okay. No, at least break. Eda, ippo idu finish agum. Okay, idu ippo finish agum. Idu finish aanadukku appuram podulle. Ippo oru half an hour. Okay, half an hour. Ganesh, I can understand that. Half an hour. You want break, guys? You want break? You want break, guys? Appo engla pidikadada? Hari, engla pidikada? So do you want break? Do you want break? Break please, Preeti. Then I will give you oru evlo minutes break venu. Lunch break evlo time venu. 20 minutes? 20 minutes is enough. 20 minutes. So everyone is crying for break da. So what should I do? Everyone is crying for break. So I will give you 15 minutes lunch break. Okay, I'm asking for lunch break. Half an hour. Half an hour. 20 minutes podulla. Half an hour ke edukkuda. So 20 minutes போதும்ல, half an hour எல்லாம் எதுக்குடா? Thirty minutes, 20 minutes. So I will give you 25 minutes. Okay, I will give you 25 minutes. So yes, finish பண்ணனும்ல, finish பண்ணனும்ல, complete organic finish பண்ணனும்ல. So 25 minutes I will give you. So சீக்கிரமா போய் சாப்பிட்டு கரெக்ட் டைம்க்கு வரணும். And light target இருக்கு. Okay, 45 minutes அது என்னடா ஸ்கூலாடா? So இப்போவே போய் ஸோ டார்கெட் லைக்ஸ் எல்லாம் இருக்கு. ஸோ வரும்போது இப்போ எவ்வளோ லைக் ஆயிடுச்சு? 172, 225 லைக் ஆகணும். ஓகே, ஓகே. ஸோ போய் ப்ளீஸ் ரவுண்ட் ஆஃப் 230. Oh my god, I have to go down now. Okay, என்னடா இது சின்ன குழந்தை மாதிரி. ஓகே, ஸோ சீக்கிரமா போய் வரணும். ஓகே, போய் வா. சாப்பிட்டு வந்துட்டீங்களா? Anyone poor in biology? But you have to physical chemistry, physics, friend, deal, okay. Deal paka. So on 100 likes. So 200 likes, 225 likes. 225 like ஆயிடுச்சா? 225 like தான target. Let me check. 25 likes. 220. I'm sad. I'm so sad. Start music. Music. Only you attempt my physics, chemistry. I will attempt your physics, chemistry. What is happening here, guys? What is happening here? What is happening here? Come on, I want to see everyone. So நீங்க already promise பண்ணிட்டு போனது. So எல்லாரையும் எனக்கு பார்க்க முடியணும், okay? எல்லாரையும் எனக்கு பார்க்க முடியணும். ஸோ ஆல்ரெடி ஓகே மேம் ஷார்ப் ஜாயின் பண்ணுவேன். எஸ், டைம் முடிஞ்சாச்சு. ஸோ இது வரைக்கும் 225 லைக்கும் ஆகலை. ஐம் ஸோ ஸ்ட்ரெஸ்ட். ஸ்ட்ரெஸ் பஸ்டர் மேம். ஓஹோ, டீலிங் மேம். ஓ, டீலிங்ஸ். டாக்கிங் அபவுட் யுவர் டீலிங்ஸ். ஓ, டீலிங்ஸ். ஓகே. ஸோடா எவ்வளோ டைம் எடுக்கும்னு எனக்கு தெரியாது. I'm a little low, ma'am. Ayyo, don't say like that. I think, yes, my voice is now available less. The mic கொஞ்சம் கீழே இருந்ததுனால. Now, set இல்லடா? Set தானே? Came 3 minutes earlier. Yeah, ma'am, came 3 minutes earlier. ஸோ நான் வெளியே போய் சாப்பிட்டு வந்திருக்குடா. நீங்கள் உங்களோட வீட்டில் தான் சாப்பிட்டது. இது வரைக்கும் யாரும் கம்ப்ளீட்டாக வரல. உங்களோட வீட்டில் தான் இருக்கு. ஸோ ஹாய் ஒலிவா. எஸ் ஹேமா. ஸ்டில் மை வாய்ஸ் இஸ் லோ. வை ஐயோ. ஹலோ. எஸ், ஐ வாண்ட் டு சி ஹை எனர்ஜி மேம். எஸ், ஐ ஹேட் லஞ்ச். ஸோ சப்பாத்தி. வந்துட்டேன் மேம். எஸ், வந்துட்டேன். எங்க போச்சு எல்லாரும் கமான் கியூக்கா. எஸ், வாய்ஸ் கிளியர். எஸ், ஐ ஹேட் லஞ்ச். ஸோ டெல் மீ, உங்களுக்கு இன்னைக்கு ஸ்பெஷல் என்ன இருந்திருக்கு? ஸ்பெஷல் இன்னைக்கு விஷு. உங்களோட ஸ்பெஷல் சொல்லுங்க. எஸ், திஸ் இஸ் இனஃப் ஃபார் ஆர்கானிக். ஸோ இனஃப்னா கம்ப்ளீட் 100. லைக் நீங்கள் இதுக்கப்புறம் எவ்வளோ ப்ராக்டிஸ் பண்ணுற அது எல்லாமே டிபெண்ட் பண்ணிட்டு இருக்கும். ஸோ பட் ஐம் ஸ்டார்டிங் ஃப்ரம் ஸ்க்ராச். ஐ டிட் பர்ஃபெக்ட். ஓகே, நான் எல்லாமே பர்ஃபெக்டாக பண்ணியிருக்கு. இது நெக்ஸ்ட் உங்களோட இதுதான். ஓகே. கீரை. வாட் இஸ் கீரைடா? கீரை இஸ் லைக் லீஃபி வெஜிடபிள். எஸ், பிரியாணி. கர்ட் ரைஸ் பிரியாணி மேம். என்ன பிரியாணிடா? வெஜிடபிள், சிக்கன், மட்டன் பிரியாணி. ஃபீலாக இருக்குடா பிரியாணி எல்லாம் சாப்பிட்டதுக்கு. ஓ, ஸ்பினச். புளிக்குழம்பு. எஸ், புளிக்குழம்பு. டீ மேம். டீயாடா? போய் சாப்பிட்றா. சிக்கன் பிரியாணி. டைகர் ரைஸா? வாட் இஸ் தட்? ஹைதராபாதி தம் பிரியாணி. நான் பண்ணி இன்னைக்கு நீ பிரியாணி சாப்பிடல, எனக்கு தெரியும். இன்னைக்கு நீ பிரியாணி சாப்பிடல, எனக்கு டெஃபினட்டா தெரியும். நீ சாப்பிடல, சும்மா சொல்ற. யூ ஆர் ஜஸ்ட் சேயிங். யூ ஆர் நாட். யூ டிட் நாட் ஹேட் பிரியாணி. That I'm sure. Mutton gravy ah. Mutton என்ன மட்டன் எங்க போச்சு? மட்டன் கிரேவி மட்டும் தான் இருக்கா? புளியோகரை. 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 Oh, புளியோகரை. That I don't know. புளியோகரை. Okay, we can start. Ada. My mouth is watering now. நான் சாப்பிட்டது சப்பாத்தி, நீங்க பிரியாணி, அதுவும் ஹைதராபாதி பிரியாணி. நான் சாப்பிட்டது சப்பாத்தி. ரொம்ப கஷ்டமா இருக்குடா. White rice with bean curry. Okay, super. Fish kulambu. Oh, fish kulambu. I like fish kulambu. I'm a non-vegetarian. எனக்கு ஃபிஷ் குழம்பு நல்லா பிடிக்கும். புளி சாப்பாடு. ஓகே, புளி சாப்பாடு. புளி தெரியும், புளியும் தெரியும். Let's start. Yes, Rudra is asking. Let's start. So guys, how to draw the resonating structure? There you can see conjugation. Conjugation is very important. Yes, Jenny, நான் உன்னை நோட் பண்ணி வச்சிருக்கு. ஓகே, Jenny உன்னை நோட் பண்ணி வச்சிருக்கு. Egg, prawns, biryani. Yes, I am Malayali. Egg, prawns, biryani, mutton gravy, puli kolambu. Okay, nice. Oh, Ganesha, சாப்பிட்டாச்சா Ganesha? Ganesha அவ்ளோ மேம் இப்போ கொடுக்கலன்னா நான் இது போயிடும் நல்லா சொல்லியிருக்கு Ganesha. Okay, we can start. So எல்லாருமே குயிக்கா செஷன் லைக் பண்ணுங்க. ஸோ நம்மளோட டார்கெட் 125 தான். இப்போ 195 தான் இருக்கு. 125. போட்டிக்கறி. யா, ஐ லைக் போட்டிக்கறி. மட்டன் போட்டி. எஸ் வி ஆர் பிளானிங் 19th ஃபுல் டே கிளாஸ் இருக்கும். இல்லைன்னா 20th இருந்து உங்களுக்கு கம்ப்ளீட் என்ன பிசிக்ஸ், கெமிஸ்ட்ரி, பிசிபியோட கம்ப்ளீட் மேரத்தான் இருக்கு. ஓகே, எஸ் ஐ வில் டூ ஒன் இன் ஆர்கானிக் அண்ட் ஆர்கானிக் ஃபர்ஸ்ட் முடிக்கட்டும், இதுக்கப்புறம் இன் ஆர்கானிக் அண்ட் பிசிக்கல் பார்க்கலாம். ஓகே, ஸோ கம் ஆன் கைஸ். ஸோ how we will draw resonating structure of this molecule? What is this da? This is phenol. Okay, phenol oda resonating structure எப்படி draw பண்ணலாம்? Tell me quickly. So we know that oxygen contain lone pair. Okay, we know that oxygen contain lone pair. Then what will happen? So this lone pair என்ன இங்க வரும் and இங்க இருக்கிற double bond என்ன charge ஆ மாறும். Okay, negative charge ஆ மாறும். Clear? Negative charge ஆ மாறும். Then next என்ன நடக்கும்? So here you can see double bond OH. Okay, so here you can see negative charge, here double bond. Next என்ன நடக்கும்டா? Next, so here you can see this charge will become, okay, this charge will become double bond and this double bond will become charge. Okay, so next step la enna nadakkum? It will become double bond and it will become charge. பாக்கி எல்லாமே சேம். ஓகே, டபுள் பாண்ட் ஓ இருக்கு அண்ட் இங்கேயும் டபுள் பாண்ட் இருக்கு. ஸோ வாட் இஸ் த நெக்ஸ்ட் ஸ்டெப்? ஓ ரியலி கிஷோர். ஸோ what is the next step? Simple da. So this charge will become negative double bond and this double bond will become negative charge. So I'm writing next step here. Okay, so இப்படி தான் resonance structure represent பண்ணணும். Okay, resonance structure dope பண்ணும்போது you should use this double headed arrow. Okay, you should use this double headed arrow. Okay, So inga vandirukku, you can see double bond OH is there. So this negative charge will become double bond. Okay, this negative charge will become double bond and this double bond will become negative charge. Okay, then what is next? This negative charge will become double bond. So double bond inga பக்கத்துல வராது. So it will become என்ன திருப்பி lone pair மாறிடும். அப்ப என்ன நடக்கும்? So 1 2 3 single bond OH. So last you will get phenol. Okay, you will get last phenol. Is it clear? So here you can see 1 2 3 4. Okay, 4. Okay, 4 structures you can see. Okay, you can see 4 structures. Okay, negative only, negative charge only, not positive, negative only, negative charge only, not positive, negative charge only. Okay, because what is happening da? So it is accepting electron less, so obviously it will form negative charge. Okay, clear? So I hope it's clear. So here you can see, it's very important guys. Here you can see, where is arrow mark? This color I will use. So you can see negative charge on this side and this side. Okay, so that means I can say that you can see the negative charge. Okay, you can see the negative charge on ortho para position. Okay, you can see the negative charge on ortho para position. So I can say that resonance. Okay, resonance ku enna effect irukku? Enna ortho para directing. It is actually ortho para directing. That I don't know money. So I want to finish all the organic chapter. That's all. Okay, so idu ennada? Ortho para directing. It is actually ortho para directing. Clear? Is it clear? So when you consider resonance structure, okay, so resonance structure ku stability rules irukku. Okay, resonance structure ku stability rules irukku. First stability rule, okay, neutral resonating structure is more stable than charged resonating structure. Okay, video is not loading. I think it's visible only. It's visible. It's visible. I think it's clear. Ganesha, it's clear. Ma'am, in my college, I don't understand this mechanism. Ma'am, but now it is full clear. Okay, da. Okay, so happy. So, neutral resonating structure. Okay, which resonating structure is more stable? We are going to compare. Okay, so when you consider neutral resonating structure, it is more stable. Okay, neutral it is actually more stable. Okay, sometimes it's loading. Okay, that I don't know what happening. Okay, I think here it is perfect only. So technician check பண்ணியாச்சு. So neutral resonating structure is more stable than charged resonating structure. Second one, stability directly proportional to number of pi bond electron. Okay, if pi bond. Thank you so much, Latika. Thank you so much for your wishes. Okay, thank you so much, and I wish you the same. Okay, I wish you Aishwarya Samridhamaya Vishwashamsagal to everyone. Okay, yes. So stability is directly proportional to pi bond. Okay, stability is directly proportional to pi bond. Yes, I will tell you. Okay, first you should learn the rule, then I will tell you with examples. Okay, so stability directly proportional to negative charge on stable atom. What is negative charge on stable atom? When you consider oxygen contain negative charge, carbon contain negative charge. Which one is more stable? I will tell you. Kashifa, no worries. Okay, I will tell you again. Okay, so stability is directly proportional to negative charge stable on atom. Okay, So thank you. So oxygen minus and carbon minus, which one is more stable? Tell me which one is more stable. Oxygen minus irukku, carbon minus irukku. Which one is more stable? Tell me quickly. Yes, oxygen is more stable because oxygen is more electronegative. Okay, oxygen is more electronegative. Next point, stability is directly proportional to positive charge on stable atom. So when you consider O plus and C plus, which one is more stable? O plus and C plus, which one is more stable? Which one is more stable? Oxygen plus இல்லனா carbon plus எது more stable இருக்கு? Jenny உன்ன நான் நோட் பண்ணி இருக்கு Jenny. C plus is more stable. Okay, yes, C plus is more stable. That is stability directly proportional to positive charge on positive charge stable on atom. Okay, so is it clear? Then we are moving to next point. Charge separating resonating structure are less stable. That means, okay, so I will tell you. So when you consider charge separating, so when you consider opposite charge, okay, opposite charge. So opposite charge, when you consider positive and negative is more stable in near carbon, okay, in adjacent carbon, okay, it is more stable in adjacent carbon. Is it clear? Positive because ma'am, Jenny பாவம் எனக்கு தெரியுதுடா. So positive and negative adjacent carbon la vanda, near carbon la vanda, because it is opposite charge will attract, so it is more stable. When you consider, okay, so when you consider plus and negative, okay, positive and negative distance la vanda, okay, distance irunda enna, it is least stable. Okay, it is least stable. Okay, because distance irunda, it is least stable. Positive, it will repel. Okay, positive negative means it will attract. Okay, so positive negative and a distance la irunda, it is least stable, and pakkathil irunda, it is more stable. So when you consider like charge on adjacent atom, this is atom, okay, are less stable. So that means like charge means positive, okay, positive adjacent carbon la irunda, it is less stable. Negative less carbon means pakkathil irunda, it is less stable. And negative and lone pair is also negative charge. Okay guys, lone pair is also negative charge. So lone pair pakkathila vanda, it is also less stable. Fifth point, no, okay, 1 2 3 4 5. Okay, so positive and negative charge irukku, adu pakkathila vanda, it is more stable because positive and negative opposite charge will attract, so adu pakkathila vanda, okay, so adjacent carbon la irunda, it is more stable. I am studying organic chemistry first time this one lecture, so this lecture is very useful for you and you should practice. Okay Ramu, you should practice maximum. Then I will give you a question. Guys, are you ready? So we can check. I think Kashifa is clear, yes? Yes. Lone pair and positive is more stable. Then here is the first question. You can do. First point at a charge. First point here you can see. This is charge molecule. There is no, it's a neutral molecule. So neutral molecule is more stable than charge molecule. That's all. That is the first point, Kashifa. So here you can say which one is more stable. Okay, this is first one, this is A, this is B. Okay, this is A, இது எல்லாமே A. Okay, இது B, greater equal to greater or less than, அதுதான் சொல்லணும். One is saying one is more stable. Okay, I am writing your answer. Okay, second one, which one is more stable? Second one, which one is more stable? Second one also you guys are saying A. So I will write A. I don't know. I'm just writing your answer. Okay. Third one. What is third one? Third one. Which one is more stable? Third one. Which one is more stable? A. This also you guys are saying it is more stable. I'm writing your answer. That's not my answer. Okay. Third, 3. Third, B. Okay. A. Oliva is saying A. Some students are saying B. So anyway, I will check. Okay. So we can check our first rule. So what is our first rule? Neutral atom is more stable than charged molecule. Okay. So it's charge. So it is neutral. So it is more stable. When you consider this molecule, here also you can see charge is there and this is neutral, and here also you can see one pi bond is also there. Pi bond is there means it is more stable. Correct. This is also correct. When you consider this one, so you guys are saying which one is more stable? This is A stable, this is A stable, this is when you consider carbon mele negative charge irukku, inga oxygen mele negative charge irukku. Which one is more stable da? Which one is more stable? Carbon mele negative charge irukku, and here you can see oxygen contain negative charge. Which one is more stable? Obviously this one is more stable. Okay, so this one is more stable. Oxygen negative is because it's highly negative, so it is more stable. Then I will give you one more question, so you can write the answer. Okay, yeah, correct answer. B is the correct answer. My pi is there. Okay, let me check which one ada. You're saying pi is there. Yeah, here also one pi is there. Here also one pi is there. So pi is 1 only. So guys, in between the questions you can do. Okay, you can do after the session. Okay, so tell me what is the correct answer here. What is the correct answer? Vanita saying B. Ganesha saying B. Shalini B. Kashifa B. Bunny. Pi bond. Gautu 1. Gautu saying 1. We'll check all the rules here. Okay, we will check all the rules here. Here I can see B 2. Okay, your answer is B2. I can see lots of answers. A, B, 1. Okay, let me check. Okay, guys, ready? So, what is the question? Which is least stable? Okay, which is least stable, they asked. Okay, so they asked which is least stable resonating structure. Okay, we can check. What is the first rule? Neutral atom is more stable. So, here you can see charge is there, charge is there, charge is there, charge is there. Ellathilayum charge irukku. So, first rule fail aidichu. Second rule. What is second rule? Do you remember what is second rule? So, second rule, tell me second rule in the chat box. Tell me in the chat box. I am waiting. So, second rule means pi. Okay, pi bond increases, stability increases. So, here you can see 2 pi bond is there. Okay, here also 2 pi bond is there. Here also one pi bond, here also 1 pi bond. So this is not the correct answer. This is not the correct answer. They are asking least stable. Here you can see 2 pi bonds are there. That means it's more stable. Okay, pi bond increases, stability increases. So I can eliminate option A and option B. Okay, I can eliminate option A and option B. Is it clear? So we are checking next rule. Okay, we are checking next rule. So do you remember what is next rule? So next rule, carbon containing negative charge, carbon positive charge. Here also carbon containing negative charge, carbon containing positive charge. So adu third rule is an adu fail aidichu. Next rule. So here you can see positive and negative. Ena பக்கத்துல இருக்கு. So positive and negative is பக்கத்துல means it is more stable. Okay, so positive and negative adjacent atom contain positive and negative. That means opposite charge. That means it is more stable. Okay, so adjacent atom contain opposite charge means more stable. Okay, so more stable. This is also correct. It is more stable. So here also you can see plus and negative. Then we can check next rule. So then we can check our last rule. So do you remember what is our last rule? What is our last rule? What is our last rule? Like charge on adjacent atom is less stable. Here you can see positive பக்கத்துல வந்தா it is less stable. Negative பக்கத்துல வந்தா it is less stable. Positive, negative and lone pair vanda it is less stable. So here you can see positive positive பக்கத்துல வருதா? No. Negative negative பக்கத்துல வருதா? No. Then what will be the answer? What will be the answer? Ganesha is saying it is 4. Tell me, Ganesha, what is the reason why it is Oliva? Why it is 4? Guys, oxygen contain lone pair. You know, oxygen contain lone pair. So here carbon is negative also. Here carbon is negative. Oxygen contain lone pair. It is less stable. Okay, it is least stable. Okay, so option D is the correct answer. Okay, clear? Clear? Is it clear? Option D is correct answer. Arun 3 illa, that is 4 is the correct answer because oxygen contain lone pair. Yes ma'am, we remember. Yes, that is the point. Then we are moving to next point, localized and delocalized. Okay, localized and delocalized lone pair. What does localized and delocalized lone pair means? So here nitrogen contain lone pair. So is this lone pair participate in resonance? Is this lone pair participate in resonance? Is this lone pair participate in resonance? Sollada. Is this lone pair of nitrogen participate in resonance? Durga, Ganesha. No, very good. Here lone pair single double. So there is no bonding. There is no resonance. Okay, conjugation. So here you can see lone pair is there. So here tell me, is this lone pair of nitrogen participate in conjugation? Is this lone pair of electron participate in conjugation? Is this lone pair of electron will participate in conjugation? Guru is saying yes. Bunny, yes. Yes, obviously. Lone pair, single, double. Okay, lone pair, single, double. Okay, lone pair, single, double. So, this will participate. Okay, this will participate. Okay. Ho, Johnny. So, lone pair participate in resonance structure. That is actually, tell me. That is actually, come on, that is actually delocalized lone pair. Okay. That is actually localized lone pair. Okay. That is actually localized lone pair. Okay. So, here lone pair does not participate in resonance. That is actually, no, this is wrong. Okay, this is wrong. This is actually delocalized lone pair. This is localized lone pair. Okay, localized lone pair. Is it clear? Localized lone pair and delocalized lone pair. Okay. Okay, clear. Okay. Then guys, we are moving to next, extended and cross conjugation. Okay, extended and cross conjugation. Here you can see positive single double. Yes, one conjugation is there. And here you can see another one more conjugation, double single double. Okay, double single double. You can see extended. This is actually extended conjugation. Okay guys, this is extended conjugation. What is extended conjugation? One after one conjugation. Okay, that is extended conjugation. Okay, so IUPAC, next chapter is IUPAC. Okay, so extended conjugation, this is cross conjugation. Here you can see one conjugation here, one conjugation here. That is cross conjugation. When you consider extended conjugation and cross conjugation, extended conjugation is more stable. Okay, extended conjugation is more stable. Is it clear? Then we can move to next. Resonance effect or mesomeric effect. Okay guys, resonance effect or mesomeric effect. I hope it's clear than a resonance effect or mesomeric effect. Resonance effect or mesomeric effect. Resonance effect or mesomeric effect. So resonance effect or mesomeric effect. First point, it will operate in pi bond. Okay, you can see in pi bond. Okay, so here pi bond is there. Listen carefully. Pi bond is there. What is, ma'am, what is stable? Before stable, before this one, extended conjugation is more stable. It's more stable. Ma'am, once explain. Okay, extended conjugation means back-to-back conjugation. Okay, here you can see positive, single, double. Okay, so this is one conjugation. Here you can see one more conjugation, double, single, double. Okay, so back-to-back conjugation is actually extended conjugation. Okay, back-to-back conjugation is actually extended conjugation. What is cross conjugation? Here you can see two conjugation. Okay, so in different way you can see two conjugation. Okay, so here you can see positive, single, double. Here also positive, single, double. So it is actually cross conjugation. Is it clear? Arun, you are a BSc student, BSc chemistry. Where you are studying? Where you are studying? Which college? Is it clear da? So which one is more stable? Simple da. Simple da. So which one is more stable da? Which one is more stable? Which one is more stable? Here extended conjugation is more stable than cross conjugation. This is cross conjugation. Okay, this is cross and this is extended. This is extended and this is cross. Is it clear? Neelada, where Arun Balaji. So then we are moving to resonance effect or mesomeric effect. Okay, I hope it's clear. Yes, clear. Okay. So it will operate in pi bond. You can see this resonance effect or mesomeric effect will affect or that will operate in pi bond. Yes, pi bond. Yeah. Here you can see pi bond is there. And this group you can see. Okay, a group is attached. GTM. Okay, college. Where it is? Gudiatam. Okay. So here a group G is attached with a double bond. Okay, G is attached with a double bond. So here I can say that. Okay, here I can say that if this group G contain lone pair of electron. Okay, lone pair of electron means this is a plus M group. Okay, if this group contain, so I am writing, so if this group contain lone pair of electron, that is a plus M group. Okay, that is a plus M group. If this group contain, okay, if this group contain double bonded atom, okay, if this group directly contain a double bonded atom, okay, so what is that? It is actually minus M group. Okay, it is actually minus M group. Aisha was saying, I am pulled my all nighter yesterday and now I am feeling sleepy, so it's okay. Nap. Continue later. See. So take not 1 hour, take rest. Okay, rest is actually very important. And guys, I will prefer. Okay, so உங்களுக்கு தெரியும் உங்களோட NEET exam time. What is your NEET exam time? I will explain. Kashifa, what is your NEET exam time? Tell me quickly. What is your NEET exam time? What is your NEET exam time? NEET exam time. Do you know? Yes, I will tell you. Kashifa, no worries. Okay. I will tell you. So what is your NEET exam time, guys? 2 to 5. Yes, 2 to 5. So in the time la maximum நீங்க தூங்காம பார்க்கணும். Okay. Yes, afternoon that is 2 to 5. Okay. Particulars சொன்னா 2 to 5. இந்த 2 to 5 நீங்க தூங்கவே கூடாது. Actually நீங்க ரொம்ப அலர்ட்டா இருக்கணும். இந்த உங்களோட biological cycle is actually very important. Okay. So நீங்க இப்போ ஒரு ரொட்டீனா இல்ல சாப்பிட்டதுக்கு அப்புறம் தூங்கணும் இல்லைன்னா ரெஸ்ட் எடுக்கணும் ரொம்ப டயர்டா இருக்கு. ஸோ இட் வில் எஃபெக்ட் யுவர் நீட் எக்ஸாம். ஓகே, இட் வில் எஃபெக்ட் யுவர் நீட் எக்ஸாம். ஸோ ஐ வில் ப்ரெஃபர் ஸோ ஆஃப்டர் 5 o'clock ஒரு 6 o'clock தூங்கினாலும் இட்ஸ் ஓகே. பட் 2 to 5 it's very important. Actually 1 to 5 இல்லைன்னா 1 to 6 is actually important. So after 6 வேணும்னா தூங்கிக்கோங்க. Okay, because biology cycle is very important. Okay, biological cycle is very important for a human. Yes, I will tell you. Okay, so I will tell you, Kashifa. So there is two type of, when you consider mesomeric effect, okay, or resonance effect, it is there is plus M group and there is minus M group. Okay, there is plus M group and there is also minus M group. What is plus M group? Plus M group means here it will operate in pi bond. So its double bond is there. So nitrogen contain lone pair of electrons. So this double bond is directly connected to a lone pair containing atom. So that means this group is actually a plus M group. Okay, this group is actually a plus M group. Clear? Here you can see this carbon contain double bonded oxygen. Okay, this carbon double bond is there, pi bond. Carbon is attached with carbon. Carbon contain double bonded oxygen. So this group is actually a minus M group. Okay, this group is actually a minus M group. Is it clear? You're from Telugu only. You're from Telugu. So is it clear what is plus M, what is minus M? So here also you can see minus M effect is there. Minus M nama already lone pair பண்ணி இருக்குல்ல. So அது மாதிரி இதுவும் resonance, it will show resonance also. Okay, it will show resonance. So then we are moving to minus plus M group and minus M group. Here you can see O contain lone pair, NH2 contain lone pair, and OCOO, CH3 contain lone pair. Here oxygen contain lone pair. Okay, nitrogen contain lone pair, oxygen contain lone pair, nitrogen contain lone pair, halogen contain lone pair. All these group are plus M group. Okay, all these group are plus M group. M chestavu. Yeah, I'm teaching. So here you can see minus M group. Minus M group contain double bond. Here you can see double bond. Okay, clear? I hope it's clear. Minus M group, plus M group. Clear illada? So here you can see lots of questions are there. So we have limited time. So we are covering the content. Okay, so when you consider aromaticity, okay, so before that I want to recall some points. Okay, so ஒரு molecule உங்களுக்கு கொடுத்திருக்கு. They will ask what is the stability or write the stability. How we will check? First you should check aromaticity. Okay, first you should check inductive effect, then you should check first you should check aromaticity, then you should check resonance, then you should check hyperconjugation, then you should check inductive effect. Clear? Is it clear, my dear students? Is it clear? First you should check aromaticity, then you should check inductive effect, not inductive, resonance effect, then you should check hyperconjugation, then you should check inductive effect. Is it clear? Video stuck. Repeat, ma'am. Olive and Olivia same dana. Okay, so it is there. So first you should check aromaticity. So guys, what is aromatic compound means? So what is aromatic compound means? It's loading really. Let me check. No, it's working da. It's working. Ganesha. Okay. So, first you should check aromaticity. Okay, if they are giving exam, okay, cation molecule, anion molecule, they will give and they will ask, write the stability order. Okay, write the stability order. So, how we will check? First, you should check back bonding. Okay, first you should check actually back bonding. That I will tell you what is back bonding. So, after back bonding, you should check aromaticity. After aromaticity, if aromatic molecule is there means that is more stable. Then after aromaticity, you should check resonance. After resonance, you should check hyperconjugation. After hyperconjugation, inductive effect. Ma'am, loading. No, I think it's clear. I think it's clear. I think it's working. I think it's working properly. It's working properly. Okay. So, yes. So, first condition. Okay. So, there is some condition for aromatic property. So, the first condition is, okay. Now it's clear. Okay. First condition is cyclic. What is cyclic? Cyclic, it should be ring. Okay. It should be ring. That is the first condition for aromaticity. Second condition, conjugation. Do you remember our conjugation? Do you remember our conjugation? Positive single double and negative single double, lone pair single double. Okay, so that is actually okay. That is actually conjugation. And next is planar. What is planar? Do you remember what is planar? Yes, definitely I will give you examples. Okay, so what is planar? Planar means there is two rules. Okay, for that. Two lone pair, two sigma plus one lone pair. Okay, so you will get sp2, 2sp2. So I will write here. So you will get sp2 hybridization, or there is one more condition. 3 sigma plus 0 lone pair, that is also sp2 hybridized. Okay, sp2 hybridized means it is planar. Okay, if sp2 hybridization is there, planar. Okay, it is planar. And third one is Huckel's rule. Okay, when you consider aromaticity, okay, when you consider aromaticity, aromatic molecule is there. Okay, non-aromatic molecule is there. What is non-aromatic molecule? So, inge edachoru condition fail ayiduchuna. Any one condition fails. Any one condition fails. Any one condition fails. Condition fails. Any one condition fails. So, it will become non-aromatic. So, here you can see cyclic illana in a conjugation illa, planar illa. Idile edachu oru condition fail aidichuna, we can say that it is non-aromatic. It is non-aromatic. We can say that it is non-aromatic. Is it clear? It is non-aromatic. I hope it's clear. I hope it's clear. And next is Huckel's rule. Okay, next is Huckel's rule. What is Huckel's rule now? What is Huckel's rule? It's very simple. Ma'am, Huckel's rule, please. Yes, I will tell you. So, what is Huckel's rule? 4n plus 2 pi electrons. Okay, so I will write Huckel's rule first. Huckel's rule. What is Huckel's rule? That is 4n plus pi electrons. Okay, 4n plus pi electron. So, when you consider n is equal to 0, n is equal to 1. Okay, first we can consider n is equal to 1. Then n is equal to 1 means it will become 0 and 2. So, 4, 5, 6 pi electrons. Okay, so n is equal to 2 means, so it will become 2 plus 4 into 2, 8, 8 plus 2, 10, 10 pi electron. 10 pi electrons. Okay, and n is equal to 3 means 3 into 4, it is 12, 12 plus 2, 14, 14 pi electron. Yes, 14 pi electrons. So we can say that it is aromatic. Okay, we can say that it is aromatic if it follows, okay, if it follows Huckel's rule also. Okay, I will tell you what is planar, no worries, I will tell you with one example. Okay, then it will become clear. Okay, then it will become clear. Okay, n means, okay, n means we will normally take 1, 2, 3, 4. Okay, don't worry, we will take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's number. Okay, that is n. Okay, clear? Okay, and when you consider, this is aromatic molecule, this is non-aromatic molecule, there is one more molecule, that is anti-aromatic molecule. Okay, no, not principal quantum number. Okay, it's not principal quantum number. No, it's not principal quantum number. So there is one more molecule, that is anti-aromatic molecule. So I will give you the equation for anti-aromatic molecule. So that is anti-aromatic molecule. Anti-aromatic. So anti-aromatic equation is 4n pi electron. Okay, 4n pi electron. So we can consider n is equal to 1. So it will become 4 pi electron. N is equal to 2. It will become 8 pi electron. N is equal to 3. It will become 12 pi electrons. Okay. So I will tell you with one example. Guys, are you ready? Yes. எல்லாரும் சாப்பிடுறதுக்கு போயிருக்கு, அதுக்கப்புறம் யாரும் திரும்பி வரல. ஓகே, some students தான் வந்திருக்கு, பாக்கி யாரும் திரும்பி வரல. Okay, clear? Okay. Then, okay, proper பாருங்க, I will give you a molecule. So, பார்க்கலாம் எப்படி planar check பண்ணும், எப்படி aromatic ஆன்னு check பண்ணும்னு. Okay, so what is our first condition? Do you remember our first condition? Our first condition is, yeah, I will tell you with example. Okay, so அப்போ கொஞ்சம் கூட easy ஆகும், aromatic, non-aromatic. Okay, so first condition is cyclic. Yes, it is cyclic. Correct, it is cyclic. So guys, is it cyclic dana? So that I will tell you. N means number of pi bonds. Yes, not pi bonds. I will tell you what is that. So second one. What is second one? Do you remember what is second one? Second point in a planar. Okay. Second point in a planar. Planar order condition. Do you remember planar order condition is actually sp2 hybridized. Okay, planar means it should be sp2 hybridized. Okay, yes, conjugation is also there. So I will check planar, then I will check conjugation. Okay, correct, conjugation is there. So you can see it is double bond. Every carbon is sp2 only. Is it clear? So it is planar. Okay, it is planar. Okay, is it clear? Is it clear? It is planar because every carbon is sp2 only. Double bond is there, double bond, alternate double bond is there. So obviously it is planar only. No issues. Clear? I hope it's clear. So it is planar. Tick. Then third one, conjugation. Do you remember what is conjugation? Do you remember what is conjugation? So every atom should have conjugation. Okay. So every atom should have conjugation. So here just write conjugation. So conjugation, every atom should have, every atom should have conjugation. So check, every atom should have conjugation. Irka illaya? Tell me quickly in the chat box. Is conjugation is there or not? Is conjugation? Guru is saying no, I think. Guru last no conjugation sollirukku. So tell me your opinion. Is there conjugation or not? Is conjugation is present in every atom or not? Is conjugation is present or not? Is conjugation is present or not? Yes. Yes. Okay, nice. Cute. Okay. Conjugation is there. Obviously. Can you tell me which conjugation is present here? Can you tell me which conjugation is present here? Which conjugation is present here, da? Which conjugation, which type conjugation is present here? We discussed different type of conjugation. Which conjugation present here? Any idea? So you can see alternate, single, double, alternate double conjugation. Okay, extensive, no, not that. Here you can see alternate double bond. Yes, very good. Alternate double bond conjugation is also there. So then we should check Huckel's rule. Okay, we should check Huckel's rule. So I am writing fourth one is Huckel's rule. Huckel's rule. What is Huckel's rule, da? So you should check. Okay, listen carefully. You should check the pi bond electron. How many pi bond electrons are there? 1, 2, 3, 4, 5, 6. 6 pi electrons are there. Okay, 6 pi electrons are there. So I am writing here 6 pi electrons are there. So do you remember this? Yeah. 6 pi electrons is there means it obey Huckel's rule. It is a aromatic molecule. So it is a aromatic molecule. Clear? Clear, Ada? Is it clear? N is equal to no, not N is 1, 2, 3, 4. Okay, it's not depend on N. You just check how many pi electrons are there. Okay, check pi electrons and check with this numbers. Okay, 6, 10 and 14 pi electrons. Okay, clear? Two n plus 2 pi electron. No, da. It is 2n plus 2 pi electron. Okay, clear? I hope it's clear. What is n? N means we are taking generally 1, 2, 3, 4. Okay, it's number only. So you should concentrate on this. Okay, you should concentrate on this. This much pi electron you are getting means yes, it's Huckel's rule. It is an aromatic molecule. Okay, I hope it's clear. I hope it's clear. Clear? And my dear students, I just want to add one more point. Is it clear? So, Inga, you can see different examples. Okay, you can do alone. Then we are moving to application of aromaticity. Okay, we are moving to, can you explain non-aromatic, ma'am? Yeah, sure. Here we can discuss non-aromatic molecule. Okay, clear? So, application of aromaticity, the first application is to compare dipole moment. Okay, to compare dipole moment. Okay, so what is dipole moment? Can you explain aromatic? Yes. So, compare dipole moment. So, we know that there is relation between dipole moment and stability of carbocation. So, dipole moment is directly proportional to stability of carbocation. Okay, dipole moment is directly proportional to stability of carbocation. Okay, so then what we can do? Very simple. So it will form. Okay, it will form O minus. Here it will form carbocation. Okay, here it will form carbocation. So I am drawing here carbocation is there. Carbocation is there. And my dear students, and my, oh, it's different. Okay, this molecule is different. Carbocation. And my dear students, I just want to share one more thing. Okay, so listen carefully. Here you can see soda. Here you can see join the pro master batch. Okay, pro master batch on பண்ணும்போது you can see என்ன ஃப்ரீயா, ஓகே, உங்களுக்கு ஃப்ரீயா கிளாஸோட ஆக்சஸ் இருக்கும். ஓகே, ஃப்ரீ கிளாஸஸ் ஆக்சஸ். ஓகே, ஸோ என்ன 0 தான். So you can buy, so 0 rupees da. So here you can do, okay, so here you can do 0 rupees, pay 0 rupees, go to my courses, check பண்ணும்போது you can watch. Okay, you can watch master batch ஓட எல்லா கிளாஸுமே உங்களுக்கு டைரக்டா ஆப்லயே பார்க்க முடியும். ஓகே, நார்மலி யூடியூப்ல இல்லைன்னா லைக் unnecessary interactions எல்லாம் இருக்குமே இல்ல, ஸோ அதெல்லாமே அவாய்ட் பண்றதுக்காக உங்களுக்கு டைரக்டா ஆப்ல பார்க்கலாம். And after the session you can do mock test. Okay, after the session you can do mock test பண்ணலாம். Okay, mock test பண்ணலாம், இல்லனா insta solve. உங்களுக்கு சடனா ஒரு இது completely free தான். Okay, இது completely free தான் மேம். பெய்டா இல்லையா? No, it's not paid. So after the session, okay, after the session உங்களுக்கு என்ன பண்ணலாம்? mock test attend பண்ணலாம். ஸோ இன்னைக்கு கம்ப்ளீட் ஆர்கானிக் கெமிஸ்ட்ரி சாப்டர் முடியும்ல. ஸோ இந்த கம்ப்ளீட் ஆர்கானிக் கெமிஸ்ட்ரியோட MCQs நான் அதில் அப்லோட் பண்ணும். ஓகே, ஸோ அதில் அப்லோட் பண்ணும். ஸோ அதில் இருந்து உங்களுக்கு என்ன பண்ணலாம்? டவுன்லோட் பண்ணிட்டு, டவுன்லோட் இல்லை, டைரக்டாக உங்களுக்கு அங்கேருந்து மாக் டெஸ்ட் அட்டென்ட் பண்ணலாம். இட் இஸ் கம்ப்ளீட்லி ஃப்ரீ, 0 காஸ்டோடது. ஓகே, கம்ப்ளீட்லி ஃப்ரீ தான். மேக்ஸிமம் யூட்டிலைஸ் பண்ணுங்க. பிகாஸ் எல்லாருக்கும் என்ன ஒரு கோர்ஸ் பை பண்ணுறதுக்கு ஃபினான்ஷியலி எல்லாரும் ஓகேயா இருக்கணும்னு இல்லை. ஸோ உங்களுக்காக, ஓகே, உங்களுக்காக டோன்ட் வரி. ஸோ அப்படி இருக்கிற ஸ்டூடெண்ட்ஸ்க்கும் நல்ல மார்க் வாங்கணும்ல. இந்த லாஸ்ட் டைம் எல்லாமே லைக் ரிசோர்ஸஸ் எல்லாமே ரொம்ப கம்மியாக இருக்கும். ஓகே, லாஸ்ட் டைமில் தான் நமக்கு லைக் மோஸ்ட் ஆஃப் த கொஸ்டின்ஸும் எல்லாம் வேணும்ல. ஸோ ரிசோர்ஸஸ் நார்மலி கம்மியாக இருக்கும். ஸோ அதுக்காக இதில் உங்களுக்கு என்ன பண்ணலாம்? உங்களுக்கு மாக் டெஸ்ட் அட்டென்ட் பண்ணலாம். ஓகே, யூ கேன் டூ யோர் மாக் டெஸ்ட். ஸோ இன்னைக்கு உங்களுக்கு செஷன் முடிஞ்சாச்சு. செஷன் முடிஞ்சதுக்கு அப்புறம் உங்களுக்கு என்ன ப்ராக்டிஸ். ஓகே, யூ கேன் see here கெமிஸ்ட்ரியோட ப்ராக்டிஸ் பண்ணணும்னா ப்ராக்டிஸ் பண்ணலாம். ஓகே, அசைன்மெண்ட்ஸ் இருக்கு. ஓகே, இது எல்லாமே உங்களுக்கு எடுக்கலாம். அசைன்மெண்ட்ஸ் இருக்கு அண்ட் அதர் கண்டென்ட்ஸும் இருக்கு. ஓகே, உங்களுக்கு எக்ஸ்ட்ரா கண்டென்ட்ஸ் கிடைக்கும் அண்ட் இதோட கிளாஸஸும் இருக்கு. ஓகே, கிளாஸஸும் இருக்கு. ஸோ க்யூஸ் பண்ணலாம். ஓகே, ஸோ க்யூஸ் அட்டென்ட் பண்ணலாம். ஓகே, ஹியர் யூ கேன் சி. அண்ட் இது மட்டும் இல்லாமல் உங்களுக்கு பர்சனலைஸ்ட் க்யூஸ் வேணும்னா, ஓகே, உங்களுக்கு பர்சனலைஸ்டா மேம் நான் நார்மலி ஆர்கானிக் சாப்டரில் ஜிஓசி மட்டும்தான் கவர் பண்ணியிருக்கு, இல்லைன்னா ஹைட்ரோ கார்பன்ஸ் மட்டும்தான் கவர் பண்ணியிருக்கு. டோன்ட் வரி, ஹைட்ரோ கார்பன்ஸோட மட்டும் உங்களுக்கு என்ன பண்ண முடியும்? க்யூஸ் அட்டென்ட் பண்ண முடியும். ஓகே, மாக் டெஸ்ட் பண்ண முடியும். இது கம்ப்ளீட்லி ஃப்ரீ ஆஃப் காஸ்ட் தான். ஓகே, கம்ப்ளீட்லி ஃப்ரீ ஆஃப் காஸ்ட், கம்ப்ளீட்லி ஃப்ரீ ஆஃப் காஸ்ட் தான். ஸோ இங்கே போய் உங்களுக்கு மாஸ்டர் பேட்ச் பார்க்க முடியும். ஸோ மை டெஸ்ட், ஓகே, யூ கேன் டூ டெஸ்ட். ஓகே, ஸோ இது வரைக்கும் இது என்னோட அக்கௌண்ட், நான் இது வரைக்கும் டெஸ்ட் அட்டென்ட் பண்ணலை. ஸோ யூ கேன் அட்டென்ட். ஓகே, மிஸ் பண்ணியிருக்கிற டெஸ்ட் எல்லாமே இங்கே இருக்குது. ஸோ ஜிஓசியோடது இருக்குது அண்ட் ஹைட்ரோ கார்பன்ஸ் அண்ட் எலக்ட்ரோஸ்டாட்டிக்ஸ் அண்ட் கிராவிடேஷன் ஒன் ஷாட் எல்லாமே இருக்குது. ஓகே, ஸோ உங்களுக்கு இங்கே போய் அட்டென்ட் பண்ணால் போதும். ஸோ ஓகே, ஸோ கொஞ்சம் டைம் வெயிட் பண்ணணும். ஸோ டோன்ட் வரி, வெயிட் பண்ணிக்கோங்க. ஸோ அதுக்கப்புறம் எனக்கு இப்போ டைம் வெயிட் பண்ணதுக்கு இல்லை. ஸோ இங்கே கொஸ்டின்ஸ் இருக்குது. இது என்ன ஆக்சுவலி அனிமல். ஸோ டெல் மீ வாட் இஸ் ஆன்சர்? உங்களுக்கு ஆன்சர் சொல்லலாம், எனக்கு ஆன்சர் தெரியாது, பயாலஜி கொஸ்டின் தான், உங்களுக்கு ஆன்சர் சொல்லலாம்ல. So yes, what is the correct answer for this question? So what is the correct answer for this question? Come on. So இங்க free of cost, okay, உங்களுக்கு இதுக்கு நீங்க என்ன ஃபீயே இல்ல, just free of cost தான். இப்போவே டவுன்லோட் பண்ணிக்கோங்க, ஓகே, இப்போவே டவுன்லோட் பண்ணிக்கோங்க. இது free of cost தான், பிகாஸ் எல்லா ஸ்டூடெண்ட்ஸ்க்கும் ஒரு கோர்ஸ் பை பண்றதுக்கு அவ்வளோ என்ன ஐயோ இந்த டைம்ல இது யூஸ்ஃபுல்லா இருக்குமா, என்ன பண்ணணும்னு தெரியாது. ஸோ டோன்ட் வெரிடா. ஸோ இது கம்ப்ளீட்லி ஃப்ரீ தான். அண்ட் இங்க இருந்து ஆல்மோஸ்ட் 88 resources, okay, books, reference booksம் இருக்கு, okay, 88 reference booksம் இருக்கு. So இப்போவே டவுன்லோட் பண்ணிக்கோங்க. I will give you ஒரு few minutes, okay, இப்போவே டவுன்லோட் பண்ணிக்கோங்க. ஸோ சீக்கிரமா டவுன்லோட் பண்ணிக்கோங்க. யார் பண்ணலன்னா ஜஸ்ட் இப்போவே பண்ணிக்கோங்க. அருண் பாலாஜி, இப்போவே சீக்கிரமா பண்ணிக்கோங்க. இட்ஸ் வெரி இம்பார்ட்டன்ட், ஓகே. ஸோ இந்த லாஸ்ட் டைம்ல உங்களுக்கு கம்மி தான் லைக் ரிசோர்ஸஸ் எல்லாம் இருக்கும். இப்போவே இதில் ஆல்மோஸ்ட் மோர் தேன் 100 ரிசோர்ஸஸ் புக்ஸ் இருக்குது, ஓகே, ரெஃபரன்ஸ் புக்ஸ் இருக்குது. கெமிஸ்ட்ரியோடது இருக்குது, பயாலஜியோடது இருக்குது, ஃபிசிக்ஸோடது இருக்குது, அண்ட் கெமிஸ்ட்ரிலையும் ஆர்கானிக் கெமிஸ்ட்ரியோடது இருக்குது, இன்ஆர்கானிக் கெமிஸ்ட்ரியோடது இருக்குது, ஃபிசிக்கல் கெமிஸ்ட்ரியோடது இருக்குது. எல்லாமே டிஃப்ரெண்ட் ஆதர்ஸோட புக்ஸ் இருக்குது, ஓகே. கண்டென்ட் லைப்ரரியும் இருக்குடா. ஹியர் ஐ வாண்ட் டு அட்டெண்ட் லீவ். ஸோ உங்களுக்கு ஏதாச்சும் டவுட் இருந்தா ஸோ இங்கே பாருங்க எல்லா கொஸ்டினும் இருக்கு, ஜிஓசி எல்லாம் இருக்கு, அட்டென்ட் பண்ணிக்கோங்க. ஸோ இது நெக்ஸ்ட் டைம்ல ஸோ நீங்கள் ப்ராப்பராக அட்டென்ட் பண்ணா, ஓகே, நீங்கள் ப்ராப்பராக அட்டென்ட் பண்ணா என்ன நடக்கும்? ப்ராப்பராக அட்டென்ட் பண்ணா உங்களுக்கு உங்களோட லீடர் போர்டும் வரும், ஓகே, லீடர் போர்டும் இருக்கு. எஸ், ஸோ லைக் ஐ வில் ஷோ யூ, ஓகே. இங்க மை டெஸ்ட் எடுத்தா உங்களுக்கு பார்க்க முடியும். ஸோ எஸ், ஹியர் யூ கேன் சி ஆர்கானிக்கோட அசைன்மெண்ட்ஸில் போனால் யூ கேன் சி அண்ட் அதர் கண்டென்ட் கிளாஸஸ், கெமிஸ்ட்ரி ரிசோர்ஸஸில் மை டெஸ்ட் எடுக்கணும், ஓகே. மை டெஸ்ட் எடுத்தா ஸோ இது வரைக்கும் இருந்த எல்லாமே, இது ஆக்சுவலி நான் இப்போ பண்ணதில்ல, ஸோ இப்போ பண்ணதுனால அண்ட் மிஸ் பண்ணியிருக்கிறது இது எல்லாமே மிஸ் பண்ணியிருக்கு. ஹியர் யூ கேன் சி. இப்போ கிளியர் தானேடா காஷிஃபா? இப்போவே டவுன்லோட் பண்ணிக்கோங்க, சீக்கிரமா டவுன்லோட் பண்ணிக்கோங்க, ஓகே. இப்போவே ஐ வில் கிவ் யூ 5 minutes. ஸோ டவுன்லோட் பண்ணிட்டு எல்லாரும் சொல்லுங்க டவுன்லோட் பண்ணி இருக்குன்னு. ஸோ ஹியர் யூ கேன் சி IUPAC, GOC, hydrocarbons ஓடது இருக்கு. and here you can see more photosynthesis, plant kingdom எல்லாமே இருக்கு, okay. dual nature, some basic concepts of chemistry, equilibrium, redox reaction order test, dual nature, radiation, atom, nuclei order test, some basic concepts of chemistry, equilibrium, redox, photosynthesis, respiration, IUPAC, hydrocarbons, and electrostatic gravitation, current, electricity, plant, animal kingdom. So இன்னைக்கு செஷன் முடிஞ்சா இன்னைக்கு இந்த கம்ப்ளீட் ஆர்கானிக்கோட டெஸ்டிங் வரும், ஓகே. கிளியர்? செஷனுக்கு அப்புறம் தான் வரும், ஓகே. டவுன்லோடட் மேம், already downloaded ma'am. Content library is there da, content library is also there, please check, okay. So இப்போ content library இருக்குடா, okay. So content library இருக்கு, இப்போ டைம் இல்லை, ஸோ அதனால எல்லாரும் டவுன்லோட் பண்ணியாச்சா? ஸோ எல்லாருக்கும் ஆக ஸோ எல்லாரும் டவுன்லோட் பண்ணியாச்சாடா? Just a second. Yes. Yes, I think content library is there. So check பண்ணுங்க, because என்ன and like கோபிகா மேம் ஆல்ரெடி ஷேர் பண்ணியிருக்கோம் எப்படி கண்டென்ட் லைப்ரரி ஓப்பன் பண்ணணும்னு எல்லாமே, ஓகே. கோபிகா மேம் ஷேர் பண்ணியிருக்கு, ஓகே. content library is there, please check, okay. So I also want to check content library எங்க இருக்குன்னு, okay. Okay. Yeah. Clear. I'm checked. So you join Nambike batch also. Yes, I know. Yes. Oliva is there. Yes, Oliva is there. I know. Nambike batch la irukku. Okay. So, shall we start? Yes, yes, we can. I hope it's clear. So, dipole moment is directly proportional to stability of carbocation. Okay, dipole moment is directly proportional to stability of carbocation. Then what will happen? So, inga bond break agumbodhu, it will form like this. Okay. So, check is it an atomic aromatica, non-aromatica and anti-aromatic and check பண்ணலாம். So first என்ன check பண்ணணும்டா? So cyclic, yes, it is cyclic. So இங்க conjugation இருக்கா? Conjugation is there or not? Conjugation is there? Ma'am, me, yeah, Jenny. Hi bye வந்துட்டு சொல்லிட்டு போகும்ல. So இது என்னடா? இது aromatica, non-aromatica, anti-aromatica. Tell me quickly. Is there any conjugation? Is there any conjugation? Is there any conjugation here? Is there any conjugation? Yes, conjugation. Ganesh is saying conjugation is there. I want 300 likes. I want 300 likes. Because I'm taking marathon, you know. So, there is no conjugation. Yes, very good. There is no conjugation. So, I can simply say that it is non-aromatic. Okay, non-aromatic. Okay, it's clear. Then when you check this molecule. So, conjugation is there or not? Conjugation is there or not? Plus single double. Conjugation is there. Cyclic and planar. Okay, it is planar also. When you consider double bond, yes, இது தான் sp2 carbon. இது sp2 carbon. Positive இருந்தா it is also sp2 carbon. Okay, it is also sp2 carbon. So conjugation is also there. And how many pi bond is there? Okay, how many pi electrons are there? Here you can see 2 pi electrons are there. Here I just want to add 0 also. I didn't mention 0. Okay. So if you are writing 0, n is equal to 0. So n is equal to 0. 0, it will become 2 pi electron. Okay, 2 pi electron. 2 pi electron means it is aromatic. Okay, 2 pi electron means it is aromatic. So guys, it is aromatic. It is aromatic. Clear? Do you have any doubt? Do you have any doubt? So I will tell you, no worries. Okay. So you can check this one. Is it aromatic, anti-aromatic or non-aromatic? Tell me in the chat box. Yeah, I will tell you dipole moment. No worries. I will tell you dipole moment. Okay. I will tell you dipole moment. What is dipole moment? Because we are discussing about dipole moment. La. So is it anti-aromatic? No double bond, ma'am. No double bond. Ganesha, aromatic. So you guys are saying it's aromatic. Let me check. Okay, let me check. So here you can see, yes, it is cyclic. Conjugation, double, single, double, and here also positive single double is there. Positive single double is there. Yes. Conjugation is also there. Planar. Yes, it is planar. Yes, it is planar. Okay. And how many pi electrons are there? How many pi electrons are there? 1, 2, 3, 4. 4 pi electron. Is it aromatic, anti-aromatic or non-aromatic? Tell me, is it aromatic? 4 pi electrons are there. Is it aromatic, anti-aromatic, non-aromatic? Yes, it is planar only. 4, yes, 4 pi electrons are there. Tell me, anti, very good. It is anti-aromatic. Yes, it is anti-aromatic. So when you consider aromatic, anti-aromatic and non-aromatic, so I will write here, okay? I don't know if I write or not. Okay, I will write. Aromatic is more stable. And after that, non-aromatic. And anti-aromatic. So, here tell me which carbocation is more stable. Aromatic carbocation is more stable. then non-aromatic, then anti-aromatic. Clear? Is it clear? So dipole moment is directly proportional to stability of carbocation. Which is more dipole? Which is more dipole? This is more dipole. It contains more dipole moment. After that, this. After that, this. Clear? If it is clear, tell me in the chat box. Quicker sollungada. If it is clear, ma'am, why anti-aromatic is less stable? Oliva. When you consider aromatic, anti-aromatic and non-aromatic stability order, when you consider anti-aromatic is less stable only because of its structure, pi electron conjugation and everything. Mainly because of that pi electrons, okay, because of pi electrons. If Huckel's rule, it obey like that type of 6 pi electron, 2 pi electron means it is more stable, okay. It is more stable. I hope it's clear. Then we can move to next application is to compare acidic strength, okay, to compare acidic strength, okay. So we know that acidity directly proportional to stability of carbanion, okay. Here also you should check aromatic, anti-aromatic and non-aromatic. Ma'am, why that is anti-aromatic? Why that is anti-aromatic? Because it contains 4 pi electrons. 4 pi electrons means I already told you now. I already told you. 4 pi electrons, 8 pi electron, 12 pi electrons, anti-aromatic. Do you remember? Okay. Somebody asked. Okay, is it clear? Then we can move to here also. So different questions you can do, okay, you can do your own. So next we are moving to stability of carbocation, okay. So seekrama finish pannala. So if they are asking the stability of carbocation, first you should check back bonding, okay. So first you should check back bonding. Money, yes, no fire. So first you should check back bonding, okay. When they are asking about stability, okay, stability means first you should check back bonding, then you should check resonance, then you should check, after that you should check inductive effect. First you should check back bonding, then you should check anti-aromatic, aromaticity, then you should check resonance, then you should check hyperconjugation, then you should check inductive effect, okay. Inductive effect is least priority effect, okay, least priority effect, okay. So here what is back bonding? I will tell you what is back bonding, okay. So here A, okay, A is there, okay. A contain lone pair of electron, okay. A contain lone pair of electron, and here carbon is a carbocation, okay, carbocation. So obviously it contain vacant orbital, okay. It contain vacant orbital, okay. So it contain vacant orbital. Then what will happen? This 2 lone pair of electron will jump into that vacant orbital, okay. So this 2 lone pair of electron will jump into that vacant orbital. That is actually back bonding. Is it clear? Then here you can see back bonding structure, aromatic, mesomeric or resonance, and hyperconjugation, inductive effect. So stability of carbocation, plus plus plus, minus minus minus, okay. Ellathilayum plus 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 effect தான் வரும். Then when you consider hybridization, that we already discussed. Hybridization means electronegativity is directly proportional to percentage of S character. So percentage of S character increase agumbodhu, what will happen? Electronegativity of element positive charge means it is unstable, okay. So that we already discussed. இது எல்லாமே discuss பண்ண points தான். இது எல்லாமே discuss பண்ண points தான். Questions இருக்கு, you can do, okay, you can do the questions, okay. So next is, thank you so much for your love, fire, everything, okay. So please watch, okay. So next is stability of carbanions, okay. Stability of carbanions we are discussing. So first one is, okay, first one is, here you can see Carbanion means it contains lone pair of electron. So the neighboring atom should have vacant. If it has vacant d orbital, okay, if it contains vacant d orbital, then what will happen? This 2 electron will shared with A. Okay, this 2 electron will shared with A. Okay, yes. So here also back bonding is more important. After that conjugation, after that aromaticity, after that mesomeric effect or resonance, after that hyperconjugation, last inductive effect. So stability of carbanion is directly proportional to minus 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 and inversely proportional to plus plus plus. Okay. I hope it's clear. Here also you can do some questions and all. Okay. Questions allame pannalam. Can we move to IUPAC nomenclature? Seekrama IUPAC nomenclature start pannalamada. IUPAC nomenclature. Loading what? IUPAC nomenclature start pannalama. Ellaru session quick like pannunga. I need energy. Okay, definitely I need energy. I want to see 300 likes soon. Okay, I want to see 300 likes soon. 300 likes soon. Samir. Okay, I want to see 300 likes soon. So, ellaru seekrama session like pannungada. Seekrama, everyone please like the session quickly. I want, yes. 88th person. Okay, I liked. Oh, your Shalini is 88th person. Okay. It's 212. Okay. So start pannalama. I think you all are ready. Yes, GOC completed. Then we are moving to next chapter. I think you all are ready. Okay. So this is IUPAC nomenclature. So IUPAC nomenclature, we can start from base. Okay, we can start. After this, first basic we can finish. Okay, first we can finish GOC, IUPAC, and after IUPAC we can do isomerism also. Okay, we can do isomerism. After isomerism, we can do hydrocarbons. Okay, hydrocarbons. Okay, IUPAC and we can do hydrocarbon. Okay, we can start from base. So base build panni pola. Okay, so yes, compound. Okay. Yes. So mainly there is two different type of compound. Organic compound is there. Inorganic compound is there. Okay. What is organic compound? Means plant and animal derivative compounds. Derivative compound. And inorganic it's mineral and oil compounds. And why organic? So self-linking property, catenation. Mainly organic like carbon. Okay. Carbon. Okay. So we can start from scratch, so we can build slowly. Okay, we can build slowly because all students inge most of the students ko base venunu sollirukku. Okay. Yes, after that we will do. So ella PPT set up prepare panni vandirukkinga. Okay. So I will cover aldehyde, ketone, haloalkenes and haloarenes ellame irukku. So no worries. Okay. Okay, yeah, come on down. So first one is catenation property. Okay, catenation property means self-linking ability of carbon. Carbon catenation property more than. Okay, carbon catenation property is more. Okay, so first one is representation of organic compounds. So organic compounds are different type of represent pannalam. Bond line structure. Okay, bond line structure theriyumla. So bond line structure. Idella bond line structure. Okay, so in the oro points Oro points, oro adjacent points, oro corners, it is representing carbon. Okay, it's representing carbon. So carbon and hydrogen is there. Okay, carbon and hydrogen is there. If we are like any hetero atoms is there, we should separate. We should represent separately. Okay, for example. OH is there. OH is there means simple. You should represent OH. Okay, it's a functional group, alcohol group. So, and you should represent separate represent பண்ணனும். And double bond and triple bond separate represent பண்ணனும். இப்படி தான் double bond and triple bond represent பண்ண முடியும். Okay, triple bond na 3 lines and double bond na extra 2 line. Okay, எப்படி போடணும். And zigzag தான் normally we will represent. Okay, we will normally represent with the zigzag lines. Okay, with the zigzag lines. And double bond triple bond எல்லாமே represent பண்ணிருக்கு. Multiple bond இதுதான் என்ன bond line representation. Okay, this is actually bond line representation. Next is degree of carbon. Okay, 𝐶𝐞𝐦𝐢𝐵 we will finish. Okay, 𝐶𝐶𝐴 we will finish this IUPAC. So degree of carbon, what is degree of carbon? So here you can check. Okay, when you check this degree of carbon, so in the carbon மேல எவ்வளோ carbon direct bond பண்ணியிருக்கு. Okay, so you can see in the carbon மேல எவ்வளோ carbon direct bond பண்ணியிருக்கு, that is actually degree of carbon. So the number of carbon atom directly attached with the carbon. Okay, number of carbon atoms directly attached with the carbon. Here you can see, here the carbon order degree is 1 because this carbon is directly attached with one carbon. Okay, or bonded with one carbon. When you consider this carbon, so this carbon is directly connected with the 3 other carbon. Okay, it's directly bonded with the 3 other carbon. So the degree is tertiary. So definitely you can expect one question from IUPAC. Okay, IUPAC எல்லாமே 11th chapter தான். Okay, this is actually 11th chapter. And when you consider this carbon, so this carbon is directly connected with 1, 2, 3 other carbon. So degree is tertiary. Okay, tertiary, or we can say that 3 degree also. Okay, either we can say tertiary or we can say 3 degree also. Okay, 3 degree or tertiary. Okay, is it clear? Then we are moving to next degree of alcohol. What is degree of alcohol? So this OH group is directly connected with the carbon. Okay, OH group is directly connected with the carbon. That carbon is directly connected with, okay, number of carbon atom directly connected with the OH connect பண்ணியிருக்கிற atom. Okay, clear? Tell me 𝐶𝐶𝐴. So OH connect பண்ணியிருக்கிற இந்த carbon atom எவ்வளோ carbon atom directா connect பண்ணியிருக்கு. So degree of carbon atom which the OH group is present. Okay, so OH group attach பண்ணியிருக்கிற carbon. Yes, very good. I can see here answer. So let me write the answer. So here OH is connected with this carbon. This carbon is directly connected with 2 other carbon. So here degree is 2 degree or secondary. We can say 2 degree or secondary. Here also this OH is connected with this carbon. So this carbon is directly connected with 2 other carbon. So here also it is 2 degree or secondary. So here when you consider this OH, okay, when you consider this OH, so this OH is connected with this carbon. So this carbon is directly connected with 1, 2, 3 carbon. So the degree is tertiary. Clear? So OH is connected with this carbon. This carbon is directly connected with the 2 other carbon, this and this. Okay, so it is secondary. Clear? Then what about third one? This carbon is directly connected. This OH is directly connected with this carbon. This carbon is directly connected with only one carbon. It is primary. Clear? Yeah. Then we are moving to degree of phenol. Tell me what is the degree of phenol? Degree of phenol. Tell me what is the degree of phenol? Tell me what is the degree of phenol? Zero degree, no degree, 2 degree. It is actually, there is no degree for phenol. Because when you consider phenol is a, okay, next interval, no interval I am not giving. Okay, I am not giving any interval. You should be there. Okay, you should be here. Okay, so it is a functional group. Okay, it is a functional group. When you consider alcohol is a functional group. When you consider phenol is a functional group. So no degree. Okay, there is no degree. So normally you will think how which is there. So which is connected with this carbon. So this carbon is again connected with two other carbon. So it is 2 degree. No, it is a functional group. Okay, when you consider phenol is a functional group. Yes, da subte. Okay, I hope it's clear. So here I will give you one example. So what is the degree of this molecule? What is the degree of this molecule? Last point, phenol degree illa because phenol is a functional group. Yes, correct. So here, this is not phenol, okay, this is alcohol. Here OH is connected with this carbon. So this carbon is directly connected with one carbon. So degree is primary. Degree is primary, very good. Manita, clear? Manita, clear? Next, degree of halogen. What is degree of halogen? Same only, okay. So this halogen is connected with this carbon. This carbon is directly connected with two other carbon. So degree is secondary. So here also, here the bromine is connected with the one carbon. That carbon is connected with two other carbon, okay. So that is degree of bromine, okay. So next is degree of amine. It is quite different, okay. It is quite different. So listen carefully. So here we are discussing directly nitrogen is connected with, okay. So here we are discussing nitrogen is directly connected with the carbon. So here nitrogen is directly connected with the 3 carbon. It is tertiary, okay, or 3 degree. So nitrogen is directly connected with the 2 other carbon. So it is secondary. So nitrogen is connected with the 1 carbon. So it is primary. And here also nitrogen is directly connected with 1 carbon. It is also primary. Is it clear? I hope it's clear. Can you repeat degree of halogen? Yeah, same da. So here halogen is connected with this carbon. So this carbon is connected with 2 other carbon. That is secondary. Sorry, secondary. Yes. So halogen is connected with a carbon. So that carbon, degree of that carbon, okay, degree of halogen connected carbon, okay, degree of halogen connected carbon, that is degree of halogen. I hope it's clear. Then we are moving to degree of aniline. What is degree of aniline? You can write, okay. It's like phenol only. Okay. So classify the following: primary, secondary and tertiary alcohol. So we can try, okay. Just try together, we can try together. So what will happen? So this OH is connected with the carbon. So this carbon is connected with 1 carbon. So it is primary. So here OH is connected with the carbon. This carbon is connected with another carbon. It is also primary. So here OH is connected with this carbon. So this carbon is connected with 2 other carbon. So it is secondary. So when you consider this, OH is connected with this carbon. This carbon is connected with another carbon. So it is primary. So here also OH is connected with this carbon. This carbon is connected to 1, 2, 3 carbon. It is secondary. Tertiary. Is it clear? Very good. I can see answers. So here also we are discussing, okay. Here we are discussing about degree of unsaturation. This is very important, okay. Degree of unsaturation. This is very, very important. Yes, Ganesh. So tell me. Yes, it is. So degree of unsaturation. What is the degree of unsaturation? So degree of unsaturation, okay. Degree of unsaturation, normally we will use degree of unsaturation. I will tell you. index of hydrogen deficiency, and UI, that is unsaturation index. So, and double bond equivalent. Okay, so exam you can expect they will ask double bond equivalent. Okay, double bond equivalent. Okay, illana they will use degree of dissociation word. Okay, either they will use degree of dissociation or they will use double bond equivalent. Okay, double bond equivalent. Is it clear? Is it clear? Is it clear? So there is two case. Okay, there is two case to identify degree of unsaturation. Okay, DU. Okay, degree of unsaturation or double bond equivalent. So what is degree of unsaturation means? So listen carefully. So how many hydrogen molecule are required to break the double bond or triple bond? Okay, or I will tell you how many number of hydrogen molecule required to convert, okay, unsaturated molecule to saturated molecule. Unsaturated நீங்க இது ப்ராப்பரா தெரிஞ்சா போதும் மேம். டீச் பண்ணுவீங்களா மேம்? Yeah, I will try. Okay, I will try my maximum. Otherwise what I will do questions. Okay, அப்போ questions எடுக்கும்போது I will discuss content also. Okay, ஆல்மோஸ்ட் 19th 20th எல்லாமே உங்களுக்கு கம்ப்ளீட் கொஸ்டின் தான் போகும். ஓகே, கம்ப்ளீட் கொஸ்டின் தான் போகும். அந்த டைமில் நீங்கள் என்ன பண்ணணும்? அந்த டைமில் ஐ வில் எக்ஸ்பிளைன். ஓகே, கண்டென்ட் ஆல்சோ ஐ வில் எக்ஸ்பிளைன். ஓகேடா? ஓகே, ஸோ ஹியர் யூ கேன் சி ஐ வில் எக்ஸ்பிளைன். ஓகே, ஸோ ஹியர் நீங்கள் ப்ராப்பராக பார்த்தா போதும். ஓகே, இது எல்லாமே கான்செப்ட் ப்ராப்பராக தெரிஞ்சால் போதும். ஓகே, ஸோ ஹியர் யூ கேன் சி C double bond. Okay, C double bond தான் இருக்கு. So this double bond break பண்ணி it's actually unsaturation. Double bond break பண்ணிட்டு so in a single bond ஆயிருக்கு. Okay, single bond ஆயிருக்கு. Okay, single bond ஆயிருக்கு. So how many hydrogen molecule required? How many hydrogen molecule is required? Only one hydrogen molecule அல்ல? Only one hydrogen molecule. So I can write du is equal to 1. Okay, I can write du is equal to 1. Here you can see triple bond is there. Okay, triple bond is there. So here I want to break two bonds. Okay, I want to break two bonds to convert to saturated molecule. I want to break two pi bonds. Okay, I want to break two pi bonds. So it will become saturated molecule. So what is the du? Tell me, what is the du here? What is the du here? Tell me. So what is the du here? What is the du here? No, mechanism is not necessary. It's very simple mechanism. So mechanism is not necessary. We just need du. Okay, we will discuss mechanism after. Okay, so hydrocarbons எல்லாம் வரும்போது இதோட mechanism இருக்கு. அப்போ I will discuss. Okay, so what is du? Yes, du is 2. Okay, we are not writing number of hydrogen. Okay, Kashifa, we are not writing number of hydrogen. We are writing the hydrogen molecule. Okay, number of hydrogen molecule we are writing. Okay, number of hydrogen molecule. Yes, 4 hydrogen is there, but we are writing number of hydrogen molecule. Okay, so here we are writing number of hydrogen molecule. Hydrogen molecule is actually 2. Here also you can see hydrogen molecule. Okay, hydrogen molecule. Okay, so is it clear? Then what is the du? You can write the du here. Write the du. Write the du. How to find how many? Simple da. Simple. It's very easy. 1. How many bonds are there? How many pi bonds? Okay, number of pi bonds. Okay, I will write number of pi bond is equal to du. So how many pi bonds are there? How many pi bonds are there? 1, 2, 3, 4, 5. So du is equal to 5. Simple. Clear? Ipa clear ada? Ipa clear? I think Oliva. ஒலிவா கேட்டது. voice of aura. ஒலிவா clear இல்ல? Then there is one more point for cycle. In case of cycle, okay, when you consider this, that is case number 1, this is case number 2. So in case number 2, how many bonds? I will use this only, okay. How many bonds required to make this chain saturated compound, okay. How many bonds are cleaved, okay, cleaved to form open chain compounds, okay. So how many hydrogen molecule are required to break to form open chain saturated compound, okay. Yes, after this chapter I will give you 10 minutes break, no worries, okay. So here I will tell you one hydrogen molecule is necessary. So we can break this one side la one hydrogen, one side la one hydrogen. I can break this one side la one hydrogen, one side la one hydrogen. Simple da. For one ring, one du is 1. Okay. For one ring, du is 1. Okay. For one ring, du is 1. Is it clear? That I don't know da. That I don't know. Lerin ma'am anga irukku. Trishur. Lerin ma'am is Trishur. Lerin ma'am is from Trishur. So is it clear? One ring is equal to 1 du. Clear? Then I will give you a question. What is the du? Tell. What is the du? ஒரு 30 minutesல இந்த chapter முடியும். 4 o'clockக்கு இந்த chapter முடியும். I will give you ஒரு 15 minutes break. Okay? Here I can see lots of answers. Let me check. So I already mentioned that one ring, one du. So just count the ring number. Okay, one ring is there. 2, 3, 4, 5. Yes, du is 5 here. Very good. Du is 5. 5 rings are there. So du is 5. Then I will give you another question. So, and there is one more equation is there. To find, maybe they will give you molecular formula. Okay, maybe they will give you molecular formula. Then how we will calculate du? So it is very easy. Du is equal to C plus 1 minus H plus X minus N divided by 2. What is C? C means number of carbon. H means number of hydrogen, X means number of halogen, N means number of nitrogen, divided by N means, divided by 2. 2 is, so you will get du. Okay, we can do one question. So, yeah, you can find the du of the following compound. It is very important, guys. It is very important. இது like முன்னாடி questions எல்லாம் இது பேஸ் பண்ணிட்டு வந்திருக்கு. மேம் புரியல. case 2ல H2 molecule number of hydrogen case 2ல number of ring number of எவ்வளோ ring இருக்கு அதுதான் du. okay, second caseல number of ring. காஷிஃபா clear இல்லப்போ? second case 2ல number of ring எவ்வளோ ring வருது. And here you can use that equation. Do you remember that equation? So equation remember pannalana, I will write the equation again. So C plus 1 du is equal to, okay, du is equal to C plus 1 minus hydrogen plus halogen minus nitrogen divided by 2. You can write. அப்போ மேம் H2 molecule based பண்ணி H2 molecule தான், but I am giving a trick to remember. Okay, I am giving trick. Okay, actually I am giving the trick. Okay, I am giving the trick only. Okay, trick like you can easier calculate பண்ணதுக்கு எப்படி calculate பண்ணலாம் அதுக்காக I am giving a trick. Okay, so you guys are writing A2 துர்கா எல்லாமே calculate பண்ணிட்டேன். So number of X means number of halogen atoms, okay? Number of halogen atom, N means number of nitrogen atom, okay? N means number of nitrogen atom, X means number of halogen atoms. So here I can see everyone is writing answers. So I already written the answer. First, du is 2, here du is 1, here du is 1, here also du1. Correct answer kadichirka? Correct answer kadichirka? Two, one, one, one. 2, 1, 1. Correct. 1, 1, 1. Correct. Then I will give you another question. You can write the answer. How many degree of unsaturation are there in the following compound? This is also a previous year question. This is a previous year question. You can write. So you can write the answer. It's very easy question, but it's very important question. Okay, it's very easy question, but it's very important question. You can write the answer. Come on, quickly. 3. You guys are saying, Guru is saying 3, Rudra is saying 8, Samir is saying 3, Kashifa 8, Durga 11. That I don't know. I also want to check, Kallada. I want to check. So check. If you want, I will give you the hint for double bond. Okay, for double bond and triple bond, count the pi bond. Okay, count the pi bond. Okay, count the pi bond for double bond and triple bond. For cyclic structure, for cyclic structure, எவ்வளோ cyclic structure இருக்குன்னு structure made me sleepy. Structure organic தான் உங்களுக்கு எக்ஸாமுக்கு வரும். Okay, almost you can expect 16 to 18 question from organic. Jenny is also saying 11. Okay, so let me check. Okay, let me check. So here you can see triple bond is there, so 2 pi bond is there, 2. Here also 1, here also 1, here also 1, here also 1. So we can check how many cycle is there. 1, 2, here also 1, 2, 3 plus 4. Okay, cycle la 3 benzene ring ஆனதுனால என்ன benzene ring ஆனதுனால 3. Okay, 3 double bonds இருக்கு. அப்போ 3 cycle ஓடது 4. 4, 5, 6, 7, 8, 9, 10, 11. 11 is the correct answer. Du is 11. Du is 11. Clear? Du is 11. Clear? Gautu is saying, Gautu, every does 7. How you are getting 7? How you are getting 7? How you are getting 3? Tell me how you are getting answer. Not clear. Okay, I will tell you again. So, நமக்கு தெரியும் double bond. Okay, pi bond வரும்போது that is actually du. Okay, for pi bond. Okay, and for ring. Okay, for ring 1. Okay, ஒரு ரிங்குக்கு ஒரு du. Okay, 1 du. So 1 pi bond. இங்க எவ்வளோ pi bond இருக்கு? 2 pi bond இருக்கு. Okay, இங்க எவ்வளோ pi bond இருக்கு? 2 pi bond இருக்கு. So no, here 1 pi bond. Okay, here 1 pi bond. Here also 1 pi bond. Here also 1 pi bond. Okay, so pi bond இங்க பார்த்தா நமக்கு தெரியும் this is a benzene ring. Okay, here you can see 3 pi bond. Okay, so pi bond ஆதியம் calculate பண்ணிட்டேன். Then we can check. Okay, then we can check ring. Here you can see 1 ring. This is 2 ring. This is also another ring. For one ring 1 du. So 1, 2, 3. Okay, calculate 2, 3, 4, 5. இது 6, இது 7, இது 8, இது 9, இது 10, இது 11. கடிச்சாச்சா? Bunny, is it clear? Bunny. Where is Bunny? Sorry, ma'am, I slept. this time. I'm repeating again and again, don't sleep in this time, okay, because this time is actually very important. This is actually NEET exam time, okay. So 2 to 5 நீங்க தூங்கவே கூடாது இந்த 2 to 5ல. So I don't. So here also you can see lots of questions are there. Identify functional group, okay. So functional group identification எல்லாம் உங்களுக்கு தெரியும்ல. Yes, there is no sleep until 3. Okay, 3rd May. So 3rd May actually no sleep nu solla mudiyadhu, because you should sleep, okay. You should sleep at least 6 to 7 hours. That is very important, okay, because that is also very important. If you are not sleeping means your body will become very tired, okay. Your body will become very tired. appo adu next enna ungaloda body tired agumbodhu adu next enna venum, adukku drip kettanum illana hospitalized ஆகும். So that is also very important. So proper தூங்கணும், but இந்த டைம்ல தூங்கவே கூடாது. This time is actually very important, okay. So yes, identification of functional group. So functional group எல்லாமே உங்களுக்கு ஐடென்டிஃபை பண்ண தெரியும். So that I know. OH group எல்லா groups-உமே and functional group double bond triple bond functional group தான்டா. And we are moving to homologous series, okay. Daily anxiety level are at peak level. Not getting sleep. Not getting sleeping, ma'am. Hey, why da? Why not getting sleeping? You are only said, ma'am, I'm feeling sleepy. Now you are said, ma'am, I feel sleepy. Now you are saying, ma'am, not getting sleep. What is this here? So homologous series. What is homologous series? So a group or a series of organic compound each containing characteristics functional group form a homologous series. So it will form some group, okay. Some group will form during night time, okay. Then take your book and study, no issue, okay. So last ஒரு 10 days நீங்க உங்களோட biological cycle செட் ஆனா போதும். இப்போ தூக்கம் வரலனா போய் படி, no issue. Siaka not coming to your So a group or a series of organic compound each containing a characteristic functional group form a homologous series. So homologous series la I will simply tell you CH, okay. CH unit is actually CH2 oda CH2 or CH2 oda multiples, okay. Multiple of CH2 oda difference irukum. Multiple of CH2 ஓட difference, okay. CH2 or multiple of CH2 ஓட difference இருக்கு, okay. CH2 or multiple of CH2 ஓட difference இருக்கும். அப்படியா ஜெனி? okay, பார்க்கலாம், நமக்கு HCA பார்க்கலாம், okay. CH2 or multiple of CH2 ஓட difference இருக்கும். clear-ஆ? CH2 or multiple of CH2 ஓட difference இருக்கும், okay. Circadian rhythm are not working well. What is that, da? Okay, so I will tell you example. Here you can see C3H8, okay. C3H8 is forming C4H10, okay. C3H8 and C4H10. What is the difference? Difference is CH2 ஓட difference இருக்கு, okay. CH2 ஓட difference இருக்கு. Here you can see CH2 ஓட difference. So here you can see in this example you can see C2H6, okay. C2, this is C2H6, okay. C2H6O, okay. This is C2H6O and this is also C4H10O. What is the difference? 2CH2 ஓட difference, okay. 2CH2 ஓட difference, okay. So you know ஹெப்சி என்ன ஜெனி சொல்லி இருக்குன்னு தெரியுமா? ஸோ ஜெனி என்ன சொல்லி இருக்குன்னு பாரு பேக்ல. ஓகே, she is making problem. ஜெனி என்ன சொல்லி இருக்குன்னு பாரு. So So what will happen da? So here, what is the difference? 2CH2 oda difference தான் இருக்கு. So 2CH2 oda difference na, it is the multiple of, so it is the multiple of CH2. Okay, so Jenny is a boy, not girl. Jenny is a boy. So what is his name? That I don't know. So CH2 oda multiple da irukku. Okay, so it is 2CH2. Okay, it is multiple of CH2. Okay, so it is the multiple of CH2. Okay da, it is multiple of CH2. Clear? It is multiple of CH2. So da, that is actually homologous series. They will give you, okay, so they will give you in the question. In the question they will ask, identify the identify the homologous series for this molecule. Okay, they will give you one molecule and they will ask you the homologous series. Okay, clear? Oh, that I don't know. I thought Jenny is a girl. I thought, oh, Generio. Yeah, I have seen my Instagram, on my Instagram, Generio. Yes, here you can write. I have seen on my Instagram, Generio. Oh, Jenny. So I also thought Jenny is a girl. Oh yeah. So that I really don't know. Generio. Oh. Instadi. My name only. My name. My full name. Hepsi knows well. I am also shocked. Actually, Hepsi is revealing the gender. Hepsi is revealing the gender. Actually, I also don't know. I thought she is a girl. I thought she is a girl. I thought Jenny is a girl. Yeah, Jenny escaped. Ban MCK. Oh, it's very nice, very nice. Don't use Insta right now. Okay, tell me the answer. Yes, I can see 2. Yes, correct answer is 2 only. This is homologous series. It's called homologous series. Okay, in between that, lots of questions are there. We are moving to, anyway, we are moving to next topic. So, you know, pi bond, sigma bond, alla. So, coming back to chemistry. Yes, Gautu. And here also, hybridization is very important. Okay, hybridization is very important. So 0 lone pair 4 pi means it is sp3. 0 lone pair 3 pi means it is sp2. 0 lone pair plus 2 pi means it is sp. And 3 sigma, 0 lone pair plus 2 sigma. Okay, 3 sigma plus 1 lone pair, that is also sp3. 2 sigma 2 lone pair means that is sp2. 2 sigma 1 lone pair means that is also sp3. Okay, hybridization. Okay, then we are moving to main IUPAC naming. Okay, IUPAC naming Q-ka parunga. IUPAC naming lo or order is there. Okay, one order is there. You can see prefix. Okay, so there is a order. Okay, yes, already smashed. Yes. So prefix 2, prefix 1, word root, suffix and suffix 2. Okay, prefix 2, prefix 1, word root, suffix 1, prefix 2, prefix 1, word root, suffix 1, suffix 2. Okay, so what is prefix 2? Prefix 2, when you consider, okay, when you consider, you know, or same group, okay, same molecule contain, after this chapter I will give you, okay, same molecule contain more than one functional group. Okay, same molecule contain more than functional group. Okay, 4sp3 means 4 single bond. Okay, 4 single bond is there. Okay, okay da. So yes, if a molecule contain more than one sigma bond, okay, more than, not sigma bond, more than one functional group, okay, more than one functional group is there. Okay, so and the ரெண்டு groupல one group, okay, if we are considering two group, okay, one group is high priority group, okay, and another one group is a low priority group. So high priority group தான் நம்மளோட suffix 2, okay, high priority group is actually suffix 2 and low priority group is actually suffix, prefix 2, okay. High priority group is suffix 2 and low priority group is prefix 2, okay. So in the prefix 2 la substituents na main varum and illana branches, okay. For when you consider CH3, that is methyl group, C2H5, that is ethyl group, okay. And if OCH3 means that is methoxy group, ethoxy group, C2H5 means that is ethoxy group, okay. So ma'am, does this lecture include both? Yes, both the 11th and 12th organic complete, okay. So prefix 1 means cyclo, okay. If it is cyclo, you should mention cyclohexane, cyclopentane, okay. So that is prefix la cyclo. Prefix 1 means you should mention the cyclo group. And word root. What is word root? Word root means that is main chain, okay. That is actually main chain. So 1, 2, 3, 4, 5, 6 carbons இருக்குல்ல. So அதில main chain எதுன்னு identify பண்ணிட்டு that is actually word root. Then suffix 1. So suffix 1 means double bond, single bond, triple bond. அதுதான் suffix னு சொல்லும். Ein, in, ein. Okay. Ein, in, ein தான் suffix. And suffix 2 ல என்ன இருக்கு? Main functional group. Okay. Your main functional group. Yes, I will give you examples. No worries. Okay. So I will give you examples. No worry. So before that, I just want to share that priority order, okay. What is priority? Principal functional group is high prior. After that, multiple bonds. After that, number of carbon atoms. After that, maximum number of substituents, okay. Maximum number of substituents and lowest locant. What is lowest locant means? Lowest locant already இங்க எழுதிருக்கு. Branch number, branch க்கு low number வரணும், okay. So normally we will number பண்ணும்போது branch க்கு என்னடா lower number வரணும். So that is lowest locant, okay. Then alphabetical order la last priority தான் alphabetical order, okay. Start பண்ணலாமா? ஒரு example பார்க்கலாமா? அதுக்கு முன்னாடி I just want to, yes, principal functional group order priority order. Carboxylic acid is more prior, okay. Carboxylic acid is more prior. Then sulfonic acid, anhydride, ester, acid chloride, acid amide, and cyanide க்கு அப்புறம் isocyanide, aldehyde, ketone, alcohol, cyanide, amine. Okay, so this is very important. We can start. Okay, இப்பவே by heart பண்ணலாமா? Guys, இப்பவே by heart பண்ணலாமா? I think it's okay. Okay, loading. No, Guru, I think it's okay. So after this, I will give you break. Okay, ஒரு 15 minutes I will give you break. So எல்லாரும் இப்பவே by heart பண்ணிக்கோங்க. Carboxylic acid, sulfonic acid, anhydride. Okay, so இங்க 3 ஆசிடுக்கு in betweenல யார் வந்திருக்கு? ஹைட்ரைடும் எஸ்டரும் வந்திருக்கு. So we can start. Now it's loading. Oh my god, let me check. No da, it's working. It's a minute, ma'am. Okay, before a minute. Okay, இப்போ okay தானடா? Okay. So again loading. Oh shit, I don't know. Loading, ma'am. I don't know why it's showing loading. Because here we are using LAN only. Da. Here we are using LAN only. Now, okay. So we can by heart, okay. So we can by heart the order, okay. Principal functional group order, priority order. So we can start carboxylic acid, sulfonic acid. After that, anhydride, ester, acid chloride, acidamide, okay. Okay. So இது வரைக்கும் சீக்கிரமா படிக்கலாம். Okay, first carboxylic acid, sulfonic acid, anhydride ester, acid chloride, acidamide. Okay, acid chloride, acidamide. Okay, we can repeat carboxylic acid, sulfonic acid. Carboxylic acid is more priority. Okay, high priority. So high priority carboxylic acid, after that sulfonic acid, after that carbon. You should, okay, you should reply. Okay, carboxylic acid, sulfonic acid, anhydride ester, acid chloride, acidamide. Okay, after acidamide we can say that cyanide and isocyanide. It is easy. So idu varaikkum easy dana. And after that aldehyde ketone alcohol. So thionyl amine. Okay, thionyl amine. Amine is a group. So amine is a group. So amine oda enna already anga idu solli irukla. Clear. So this is actually very important. Okay, this is actually very important. So principal functional group suffix 2 la varumbodhu, that means high priority la varumbodhu. For example, carboxylic acid ku oic acid, sulfonic acid ku sulfonic acid na, anhydride ku oic anhydride, and ester ku oate, and acid chloride ku oil chloride, acidamide ku amide, cyanide ku nitrile, isonitrile ku isocyanide ku isonitrile, and aldehyde ku al, ketone ku on, alcohol ku all, thiol ku thiol, amine ku amine. Okay, amine ku amine. Clear? Yes guys, quickly smash the like button. Okay, and inga priority order prefix la varumbodhu, okay, priority order principal functional group enna varumbodhu eppadi varumbodhu prefix la varumbodhu. Okay, prefix la varumbodhu carboxylic acid ku carboxy group, sulfonic ku sulfo group, anhydride ku ஒண்ணுமே சொல்ல முடியாது. Okay, அது because அங்க prefix la வரும்ல. And ester ku alkoxy carbonyl, acid chloride ku chloro carbonyl, and அதுக்கப்புறம் acid chloride ku chloro carbonyl அது சொல்ல இருக்குல்ல. acidamide ku carbamide, cyanide ku cyano, isocyanide ku isocyano, and அதுக்கப்புறம் aldehyde க்கு aldo இல்லனா formyl groupனு சொல்லும், and ketone க்கு keto oxo சொல்லும், and alcohol க்கு hydroxy சொல்லும், thiol க்கு mercapto சொல்லும், amine is amino. This is actually ரொம்ப important. You should by heart all the name. Okay, you should by heart all the name. Prefix லையும் by heart பண்ணனும், suffix லையும் by heart பண்ணனும். It's very important. Organic la, this is actually very important. So we can write the name. Okay, we can write the name. Come on, try to write the name. Okay, try to write the name. Chat box la you can write A oda name எழுதலாம், B oda name எழுதலாம், C oda name எழுதலாம், D oda name எழுதலாம். Kyukka. Noda, like take the screenshot. Okay, screenshot எடுத்துட்டு வெச்சுக்கோ and you can use. Okay, take the screenshot and A 2-methyl propane, Genario 2,2-dimethyl propane. Olivia is crying. Olivia, what happened? Olivia illa, Oliva. Oh, Oliva, what happened? அது இல்ல ma'am, prefix after I'm asking general order. Okay, அது இல்ல ma'am, prefix after after என்ன வரும்போ என்ன வரும் I am asking. Prefix க்கு after prefix க்கு after ஒன்னும் வராதுடா, prefix தான் last. 2 second previous slide. 2 second previous slide. Take the screenshot. Yeah, Generio. Okay, 2 second. போதும்ல. So here I can see lots of answers. So anyway, I will write method proper. This is our main group and this is our branch. Okay, 2-methyl propane. And 1, 2, 3. This is our main chain. That is our word root. Method proper is our word root. Ma'am, prefix suffix la chain எந்த order வரும்? Prefix suffix la main chain எந்த order வரும்? Main chain புரியலடா, எனக்கு புரியல காஷிஃபா, டவுட் புரியல. Yes, and dimethyl propane 2,2. So 2CH3 group is there. So 2,2 dimethyl propane. So here you can see method proper butane. Second carbon la CH3. So 2-methyl method proper butane. Yes. 1, 2, 3, 4. Method proper butane. 2,2 dimethyl method proper butane. Then I will give you another molecule. Here you can write low number for branching. Yes, low number for branching. Branching க்கு low number வரணும். Yes, Generio. Jenny இல்ல, Generio. என் ஃபோன்ல இருக்கு. I will show you. Jenny ma'am, Jenny, Generio. Come on, write the name, okay? Write the name. Double bond is there. OH group is there. Main chain is there. Here also C double bond O, C double bond O is there. IUPAC in 2-methyl oct 6 in 3 all. Okay. Hexane. Okay. Let me check. So 1, 2, 3, 4, 5, 6, 7. So here we should give so OH is here. So OH க்கு என்ன வரணும்? Least number வரணும். So I'm numbering 1, 2, 3, 4, 5, 6, 7. So 7. So what will happen? So 5th carbon la என்ன இருக்கு? So this is OH group is a main group. Okay, OH group is after this session. Okay, I mean after this chapter I will give you. Okay, OH group is a main group. So you can write methyl is a branch. Okay, so 5-methyl oct 6. Okay, oct 6 in. So 6 in illada. So I think it's 5 in. Okay, not 6 in. 5 in. Okay, so it is 6 in varuma. 1, 2, 3, 4, 5 தான் வருது. 5 in தானே. 5 in or n. N is also correct. Okay, 5 n தான் வரும்ல. 1, 2, 3, 4, 5. 5ல தான் double bond வருது. So you can write 5 n 3 all. Correct. Hi. ஒரு 5 to 10 minutesல finish பண்ணலாம். So next molecule here you can see this molecule. This is a molecule. So என்ன பண்ணணும்? ரெண்டுமே keto group தான். Okay, keto group தான் இருக்கு. So keto groupக்கு கம்மி நம்பர் வரணும். Okay, keto groupக்கு என்னடா கம்மி நம்பர் வரணும். So 1, 2, 3. So இங்க பார்த்தா 1, 2, 3. So here also 3, here also 1, 2. இங்க பார்த்தா 2 வருது, இங்க பார்த்தா 3 வருது. So கம்மி நம்பர் இங்க இருந்து போடணும். Clear? So meth, eth, proper, butyl, pendehex. Hex is there. And second லையும் fourth லையும் ketol இருக்கு. So dione. Okay, dione. Clear? Clear da? I hope it's clear. Yes. I will give you break. I will give you break. I will give you break. Yes. And vowels வரும்போது you can cut. Okay, you can cut E. Okay, you can cut here E. Okay, you can cut here E. Vowels வரும்போது. Then இங்கேயும் like lots of examples எல்லாம் இருக்கு. So maximum try பண்ணுங்க. Okay, maximum examples எல்லாமே இன்னைக்கு finish பண்ண பாருங்க. So we will start isomerism. Okay, we are going to start isomerism. I know you guys are asking isomerism, ma'am, can you take isomerism? So we can start isomerism. Soda. What is time now? Okay. Yeah, correct. கரெக்டு தான்டா, 6 தான் வரும். நான் அங்கே சேஞ்ச் பண்ணியிருக்குன்னு நினைக்கிறேன். ஸோ அங்கே 6 தான் வரும், அங்கே சேஞ்ச் பண்ணியிருக்கு. அங்கே டபுள் பாண்ட் கவுண்ட் பண்ணும்போது டபுள் பாண்ட் தான் வரும். ஓகே, 6 தான் வரும். இப்போது நான் எல்லாரும் சொல்கிறேன், இட்ஸ் 4-7. ஓகே, 4-7. 4-20. 4-17. Yes, correct. இப்போ எவ்வளோ லைக் ஆயிடுச்சு? 223. ஸோ 250 லைக். ஸோ பிரேக் முடிஞ்சு வரும்போது 250 லைக்ஸ் வேணும். ஓகே, should we read NCERT? For what? Isomerism? No, don't read NCERT. Oh, I will speak Malayalam. എന്താ സംസാരിക്കണ്ടേ? സുഖാണോ? Okay, so പോയി round. No, എതുക്കടാ round off? We don't have time. We don't have enough time. So you want to round off the time also. So I will round off this time to 20. Is it okay? IUPAC and GOC finished. Yes, we will finish isomerism in 1 hour. Okay. டீ காஃபி எல்லாரும் சாப்பிட்டு வந்துட்டீங்களா? டீ காஃபி எஸ். டீயோட என்னடா இங்க நடக்குது? டீ டீ பிசினஸ் ஆடா? டீ பிசினஸா? இங்க என்னடா கைண்ட் ஆஃப் which kind of tea you like? டீக்கு என்னடா டைப்ஸ் இருக்கா? பூஸ்ட் குடிச்சாச்சு. பூஸ்ட் நீங்க டீ சாப்பிடும்போது நான் பூஸ்ட், எனக்கு எனர்ஜி வேணும்ல. ஸோ 250 கேட்டது நீங்க எனக்கு கொடுத்தது 230. 250 கேட்டுட்டு நீங்க எனக்கு கொடுத்தது பூஸ்ட் ஹார்லிக் பிஸ்னஸ் ஆவாம். இல்லடா, பூஸ்ட் பிஸ்னஸ் ஒன்றும் இல்லை, அவ்வளோ ஆகலடா. NCERT is not needed. Line by line, no reactions mechanism that we need. Okay, when you consider organic, for organic reactions mechanism we need. Okay, reactions mechanism we need. Okay, reaction mechanism தான் நமக்கு தேவை. So start பண்ணலாமா? So கொஞ்சம் எக்ஸசைஸ் எல்லாம் பண்ணிட்டு just a second. தரதான Yes guys, now we are moving to isomerism. Isomerism, note name T is identity. Here we call you T. Arun, what happened Arun? Hepsi akka enga pochu? Hepsi akka, where is Hepsi akka? How to do resonance ada? So we are discussing about isomerism. Guys, I think you all are ready. So you know what is isomerism la. So you know, I feel kannaveli. So you know what is isomerism. So tell me guys, what is isomerism? Yeah, Hepsi akka famous. Hepsi akka famous. Hepsi akka famous illa. நம்மள மாதிரியா? ரொம்ப ஃபேமஸ் அக்கா. So tell me guys, what is isomerism? Iso means same. Okay, so tell me what is isomerism. So நீங்க ஸ்கூல்ல இருந்தே isomerism என்னன்னு படிக்குது. So tell me what is isomerism. Tell me quickly. Yeah, Hepsi akka becomes famous. Where is 𝐺𝐸𝐸𝑎? Where is 𝐺𝐸𝐸𝑎? So we can start now. Okay. Okay. Why ma'am? No, I am just kidding guys. Just kidding. No, I will call him 𝐺𝐸𝐸𝑎. I will call him 𝐺𝐸𝐸𝑎 only. So everyone is thinking Jenny is a girl. Oh, he don't like 𝐺𝐸𝐸𝑎. He is changing his identity. You know, he is changing his identity. Okay, don't worry. Okay. So, okay, we can start. Guys, what is, yes, note is enough for organic, ma'am, your note. Yeah, note is enough, da, but you should do maximum questions, maximum problems, okay? So, here we are discussing only important thing, okay? Okay, so here we are discussing important concept only. So, we can expect question from some like like other than important topics la irundu, okay? There is chance, okay? So, yes. So, கண்ணு வலிக்குது, லைட் வருதுல்ல, so கண்ணு வலிக்குது, அதுக்காக, okay? So, yes. So, isomerism. Guys, what is isomerism? What is isomerism? So, what is isomerism? So, molecule which have same molecular formula but different structure or physical property, chemical property, that is different, okay? So, same molecular formula but different structure and physical property, chemical property எல்லாமே different இருக்கும். But அங்க என்ன same molecular formula I'm saying same இருக்கும், okay? same இருக்கும், okay? So, type of isomerism, okay? So, mainly என்ன structural isomerism இருக்கு, stereo isomerism இருக்கு. Structural isomerism, stereo isomerism தான் important, okay? Structural and stereo isomerism. So, first we are discussing about type of structural isomerism. So, type of structural isomerism. First one is chain isomerism, okay? Isomerism. So, first one is chain isomerism, position isomerism, metamerism, functional isomerism, tautomerism, ring chain isomerism, okay? We can start. எல்லாரும் GOC finish பண்ணிட்டேன். Yes. So, first we are discussing about chain isomerism, okay? Chain isomerism, okay? First one is a chain isomerism. What is chain isomerism? Compound which have same molecular formula. Isomer means same, okay? Same. So, iso means same molecular formula but having different parent carbon chain, okay? Parent carbon chain என்ன different இருக்கும், but இங்க என்ன molecular formula same இருக்கும். பார்க்கலாமா? So, 1, 2, 3, 4, C4, 6, 7, 8, 9, 10, C10, H10. So, here also 1, 2, 3, 4 carbon, C4 carbon, H10, H10. So, here you can see molecular formula is same, but here you can see chain, okay? This is a complete one chain, okay? So, method proper butane, okay? So, inge உங்களுக்கு என்ன பார்க்க முடியும்? You can see one branch, okay? One branch is there, okay? One CH3 branch, methyl branch is there, okay? One methyl branch is present, okay? So, here you can see one methyl branch is present, okay? That is actually chain isomerism. Next, we are moving to position isomerism. What is position isomerism? So, compound which having same molecular formula but have different position of branch. Branch oda position illana functional group oda position le difference irukum, okay? So, here you can see alcohol, OH group is there, okay? So, OH group is there. So, OH group first carbon la vandirukku. This is 1, 2, 3, 4, okay? So, here also 1, 2, 3, 4, okay? So, inga OH first group la vandirukku. First carbon mele OH is attached, okay? OH is bonded with the first carbon. Here, OH is bonded with the second carbon. OH is bonded with the second carbon. Clear? OH is bonded with the second carbon. And my dear students, we will consider double bond and triple bond. நமக்கு தெரியும் multiple bonds இருக்கு. So, multiple bonds நாம என்ன functional group consider பண்ணும், okay? Normally உங்களுக்கு double bond and triple bond தானே, how we will consider it as a functional group, but it is a functional group, okay? When you consider double bond and triple bond, this is also a functional group, okay? This is also a functional group. Then when you consider this CN is there, okay, nitro group is there. So here you can see 1, 2, 3, 4, 5. So third carbon la CN irukku. Here also 1, 2, 3, 4, 5, 6. This is also same da varudda. So idu same. It's actually exactly same molecule. There is no difference. It is identical molecule. Okay, it is identical same molecule. We can't consider it as a position isomerism. So இது எப்படி position isomerism consider பண்ண முடியும்? So இங்க இருந்து least number CN க்கு என்ன least number வரணும். இதுவும் third தான் வருது. So இதுவும் third தான் வருது. So இது change பண்ணிட்டு இங்க எங்கயாச்சு CN போட்டா 1 2 3 அப்பவும் 3 தான். 1 2 1 2 3 அப்பவும் 3 தான். So yes இங்க போடலாம். இங்க போட்டா okay. Okay. இங்க போட்டா okay. So இல்லாம அது this is not considered. Okay. So இது consider பண்ண முடியாது. This is actually identical molecule தான். Okay. Identical molecule தான். Then we are moving to metamerism. Okay. What is metamerism? Same pitch. Yeah, yeah, same pitch only. So next we are discussing about metamerism. What is metamerism? So compound which have same molecular formula. Isomer means same molecular formula only. Okay. But have different arrangement of atom or group, either sides of bridging of functional group. Okay. So I will tell you. So here it should can link or bridge with the two sides. Okay. When you consider ether la eppadi irukku? Two oxygen irukla. So oxygen can make bond or create bond in two sides. Okay, oxygen can make bond in two sides, two bond. Okay, two bond. Here also R group, here also R dash group. These type of group will form metamerism. Okay, these type of groups will show metamerism. Okay, so for example, and here you can see ketone is there, and secondary amine and tertiary amine is also another example. Okay, tertiary amine is another example. So here also R dash R double dash group. Okay, ester also. Ester here and inga irundhu one group attach பண்ணலாம், inga irundhu வேற ஒரு group attach பண்ணலாம். So இந்த மாதிரி two groups attach பண்ண முடியும்ல. So different, okay, different arrangement same atomல இல்லனா same groupல different arrangement through or different, it can make bond through either side. Okay, it can make bond through either side. That is actually metamerism. Okay, that is actually metamerism. Is it clear, guys? Is it clear? It is metamerism. Okay, so இது எல்லாமே metamerismத்துக்கு example தான். So here you can see. Okay, here you can see this is forming metamerism. Okay, so இங்க 1 2 3 carbon இருக்கு, இங்க 1 carbon தான் இருக்கு. So yes, metamerism இங்கேயும் இருக்கு. Okay, so இந்த two molecules are showing metamerism. So proper பார்க்கணும். So 1 2 and 3 molecules. So இங்கேயும் 3 carbon இருக்கு, இங்க 1 carbon இருக்கு, இங்க 3 carbon இருக்கு, இங்க 1 carbon இருக்கு. So guys, எனக்கு ஒரு doubt, இந்த molecule metamerism possess பண்ணுவீங்களா இல்லையா? So is this molecule possess metamerism with this molecule, with this molecule, with this molecule? Illa. Here you can see only 2 carbon atom is there. Here also 2 carbon atom is there. So carbon number either one side la number of carbon same ah irukano. Okay, either one side la carbon number of carbon same ah irukano. Okay, either one side la. Okay, two branches form agula. So two connection irukula. So and the two connection la one side la, at least one side la number of carbons illana chain enna same ah irukano. Clear ah? Clear ah? Is it clear, guys? Yes, yes, I can teach up to 12. No worries. Is it clear? Yes, I am ready. Is it clear? So next is functional isomerism. Okay, next is functional isomerism. Pavitra, yes, what is your doubt? Okay, okay. So either one side, okay, either one side should have same, okay, same number of carbon, okay, either one side should have same number of carbon. Here 3 carbon is there, so here also 3 carbon is there, metamerism is there. So here you can see 2 carbon is there, here also 2 carbon is there, so there is no metamerism with this molecule or with this molecule, okay. So it should contain same number of carbon either in one side, okay, either in one side, okay. We know that 2 different branches are there, so either one side it should obey, or it should contain same number of carbon. Is it clear? Is it clear? Is it clear? Then we are moving to functional isomerism, okay. We are moving to functional isomerism. Is it clear? Yes. So metamerism, here you can see it's very simple. It's very simple. Here you can see. Here you can see this molecule will possess metamerism, okay. This molecule will possess metamerism. Why? Because I will tell you. Here you can see 3, okay, 3 carbons are there, okay, 3 carbon atom is there. Here also you can see 3 carbon atom is there, okay. So either one side it should contain same number of carbon, okay, either one side, okay, this side or this side, okay. Either one side it should obey, it should contain same number of carbon. So when you consider this one, okay, this molecule, here you can see 2 carbon atom, here you can see 2 carbon atom. So here it is 3 and here it is 1. So it is not metamers, okay, it is not metamers. Why? Because different number of carbon atom, okay. Why it is? Because different number of carbon atom, okay, clear, okay. Then we are moving to next type, that is functional isomerism, okay. We are moving to next isomerism, that is functional isomerism. What is that? Compound which have same molecular formula. So compound in a, we know that any isomerism means, isomers means it should have same molecular formula, but here functional group is different, okay, but the functional group is different. So here you can see alcohol and ether will show, okay. So other molecule will also show, but most of the time alcohol and ether will show functional isomerism, and acid and ester will show functional isomerism, and aldehyde ketone will show functional isomerism. Is it functional isomers? Is it functional isomers or not? Is it functional isomers or not? Is it functional isomers or not? Is it? Is it? So why? It's loading. No, just check. Okay, so here you can see, yes, different functional groups are there. Here it is carboxylic acid, here is it aldehyde and ester, okay, aldehyde and ester. We can write the molecular formula. Just write the molecular formula. Just write the molecular formula. Tell me in the chat box, write the molecular formula. It's loading, buffering. I think it's because of this issue, okay. It's maybe a YouTube issue, I think. Yeah, I think it's YouTube issue da. Yesterday also there is some YouTube issue. So yes, you can see. So tell me the molecular formula quickly in the chat box. Everyone write the molecular formula of these molecules. Write the molecular formula of this molecule. 𝐶𝐞. I am not asking the name. I am asking to write the molecular formula. Just write the molecular formula. Just write the molecular formula. Nobody is writing molecular formula. You don't know the molecular formula? 1, 2, 3, 4 carbon is there. Okay, here also 1, 2, 3 carbon is there. And here also I will draw one more molecule. So this also 1, 2, 3, 4. 1, 2, 3, 4. Yes, it will become correct. CH3, CH2. So it is C 1, 2, 1, 2, 3, 4. C4, H 6, 3, 4, 5, 6, 7, 7, 7, 8. 8H 1, 2, O. O2. This is the molecular formula. Here I will write 1, 2, 3, 4. C4, H 3, 4, 5, 6, 7, 7, 8. O, yes. O2. So here you can see molecular formula is same. Okay, so I will draw the proper structure. Okay, this is the proper structure. Okay, this is the proper structure. Okay, so this is the proper structure and molecular formula is C4H8O2. Okay, so both the molecular structure is same. Okay, both the molecular structure is same. Yes, it is COOH, correct. So it is carboxylic acid. Okay, first one is carboxylic acid, second one is here it is aldehyde, and this is ester. Okay, this is ester group. Okay, so yes, there is two different functional group. Okay, so here you can see this is carboxylic acid and this is aldehyde and ester. So that means the functional group is different, molecular formula is same. So it is a functional isomerism. So it is a functional isomerism. Is it clear? Is it clear? So is it clear? Then we are moving to tautomerism. Okay, we are moving to tautomerism. It is also very important. Keto-enol tautomerism is very important. Okay, keto-enol tautomerism. What is tautomerism means? Intramolecular transfer of proton. Okay, intramolecular. So proton na enada H plus oda transfer da. Okay, H plus oda transfer da actually tautomerismthila nadakudhu. Okay, H plus oda transfer. Okay, so here you can see. Okay, here you can see a molecule. So I'm taking a molecule. This is keto. Okay, keto group. Okay, C double bond O is there. Okay, then what will happen? What will happen? This double bond will break. This double bond will break. So it will form. So it will form double bond. Okay, in the double bond break, it will form double bond, and this hydrogen will come with oxygen. Okay, come with oxygen. Okay, appo enna nadakunda? It will form enol. So inga irukra hydrogen enna? Oxygen கிட்ட போயிருக்கு. Okay, oxygen கிட்ட போயிருக்கு. So இங்க இருந்த double bond break ஆகி it will form double bond. Okay, it will form double bond. Okay, இதா, this is keto group and this is enol group. Okay, I hope it's clear. Second order structure ஆடா. Second order structure என்ன பிரச்சனை? CH2 COH double bond CH2. This is keto-enol tautomerism. So what will happen? Yes. So what will happen? So this double bond will break and it will form. Here it is single bond. Okay, it will form double bond, and this hydrogen, this bond will break and hydrogen will go to oxygen side. Okay, hydrogen will go to oxygen side. So it will form OH. Yes, it will form OH. This bond will form single bond. Yes, this will form single bond. And Here it will form double bond. Here it will form double bond. Is it clear, guys? Is it clear, guys? This is keto group and this is enol. So keto-enol tautomerism. Keto-enol tautomerism. So keto-enol tautomerism. Intramolecular transfer of hydrogen. So what is intramolecular? In same molecule, hydrogen is transferring. In a same molecule, hydrogen is transferring in a same molecule. This is one molecule. Hydrogen is transferring. Okay. Hydrogen is going to oxygen. Okay. So it's going to oxygen. Okay. Going. Clear? So here it will form OH, OH, and here it will form double bond. Okay. I hope it's clear. I hope it's clear. I hope it's clear. No, it's not confusing. It's easy only. So they will ask, okay, Toto exhibit or not. Okay. In your exam, you can see that tautomerism will exhibit or not. So if tautomerism exhibit means, okay, tautomerism exhibit means it should contain alpha carbon. Okay, and that alpha carbon should be sp3. Okay, I will give you. No, don't worry, Kashifa, I will tell you. Okay, so that carbon should contain alpha hydrogen also. Okay, then we can say that yeah, this molecule will possess tautomerism, or this molecule will exhibit tautomerism. So here you can see. Here you can see. This is double bond. Okay, so this is double bond. If this double bond carbon, okay, it's the double bond carbon contain hydrogen means, yes, it will possess, yes, Puriyala, I will tell you. Tautomerism means, listen carefully, it is very important. Okay, what is tautomerism? Tautomerism means intramolecular transfer of proton. Okay, so it is actually intramolecular means what is that? So in same molecule, okay, same molecule will, okay, same molecule hydrogen transfer you can see. Okay, so same molecule hydrogen transfer nadakkum, same molecule la irukra hydrogen enna transfer agum, that is actually tautomerism. Okay, tautomerism means, so here you can see this is the hydrogen. Okay, idu oru molecule, in the molecule enna irukku, this is actually keto group. Okay, keto group la enna irukku, so alpha carbon da. So in the O attach பண்ணி இருக்கிற carbon பக்கத்துல இருக்கிற carbon is actually alpha carbon. So this alpha carbon என்ன, containing hydrogen is alpha hydrogen. So in the alpha hydrogen யார் பக்கத்துல போகும்? Oxygen பக்கத்துல போகும். Okay, so oxygen மேல என்ன இருக்கு? Double bond is there. So இந்த double bond break ஆகி single bond ஆகும். So இந்த double bond எங்க போகும்? இங்க carbon okay, carbon கிட்ட போய் it will form double bond. Okay, that is actually, okay, yes. So இங்க என்ன, அந்த double bond இங்க double bond ஆயிருக்கு. So இங்க இருக்கிற hydrogen இங்க போயிருக்கு. இப்போ clear ஆனோ? இப்போ clear ஆ? Means it transferring to oxygen. Yes, yes. So the hydrogen will, clear ma'am. Yes, Pavitra and Ganesh and Kashifa. Now clear la? Yes. இதோட பேரு, this is keto group. Okay, C double bond O, இங்க ஒரு R group, இங்க ஒரு R group. This is a keto group. Okay, and this is enol will form OH. Okay, and double bond is there, so we will say it is enol. Okay, so keto enol, so we will say keto enol tautomerism. Yes. So tautomerism exhibit means, okay, they will ask tautomerism exhibit or not. Okay, so if tautomerism there means you should find a alpha carbon. Okay, if alpha carbon is present means, and that alpha carbon should be sp3 hybridized. Okay, if alpha carbon should be there, and that alpha carbon should be sp3 hybridized. Okay, that alpha carbon should be sp3 hybridized, and that alpha carbon should contain alpha hydrogen. Okay, that alpha carbon should contain alpha hydrogen. Then we can say yes, tautomerism tautomerism will exhibit. Okay, then we can say that yeah, tautomerism will exhibit. So if they are asking means you should first check alpha carbon, and that alpha carbon should be sp3, and then you should check alpha hydrogen. Okay, next is ring chain isomerism. Ring chain isomerism means it is compound which having the same molecular formula. So compound which having same molecular formula, but one should be ring. Okay, one should be ring and the other structure should be open chain. Okay, one structure should be ring and another structure should be open chain. Okay, we can check the molecular formula. So C3 H456. Here also C3 H6. Okay, correct. Okay, so this is actually ring chain isomerism. Is it clear, guys? Is it clear? 12th result epoda? 12th result epoda? 12th result one varala. 12th result epoda? 12th result epoda? Yes, cyclopropane and propene. May 8th. Oh, like bio edukada bio? Cyclic ring same amma. Yes, cyclic na closed structure irukanunda. Ring na you can see here. So ring is a closed structure. Okay, ring is a closed structure and ring chain, and chain means here you can see it's a open structure. Okay, one should be open and other structure should be closed. Okay, one should be ring and cycle is same. Yes, same only. Ring and cycle is same only. Okay, it's closed structure, we will say ring or chain. Acha, ring or cycle. Okay, clear? Then waiting edukada. So உங்களோட 12th result ஆல உங்களோட life decide பண்ணவே முடியாது. Okay, உங்களோட 12th result, if you are getting good mark, if you are not getting good mark, it can't decide your life. Okay, your 12th mark can't decide your life. Topper waiting. So your 12th mark can't decide your life. So 12th mark, okay, உங்களோட 10th mark மாதிரி தான், அவ்வளோதான் 12th. ஓகே, அவ்வளோ டென்ஷன் அடிக்க வேண்டாம். ஸோ இதுக்கப்புறம் நீங்கள் என்ன கோர்ஸ் எடுக்கிறது அண்ட் அந்த கோர்ஸுக்கு அப்புறம் நீங்கள் என்ன ஜாப் இருக்குது, ஸோ இது எல்லாம் தான் இம்பார்ட்டண்ட். ஓகே, இது எல்லாம் தான் இம்பார்ட்டண்ட். ஓகே, ஸோ கைஸ் இட்ஸ் வெரி இம்பார்ட்டண்ட். இட் இஸ் வெரி இம்பார்ட்டண்டா, இட் இஸ் வெரி இம்பார்ட்டண்ட். ஓகே, ஸோ alkane formula, name and number of structural isomerism they will ask. Okay, they will ask the structure of isomerism. Okay, they will ask number of structure of isomerism. If CH4, in case of methane la number of structural isomerism is 1, you should by heart this. Okay, 1 1 1 2 3 2 1 1 1 2 3 5 9 18 35 75. adha values is very important. Okay, so when you consider CH4 in methane, there is only one structural isomerism is there. When you consider ethane, only one structural isomerism. When you consider propane also contain only one structural isomerism. When you consider butane contain 2, pentane 3, and hexane 5, and heptane 9, octane 18, nonane 35, and decane 75. Okay, this is very important. By heart பண்ணிக்கோங்க, இப்போவே by heart பண்ணிக்கோங்க. You should by heart. Illana, there is one like equation is there, that is a du equation. Okay, du equation இருக்கு, ஆனாலும் du equation படிச்சு அது லாஸ்ட் ஃபைண்ட் பண்ணணும்னா it's very difficult. Okay, it's very difficult. So just by heart it. Okay, so இது first இது by heart பண்ணிக்கோங்க. So rest I will tell you. Okay, rest I will tell you. Okay, so when you consider a molecule C4, H8. Okay, so C for H8 கொடுத்திருக்கு. So இதோட they will ask இதோட structural isomerism. Okay, so they will ask இதோட structural isomerism. How we will find structural isomerism of this molecule? So we know du. Calculate du. So now only I just shared that formula of du. You can write. Find du. Du. Find du. Shalini is saying 1. Jahi 1. Any Oliva, Hepsi, Sasmita, Hepsi. What is the du? Calculate the du value. You forget the equation. Now. So C plus 1 minus H plus X minus N divided by 2. This is the equation. Sasmita, what is your answer? Tell me. So number of carbon is 4 plus 1. Number of hydrogen is 8. There is no halogens, no nitrogen. So 5 minus 8 by 2. So 8 by 2. So that is equal to 5 minus 4. That is equal to 1. That is equal to 1. Okay. That is equal to 1. So you will get answer 1. Okay. You will get answer 1. So we will get answer 1. Du is 1. So what you should do? You should make compounds. Okay. You should make molecules. Okay. So இதில இருந்து du1 வரணும். அப்ப எவ்வளவு moleculesக்கு options இருக்கு, chances இருக்கு. ப்ராப்பரா பாருங்க சஸ்மிதா. So guys, one molecule is 4 carbon. Yes, 1, 2, 3, 4. 1, 2, 3, 4. So one molecule. Okay, this is one molecule. Structural isomer. 1, 2, 3, 1, 2, 3, 4. And this is another molecule. Okay. So du is 1. Okay, adu vachu you should find. Okay, you should find. Okay, 1, 2, 3, 4. One molecule. 1, 2, 3, 4. And another one molecule. One inge one. First carbon le, second carbon le. Adudhaan varum. And you should check. Okay. And there is one more option. Okay, branches is there. Okay. 1, 2, 3, 4. And this also. This is a branch. Okay, branch is there. And another one is 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay. So this is another one. And another structure is this 1, 2, 3, 4. 1, 2, 3, 4. Yes, this is another structure. இது எல்லாமே டியோட ஸ்ட்ரக்சர் தான். So number of structural isomerism is 1, 2, 3, 4, 5. 5 is the structural isomerism. Clear? Here you can see that double bond is not there. Okay. double bond is not there. Double bond in the du is equal to du will become 2. Okay, du will become 2. So this way you should find number of structural isomerism da. So I will tell you again, I will repeat again. So proper focus pannirunga. So here we know that du is 1. Okay, du is 1 means we know that either cyclic structure or alkene structure. Okay, du1 means either cyclic structure. Okay, cyclic structure varumbodhu what will be the answer? Du is equal to 1. So and double bond varumbodhu enna du 1 தான் வரும். Okay, so இதுல எவ்வளோ டபுள் பாண்டுக்கு சான்சஸ் இருக்கு? ஃபர்ஸ்ட் யூ ஷுட் செக் தட். ஓகே, எவ்வளோ டபுள் பாண்டுக்கு சான்சஸ் இருக்கு? ஸோ ஃபர்ஸ்ட் கார்பன்ல யூ கேன் சி டபுள் பாண்ட் ஆர் செகண்ட் கார்பன்ல யூ கேன் சி டபுள் பாண்ட். ஓகே, ஸோ தெர் இஸ் ஒன்லி 2 சான்ஸ் ஃபார் டபுள் பாண்ட், first carbon and second carbon. And next one is branch. Okay, one branch is there, or inge enna branch la inga carbon போடலாம். So you can consider இது branch consider பண்ணலாம். இது that is your main carbon group. Okay, that is main carbon group, second one. And so here du is 1, du is 1, du is 1. So here, okay, so closed structure varumbodhu du is, we know that du is 1. So here when you consider this one, this is a cyclic structure, du is 1. So here you can see one cyclic structure is there, one branch is there. Okay, 1 2 3 4 carbon. So 4 carbon வர்ற எவ்வளோ structure du1 ல உங்களுக்கு make பண்ண முடியுமோ make பண்ணிக்கோங்க. That is the number of structural isomerism. Is it clear, guys? Is it clear? Is it clear? Is it clear? Is it clear or not? Clear. Clear, clear, clear. Okay. Then we are moving to stereoisomerism. Okay. Stereoisomerism means it is actually the compound that have same constitutional and sequence of covalent bond but differ in relative position of their atom, group of atoms in spaces. Same molecular formula. Okay, same molecular formula, same structure, everything is same, but the arrangement in space is different. Okay, so the arrangement in space is different. So in a proper structure irukum, so ellame proper same to same irukum, but the enna different irukum, you can see the arrangement in space is actually different. The arrangement in space is actually different. Is it clear? Is it clear? So we can consider, so when you consider stereoisomerism, okay, stereoisomerism, there is two different type of stereoisomerism. Okay, there is two different type of we will discuss that. So there is two different type of stereoisomerism. One is geometrical isomerism, another one is optical isomerism. Okay, one is geometrical isomerism, another one is optical isomerism. Okay, so what is geometrical isomerism? So isomers which arise due to restricted rotation. Okay, inga restricted rotation irukum. Okay, so rotation enna restricted ah irukum. So restricted rotation is present in double bond and ring. Okay, that restricted rotation you can see in double bond or in ring. Okay, double bond liyum ring liyum mattum enna you can see geometrical isomerism. Okay, geometrical isomerism you can see in double bond or in ring. Okay, so yes, coordination compounds here I can see. Yes, coordination compounds. Okay, so they will ask, okay, in question they will ask geometrical isomerism exhibit or not. Okay, they will ask geometrical isomerism exhibit or not. So how we will check, I will tell you. C double bond C, A, B, C, D. So the 4 groups attached with carbon is actually different. Okay, yes, 4 group attached with carbon is actually different, completely different. Okay, so yes, this molecule will possess geometrical isomerism. Okay, this molecule will possess geometrical isomerism. So when you consider C double bond C, AA, BB, is this molecule will possess or exhibit geometrical isomerism? Is this molecule will exhibit geometrical isomerism? Is this molecule will exhibit geometrical isomerism? You guys are saying no. Shalini is saying yes. Yes, this molecule will also possess geometrical isomerism because in the carbon mele two different group da irukku. Okay, same one carbon mele two different group. Okay, different groups are there. Okay, different group. It is different group A and B. So இது another carbon. This is another carbon. So this carbon containing another A and B group. So this molecule also possess or exhibit geometrical isomerism. Clear? Yes, it will also possess geometrical isomerism. Yes, is it clear? Yes, isomerism. Oliva still loading. I'm not first bench student. Never, ever. I don't want to become. I want to enjoy my life. I want to study. Okay, so tell me. Yeah, I will tell you. So, I will tell you geometrical isomerism. So, geometrical isomerism means restricted site must have different group. Okay. So, what is restricted? Geometrical isomerism. Okay. It does not exhibit geometrical isomerism. Video stuck. This is not geometrical. This molecule does not possess geometrical isomerism. கிடையாது because in the carbon la same molecule வருது. So restricted site means this is one restricted site and this is another restricted site. Okay, so here this carbon also contains same molecule, so same group. So I hope it's clear. If it is clear, give me some thumbs up in the chat box, guys. If it is clear, give me some thumbs up in the chat box. Clear? Okay. I hope it's clear. Here you can see. This molecule exhibit geometrical isomerism or not? This molecule show or exhibit geometrical isomerism or not? It's very simple. This is our restricted site. Okay, this is our restricted site. So in this restricted site, you can see two different groups. Okay, so two different group. Here also it is two different group. So it will exhibit geometrical isomerism. Okay, when you consider this one, yeah, this will also possess geometrical isomerism, and this carbon is actually sp3 carbon also. It is sp3 carbon also. Okay, so it is sp3 because it is like what? It is what I'm saying, cycle, a ring. Okay. Cis trans I will tell you. Okay, cis means same site, trans means different site. Is it clear? Both exist. Clear? Rudra, listen carefully, okay, Rudra. So, restricted site must have different group. What is restricted site? So here this carbon is a restricted site. Okay, this carbon. Okay, this carbon. So yes, it contains two different group. When you consider this carbon, yes, this carbon also contain two different group. So when you consider this carbon, so yes, this carbon is contain different group. It is restricted carbon. So this carbon contain two different group. Yes, it is. It exhibit geometrical isomerism. So when you consider this carbon, this carbon contain AA. Same group. Okay, it's a restricted carbon, and here you can see same group. So it does not exhibit geometrical isomerism. Is it clear, Rudra? Is it clear, Rudra? So is it clear, Rudra? I hope it's clear. Rudra, clear? Is it clear, Rudra? So எல்லாரும் quick-ஆ session like பண்ணுங்க. quick-ஆ session like பண்ணுங்க. Okay, so when you consider this is alkene case la, okay, double bonded case la. So when you consider ring, okay, here when you consider ring, this is the restricted carbon. Okay, so this restricted carbon contain two different group. This restricted carbon contain two different group. Yes, here this molecule will possess or exhibit GI. Okay, what is GI? That is geometrical isomerism. Okay, this molecule will possess geometrical isomerism. Okay, I hope it's clear. I hope it's clear. I hope it's clear what is geometrical isomerism. Then we are moving to next type. Okay, geometrical next type da cis-trans isomerism. Okay, cis-trans isomers. Okay, cis-trans isomers and EZ isomer. So I will tell you what is first cis-trans isomerism. It's not moving. Okay. Cis-trans isomerism, you know guys, what is cis-trans isomerism means? Same side la, same group vanda, that is cis. So same side la, different group vanda, that is trans. Okay. So cis-trans isomerism, opposite side la, same group vanda, that is trans. Okay. You know that. Okay. You know that. I will draw one structure. Okay. So see, double bond I am taking. 1, 2, 3, 4. Here Br. Here also Br. Here Cl. Is it cis or trans? 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 Meridial, facial, yes. Yes, you're correct only. Is it cis or trans? Yes, it is trans. Okay. So cis now I will draw the cis structure. So same side la vanda, that is cis. Okay, this is cis and this is trans. Okay. So cis and trans will also shows geometrical isomerism. Okay. So cis and trans will also shows geometrical isomerism. Next is EZ isomers. What is EZ isomers? So adala or scientist rule da CIP rule. Okay, CIP rule. So it is based on atomic number. Okay, atomic number base பண்ணிட்டு தான் இந்த rule இருக்கு. So நமக்கு தெரியும். என்ன தெரியும்? So நான் அதோட எக்ஸாம்பிள் எழுதி இருக்குன்னு நினைக்கிறேன். Yes. Here you can see bromine. Okay, bromine is the high molecular weight. After that, here nitrogen is there. 2, I'm writing true. And next carbon 3 and hydrogen is 4. Okay, so here I'm writing in 4 different groups. So atomic number high varradhu bromine, so 1, and after that nitrogen, adukapram carbon oda atomic number, and adukapram hydrogen oda atomic number. Okay, hydrogen ku ettum kammi dhaan because 1 dhaan atomic number. Okay, so then what will happen da? Then what will happen? So here you can see this is 1. Okay, this is 2. So high atomic number varra elements or groups. So in same side la vanda, it is Z type. Okay, it is Z type. Okay, so same side la vanda high atomic number vanda Z type. This opposite side la vanda. Okay, Br இங்க வந்தா Br, opposite sideல வந்தா that is E type. Okay, that is E type. Clear? That is EZ. Okay, EZ isomerism. Okay, clear? So here I will tell you again. Okay, I will tell you again, Kashifa. So what is that? Here in first you should write the increasing order of atomic number. So brominode atomic number is 1 and NH2 atomic number is 2 and carbonode not brominode atomic number 1 illa. So like increasing inga path inga irukra molecule la brominode atomic number da high. Okay, brominode atomic number da high and adukapra nitrogen oda atomic number so second place la irukku and adukapra carbon and hydrogen paakumbodhu carbon ku da atomic number jaasti adukapra hydrogen varudhu. Okay, hydrogen fourth position la. So atomic number jastiya irukkiradhu inga bromine and nitrogen. At the same side la vanda, okay, at the same side la vanda, that is actually Z type. Okay, that is actually Z type. This opposite side la vanda, that is E type. Is it clear? Z type and E type and clear? That is also geometrical isomerism. Okay, this is also geometrical isomerism. This is also geometrical isomerism. So here you can see bromine's atomic number is more, then nitrogen, then carbon, then hydrogen. Okay, we are writing in increasing order. Okay, yes. So when you consider bromine, okay, high atomic number elements, that is bromine and nitrogen in same side means that is Z type. Okay, that is Z type. Okay, that is Z type isomerism. Then what is E type? If the high atomic number atoms come in opposite side, okay, comes in attached in opposite side, then it is E type. Then it is E type. Clear? Clear? Oliva, clear? Is it clear? Is it clear? Okay. Then we are moving to properties of cis-trans isomers. Okay, properties of cis-trans isomers. So first one is dipole moment, boiling point, crystal lattice. So I will explain. I already written here. So when you consider dipole moment, okay, dipole moment yarukku jastiya irukku. You can with the concept tell me. So why? So cis and trans, okay, we are considering cis and trans. Okay, so dipole moment yarukku jastiya irukum, which isomer have high dipole moment? Cis isomer or trans isomer? Cis isomer or trans isomer? Cis isomer or trans isomer? Tell me quickly. Okay, yes. So dipole moment ஜாஸ்தி யாருக்கு இருக்கும்? சிஸ்ஸுக்கு தான் இருக்கும். Okay, so that I will tell you. டிரான்ஸ்ல ஆப்போசிட் சைடு இருக்கு. ஓகே, டிரான்ஸ்ல என்னடா ஆப்போசிட் சைடு இருக்கு. ஸோ ஆப்போசிட் சைடு அட்ராக்ட் பண்ணும்போது அது கேன்சல் ஆகும்ல. ஸோ ஆப்போசிட் சைடு வரும்போது அது கேன்சல் ஆகும்ல. ஸோ ஆப்போசிட் சைடு வரும்போது அது கேன்சல் ஆகும். ஸோ சிஸ்ஸுக்கு தான் டைபோல் மொமெண்ட் ஜாஸ்தியா இருக்கு. கிளியரா? சிஸ்ஸுக்கு தான் டைபோல் மொமெண்ட் இஸ் மோர் ஃபார் சிஸ். ஓகே, டைபோல் மொமெண்ட் இஸ் மோர் ஃபார் சிஸ். I will tell you the reason. Okay, when you consider this Cl and Cl, in here I am considering hydrogen and hydrogen. So chlorine is more electronegative. So chlorine, what will happen? So chlorine on the side la pull pannum. So and inge enna nadakum? Chlorine in the side la pull pannum. Obviously the dipole moment will become cancel. Okay, we can cancel each other. We can cancel each other. Opposite side cancel பண்ணலாம். So trans என்ன dipole moment கம்மி தான் இருக்கும் when you compare with the cis. Okay, when you compare with the cis. Clear? So next one is boiling point. So boiling point, okay, so next is boiling point. Yes, boiling point is directly proportional to dipole moment. Okay, boiling point is directly proportional to dipole moment. Yes, இன்னும் இருக்குடா. So boiling point is directly proportional to dipole moment. So we can write the same. So cis க்கு greater and trans க்கு less. So next is crystal lattice energy. Okay, crystal lattice energy. So what is crystal lattice energy? Crystal lattice energy means இங்க உங்களுக்கு சிஸ்ல பார்த்தா, okay, சிஸ்ல here you can see methyl group is there. Okay, methyl group and hydrogen is there. So here you can see methyl group means it's a bulky group. Yes, it's a bulky group. So then what will happen? So transல வரும்போது trans is opposite side. அப்போ bulky group maximum distanceல இருக்கு transல வரும்போது. Okay, bulky group maximum distanceல இருக்கு transல வரும்போது. So what will happen? Trans crystal lattice energy என்ன transல தான் ஜாஸ்தியா இருக்கு. Okay, crystal lattice energy transல தான் ஜாஸ்தியா இருக்கு. Is it clear? Then we are moving to next point, melting point. Crystal lattice energy directly proportional to melting point. Then it will be the correct answer. Okay, so C less than D. Okay, C less than, that means cis less than trans. Then third point, third point, that is fifth point, stability. Which one is more stable, cis or trans? Cis or trans is more stable? Tell me quickly, cis or trans is more stable? So here, from where should I start, Oliva? From where? Which point? Third, okay, third point. Crystal lattice means, so when you consider here it is cis. Okay, because methyl group is same side. Okay, in same side you can see methyl group. So same side means bulky group is there. Okay, bulky group is there in same side. Okay, bulky group is there. So what will happen? Cis, the crystal lattice energy is less in cis side. Okay, cis side means same side. Okay, because of bulky group. Okay, here you can see methyl group is there, here also methyl group is there. Methyl group means it's a bulky group. Okay guys, methyl group means bulky group. Okay, so here you can see this is bulky group. So bulky group present means, okay, bulky group present means, so here you can see crystal lat energy, you can see high crystal lat energy in trans side. Okay, high crystal lat energy in trans side. Okay, then next when you consider cis and trans, okay, melting point. Melting point is directly proportional to crystal lat energy. Okay, crystal lattice energy. So melting point directly proportional to crystal lattice energy. Okay, clear? So we can write the same, C less than T. What is C? C means cis. Okay, T means trans. Then stability. So here you can see methyl group, bulky group, again methyl group, bulky group, two bulky group, pass means two bulky group, pass means stability is less. Okay, stability is less because two bulky group, pass means stability is less. Okay, for cis stability is less. Okay, for cis stability is less. So for cis stability is less, trans stability is more. Clear? Okay. Next is solubility. So solubility also we can compare melting point. Okay, melting point opposite of solubility. So if melting point increases for cis, okay, is trans, so solubility is just opposite of that. Clear? Okay, that I will tell you what is bulky means. C double bond C. methyl group. Here also methyl group. Here hydrogen, hydrogen. Bulky means high groups are there. Here you can see CH3 is there. CH3 means 1 carbon and 3 hydrogen is there. So its bulkiness is there now. So carbon contain. So here this carbon contain this group and one side 3 hydrogen. Okay, bulkiness is more. Okay. Okay. So here you can see that is bulky. Okay. So that is bulky group. So that is the meaning of bulky group. Okay. Here you can see carbon contain 3 hydrogen plus this group also. Okay. So bulkiness, what you can say, mota groups. Okay. Mota groups. That is actually bulky group. Okay. Clear? Yes. Then we are moving to calculation of GI. Guys, are you ready? For the calculation of GI. For the calculation of GI, this is very important. So, if the molecule is dissymmetric, okay, there is two different type of molecule. Molecule is symmetric and molecule is dissymmetric. If molecule is dissymmetric means you should use this formula, okay. If molecule is dissymmetric means you should use this formula, 2 raised to n. What does n means? N means double bond exhibit GE. Okay, number of double bond exhibit GE. Evlo number of double bond irukku and the GE exhibit pandra. Okay, so that is actually n. Okay, here if molecule is symmetric, okay, we can assume that the molecule is symmetric. So if the molecule is symmetric, you can use this formula, 2n minus 1 plus 2p minus 1. Okay, so what is p? If n is even, okay, if n is even, you can take p is equal to n by 2. If n is odd, okay, if n is odd, p is equal to n plus 1 by 2. Okay, p is equal to n plus 1 by 2. Clear? 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 Is it clear? So we can do one example. Okay, we can do one example. Guys, are you ready? We can do one example. Example is already here. We can write one example. Explain again, ma'am. So they will ask, okay, calculate the number of geometrical isomer. Okay, they will ask. Okay, they will say that. Okay, they will ask, calculate the number of geometrical isomer. How you will calculate the number of geometrical isomer? So here there is two different type of molecule. Okay, one is dissymmetric molecule, another one is symmetric molecule. Okay, one is dissymmetric molecule, another one is symmetric molecule. Okay, so in case of dissymmetric molecule, okay, in case of dissymmetric molecule, n raised 2 raised to n. Okay, 2 raised to n. So what is n? N means number of double bond exhibit GI. Okay, evlo number of, okay, how many number of double bond exhibit GE, that is n. Okay, number of double bond exhibit GI. What is GI? GI means geometrical isomerism. Clear? You can see geometrical isomerism. So here if molecule is symmetric, okay, this is dissymmetric, here it is symmetric. So if the molecule is symmetric, then you can use this formula. Okay, so 2n minus 1 plus 2p minus 1. Okay, so here n means n we already discussed. Okay, number of double bond exhibit GE. Okay, so then what is p? P means in case of n is even, if n is even, you can use p is equal to n by 2. Okay, that is p. So if n is odd, okay, when you consider n is equal to odd, okay, odd number, then p is equal to n plus 1 by 2. Okay, here we can do one example. Okay, we can do one example. Clear, Ada? We can do one example. So here you can see one molecule, CH3 CH double bond CH 4 times. That means here you can see CH double bond CH is 4 times CH double bond CH is there. Okay, so 4 times minus CH2Br. Okay, minus CH2Br. So we know that how many double bonds are there? 4 double bonds are there. Okay, how many double bonds are there? 4. Okay, here you can see 4. So, number of double bond exhibit GI. Here it is 4. Then, it is a symmetric molecule. Okay, guys, it's a symmetric molecule. It is a symmetric molecule. Then, what we can do? N is equal to 4. Then, we know the equation 2 raised to n. 2 raised to 4. That is equal to 16. That is equal to 16. Clear? That is equal to 16. Clear? I hope it's clear. Then we are moving to next molecule. A molecule is symmetric. Okay, this is dissymmetric. So here the molecule is symmetric. So here Br is there. Okay, Br is there means it is dissymmetric. This molecule is symmetric. Inga paatha ungalku theriyum CH3 is there. Here also one CH3 is there. So this molecule is symmetric, and here you can see what is P. Here what is actually N. I am writing N. Okay. N is equal to 4. 4 means it is a even number. Okay, it is a even number. So what is P? N by 2. So 4 by 2. It is equal to 2. Okay, it is equal to 2. So total GI is equal to 2 into N is N is 4. 4 minus 1 plus. Okay, 4 minus 1. Here you can see 4 minus 1. 4 minus 1 plus 4 minus 1 plus here 2p minus 1. What is p? P already we calculate, that is 2. Okay, 2 minus 1. So 2 raised to 3 plus 2 raised to 1, that is equal to 10. Clear? Yes, here also N means double bond. Okay, here also N means double bond. Here and here. Okay, so in two cases N means double bond only. Okay, in two cases N means double bond only. Is it clear? Is it clear? And next is we are moving to optical isomerism. Is it clear? Then we can move to optical isomerism. Optical isomerism. Yeah. So we know that optical isomerism means a unpolarized light we are passing through Nicol prism. Then what you will get? You will get polarized light. Okay, polarized light direction should be in one. Okay, one direction light. Okay, it's a one direction light. So so this polarized light we are passing through a solution. Okay, we are passing through a solution, and so you will get 3. Okay, there is 3 chance. Okay, you will get 3 chance. Okay, first light direct அப்படியே polarized light திருப்பி வரலாம். Okay, and the direction same direction la light திருப்பி வரலாம். Okay, so one direction தான் இருக்கு. So அந்த one direction லயே light திருப்பி வரலாம். That is actually optically inactive nu sollum. That light is actually optically inactive. Okay, that light is actually optically inactive. Okay, and there is chance. Okay, there is chance for rotation of light. Okay, light will rotate either right side or left side. Okay, either right side or left side. And suppose right side la rotate panna, we will say that is dextro-rotatory. Okay, right side la rotate pannalum, left side la rotate pannalum, we can say that it is optically active. Okay, we can say that it is optically active. So right side la rotate panna, we can say that it is dextro-rotatory. Okay, it is dextro-rotatory. We can represent with this is wrong. We can represent with the plus, and we can represent with the letter D. Okay, we can represent with the letter D. And in case of left side la, okay, left side la rotate panna, that is actually levorotatory. Okay, we will say levorotatory, and that is we can represent with negative charge, negative sign, and L. Okay, we can represent with L. Is it clear? Is it clear, guys? Is it clear? Is it clear? Dextrolivo, clear. And normally, இது எல்லாமே experiment. Okay, this is experiment way. So normally we will say chiral or asymmetric carbon. Guys, you know what is chiral carbon or asymmetric carbon? You know what is chiral carbon? You know chiral carbon, yes. So you know what is chiral carbon and asymmetric carbon, yes. So chiral carbon or asymmetric carbon means the 4 group, okay, so the 4 group attached with the sp3 carbon should be different, okay, the 4 group should be different. That carbon should be sp3 carbon. So here you can see ABXY, okay, 4 group is actually different and it is sp3 carbon also. This is actually chiral carbon, okay, this is actually chiral carbon, okay. And there is one more point. That point is, yeah, here I will explain, okay. So, plane of symmetry and center of symmetry, okay, plane of symmetry and pose and cos, okay. So, what is plane of symmetry means? So, if you are dividing, okay, so A divide panna enna, so equal part தான் கிடைக்குதுல, so equal part you will get, okay, equal part you will get. If you cut B, okay, so equal கிடைக்கிறது இல்ல, equal இல்ல, so it's unequal, okay. So if it is equal, we can say plane of symmetry, okay, this is plane of symmetry. And when you consider this is actually POS, okay, plane of symmetry. When you consider center of symmetry, what is center of symmetry? This is a molecule, okay, this is a molecule. Here you can see one molecule. So in the molecule as a center, this is the center. So center la irundhu ipdi draw பண்ணும்போது, okay, so you will get hydrogen, yes, correct. Ipdi draw பண்ணும்போது, yes, you will get carbon. Ipdi draw பண்ணும்போது, you will get methyl group, okay. So this is actually, okay, even no cyclic number of cyclic structure, okay, even number of cyclic structure la mattumda ungalku center of symmetry paaka mudiyum, okay, even number of cyclic structure, okay, even number of cyclic structure la mattumda you can see center of symmetry, okay, you can see center of symmetry, okay, clear. This POS is there, COS is there, POS irka, COS irka. How would I same? It's not same. How we can say same? So I will draw B. Okay. So cut பண்ணும்போது இப்படி cut பண்ணும்போது இதுதான் வரும்ல. So இந்த சைடுல இப்படியும் கிடைக்கும். So how it will become same? How it will become same? POS, COS. Kashifa saying POS. Okay, so I will tell you, when you consider POS, okay, when you consider POS, இது equal divide பண்ணும்போது, yes, you will get equal part, okay, you will get equal part. POS is there. COS you can see only in even, okay, even number of cycle, okay, even number of cycle la தான் you can see COS, okay, you can see COS in even number of cycle. Okay, clear. So inga questions ellame irukku, you can do the questions, okay, you can do the questions. Idu ellame okay. So yes, then we can move to hydrocarbons. Guys, are you ready? Hydrocarbon venuma illana vera edachu chapter venuma? Suggest, if you want to suggest any chapter, I'm ready to take, or I will give you a 10 minutes break, then we can start. Okay, we can start. So if you have any suggestion, I will take. Okay, here I can see hydrocarbons. Yes, Jenny. Hydrocarbons. 10 minutes break I will give you. Hydrocarbons and haloalkanes you are asking. So I think we can start hydrocarbons. Every student, most of the students are asking for hydrocarbons. Then I will take hydrocarbons. Then after that I will take, yeah, he came back. So we can celebrate Jenny's comeback. How to find element with lone pair or not? Lone pair means unbonded electron should be there. Okay. Anyway, I will take, need refresh time. Yes. Anyway, hydrocarbon I will take. Okay. So we will start hydrocarbon. So hydrocarbons. Clear? So I will take hydrocarbon. Most of the students are saying hydrocarbon. So I will take hydrocarbon. Then after that I will take haloalkenes and haloarenes. Clear? Break undo, ma'am. Yes, break undu. I will give you break. Evlo time break venu? I will ask. Evlo time break venunda? $20 minutes? 7 hours. 20 minutes? Minutes I will give you. And before that I want to இப்போ எவ்வளோ லைக் ஆயிடுச்சுடா, லைக் டார்கெட் இருக்கு. Okay. Yeah, everyone is happy. Yeah, I'm here. Yes. Hello, my dear students. Hello, 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 hello. Yes, perfect. So now, so April batch, okay, April batch start ஆயிடுச்சு ஆஃப்லைன்ல. ஸோ உங்களுக்கு up to 90% வரைக்கும் உங்களுக்கு ஸ்காலர்ஷிப் கிடைக்கும். ஓகே, 90% ஸ்காலர்ஷிப். எஸ், up to 90% உங்களுக்கு ஸ்காலர்ஷிப் கிடைக்கும். அண்ட் ஸோ அதுக்காக நியரஸ்ட் வேதாந்து சென்டரில் போய் விசிட் பண்ணுங்க. ஓகே, ஸோ 90% ஸ்காலர்ஷிப்னா ஆக்சுவலி இட்ஸ் குட் ஒன்லி. எஸ், ஸோ நீட் கிராஷ் அண்ட் நீட் கோர்சஸ் இருக்குது. ஸோ அதுக்காக நியரஸ்ட் வேதாந்து சென்டரில் போய் உங்களோட 90% ஸ்காலர்ஷிப் இப்போவே யூட்டிலைஸ் பண்ணிக்கோங்க. ஓகே, அண்ட் வேதாந்து சென்டர்ஸ் எங்கெல்லாம் இருக்கு? ஸோ ஆஃப்லைன் சென்டர்ஸ், ஸோ தமிழ்நாடு சென்டர்ஸ் அண்ணா நகர்ல இருக்கு, மலஞ்சேரி அண்ட் தாம்பரம். ஸோ ஹியர் யூ கேன் சி லாட்ஸ் ஆஃப் சென்டர்ஸ் ஆர் தேர். ஸோ இப்போவே என்ன இது நோட் பண்ணிட்டு உங்களோட பக்கத்தில் இருக்கிற சென்டர்ல இப்போவே போயிட்டு 90% ஸ்காலர்ஷிப் இப்போவே கிராப் பண்ணிக்கோங்க. ஓகே, அண்ட் highest personal attention. Okay, so highest personal attention result, ப்ராப்பரா personal attention எல்லாமே கிடைக்கும். ஸோ லாஸ்ட் இயர் ரிசல்ட் தான் இது. நீட் 2025 ரிசல்ட் தான். இவ்வளோ ஸ்டூடெண்ட்ஸ்க்கு குட் மார்க், ஓகே, குட் மார்க் கிடைச்சிருக்கு. ஓகே, குட் மார்க் கிடைச்சிருக்கு. ஸோ இப்போவே எல்லாருமே என்ன போய் சீட் கன்ஃபார்ம் பண்ணிக்கோங்க. ஓகே, இப்போவே போய் எல்லாரும் சீட் கன்ஃபார்ம் பண்ணிக்கோங்க. எஸ், என்னடா some glitches there. Isomerism we finished. Hydrocarbon we are starting. ஸோ எல்லாரும் டீ சாப்பிட்டு ப்ராப்பராக ரெஸ்ட் எடுத்தீங்களா? ரிஃப்ரெஷ் பண்ணீங்களா? ஸோ எல்லாரும் நோட்ஸ் எல்லாம் எழுதுதுன்னு நினைக்கிறேன். ஸோ ப்ராப்பராக நோட்ஸ் எல்லாம் எழுதிக்கோங்க. உங்களோட வான் நோட்ஸ் இருந்தால் கொஞ்சம் கூட ஈஸியாக இருக்கும். ஓகே, உங்களோட வான் நோட்ஸ் இருந்தால் கொஞ்சம் கூட ஈஸியாக இருக்கும். ஓகே, ஸோ டார்கெட் கம்ப்ளீட் பண்ணியாச்சா? 250 லைக்ஸ் ஆயிடுச்சா? ஸோ 250 லைக்ஸ் ஆயிடுச்சா? இப்போவும் 244 தான் இருக்கு. இப்போவும் 244 தான் இருக்கு. இப்போவும் 244 தான் இருக்கு. ஸோ we can start anyway. So we know that. So 𝐶𝐶 okay, 𝐶𝐶. So we are starting hydrocarbons, okay, we are starting hydrocarbons. So hydrocarbons la alkanes irukku, alkene irukku, alkyne irukku, benzene irukku. So what is the general formula of alkane? So it's CnH2n plus 2, alkene CnH2n, and yes, 6 more conjugates. Yeah, they are not ready to give likes. So here I can see how many students, okay, how many students poll பண்ணிருக்குன்னு பார்க்கலாம். So you can see 303 students, okay, 303 students poll பண்ணிருக்கு. But here I can see only 245 like, okay, 245 like. This is so bad, okay, this is so bad. I'm so sad, you know, I'm so sad. So இவ்ளோ students poll பண்ணிருக்கு, but அவங்களுக்கு like பண்ண முடியலல, like பண்ண முடியலல. This is so bad, this is so bad. I'm so sad. Okay, so we know that alkane is there, alkene is there, alkyne is there. Okay, so first we are going to discuss the preparation, okay, method of preparation. So from unsaturated hydrocarbon, so unsaturated hydrocarbon la irundhu eppadi prepare pannalam? Unsaturated hydrocarbon la irundhu saturated hydrocarbon prepare pannalam. Okay, make ma'am happy. Yeah, so it's your responsibility, okay, it's your responsibility only. Make me happy. So I'm taking almost எவ்வளோ டைம் ஆயிடுச்சுடா? 7 hours. Okay, 7 hours ஆயிடுச்சு. Okay, I'm taking 7 hours class. So you can't give a like. But you can't give a like. Okay, so I'm so sad. So yes, we can start. So from unsaturated hydrocarbon, what is unsaturated hydrocarbon means? Double or triple bond. Okay, so we can directly that react with the hydrogenation. Okay, it's hydrogenation. So for hydrogenation, here you can see in presence of hydrogen, nickel, platinum, palladium. Okay, in presence of hydrogen, nickel, platinum, palladium, what will happen? So this double bond will break, ilana pi bond will break, and it will form single bond. Okay, it will form unsaturated alkenes. Okay, it will form saturated alkenes. Next one, okay, this is example questions ellame irukku, so you can do your questions. Okay, so here you can see lots of questions are there, you can do. Okay, so next is Wurtz reaction. What is Wurtz reaction? So Wurtz reaction is means, so here we are treating in a alkyl halide. Okay, alkyl halide in presence of sodium. Okay, so in presence of sodium, in presence of dry ether. Okay, in sodium and in presence of dry ether, then what will happen? It's very simple. So inga irundhu halogen pogum, what will happen? It will form RR. Okay, it will form alkyl halide. Okay, it will form alkyl halide. Okay, it will form alkyl halide. Okay, so it will form alkyl halide. Okay, clear? It will form alkyl halide. So here you can see symmetrical alkane. Okay, it is symmetrical alkane. You can see in Wurtz reaction. Wurtz reaction la enna kadaikum? You can see symmetrical alkane in Wurtz reaction. And there is one more important point. Okay, so even number of carbon will be formed. So here you can see even number of the product of, okay, the product of Wurtz reaction is even number of carbon. Okay, even number of carbon da ennada Wurtz reaction oda product. Okay, even number of carbon will be the product. Okay, and important point, inge enna nadakudhu? Primary and secondary oda coupling nadakudhu. Okay, primary and secondary oda, here you can see primary and secondary oda coupling will form. Okay, and tertiary la disproportionation nadakum. Okay, primary and secondary la coupling nadakum, and tertiary la disproportionation you can see. Okay, this is also very important. Next, This is actually Wood's reaction related questions எல்லாம் இருக்கு. Then we are moving with reaction with the zinc. Okay, reaction with the zinc in presence of HCl. Okay, dilute HCl. So in presence of dilute HCl, what will be the product? H plus will be the product. Okay, what is that? H. Okay, எந்த important point na? எந்த important point? This one, coupling. So this one. So when you consider primary and secondary alkyl halide la, you can see, okay, so you can see coupling will occur. Okay, coupling means one hydrogen replace பண்ணிட்டு hydrogen வரும். Okay, here you can see this is coupling. Okay, so coupling will happen. So this is tertiary. Okay, this is tertiary carbon free radical. Okay, carbon free radical is tertiary. Here you can see 1 2 3. So what will happen? It will react with hydrogen. Okay, it will react with hydrogen. So என்ன நடக்கும்? இந்த bond break ஆகும், இது hydrogen react ஆகும். So what will happen? Disproportionation will happen. Okay, disproportionation will happen. Okay, with the sodium in presence of dry ether. Yes. So zinc. Okay, zinc and HCl. Okay, zinc and HCl oda byproduct is actually hydrogen. Okay, hydrogen is the byproduct. So RX in a zinc and hydrogen kuda react பண்ணும்போது what will happen? You will get RH. Okay, you will get RH. Okay, so here one is the one example. So இங்க இருந்து halogen போகும், அங்க யாரு வரும்? Hydrogen வரும். Okay, halogen போகும், அங்க யாரு வரும்? Hydrogen வரும். And here you can see rate of reaction. Rate of reaction எங்க அதிகமா இருக்கு? So rate of reaction you can see. So iodine. Okay, alkyl iodide la தான் rate. Okay, rate of reaction ஜாஸ்தியா இருக்கு. Why? Because here the bond energy is less. Okay, here the bond energy is less, so we can easily break the bond. Okay, we can easily break this bond. Okay, so here also we can easily break the bond. So bond energy is less, so rate of reaction is more. Okay, rate of reaction is more, bond energy is less. Clear? Bond energy is less, rate of reaction is more. Answer attached bro. So question oda answer எல்லாமே இங்க இருக்குடா. So எல்லா question oda answer இங்க இருக்கு. Okay, எல்லா question oda answer இருக்கு. because இது நானே solve பண்ணிட்டு எடுக்கிறதுனால so எனக்கு ஒரு பேஜ்ல நான் solve பண்ணும். Okay, so அப்போவே question பார்க்கிறதுக்காக நான் அப்போவே solve பண்ணும். Okay, yes, so it is better living group also. You can say that because of the size also. Yes, Arun. Yes, then we are moving to from carboxylic acid. Okay, from carboxylic acid. So what is carboxylic acid la enna nadakudhu? Decarboxylation. Okay, so what is decarboxylation? So decarboxylation na sonna enna da? Inga decarboxylation nadakudhu. So CO2 remove பண்ணுது. Okay, so decarboxylation means so removal of CO2. Okay, so decarboxylation means it's very simple, removal of CO2 is happening. Okay, simple. So what will happen? So here you can see carboxylic acid is reacting with the sodium hydroxide. Okay, then what will form? So it's very simple, RH will form. So இங்க இருந்து complete group. Okay, இங்க இருந்து complete group இங்க இருந்து eliminate ஆகும். Okay, complete group eliminate ஆகும். Okay, complete group eliminate ஆகும். Actually decarboxylation means here removal of carbon dioxide. Carbon dioxide remove பண்ற process தான் decarboxylation. Okay, okay, clear? Then here also another example. இங்க இருந்து என்ன நடக்குது? So it is sodium salt of carboxylic acid. Here it is sodium salt of carboxylic acid. Then what will happen? Same, this group இங்க இருந்து attach ஆகும், RH will form. Okay, RH will form. Okay, then we are moving to here also lots of questions are there. Okay, lots of JEE NEET level questions are there. You can solve this. Okay, இன்னைக்கே solve பண்ணிக்கோங்க. Okay, இன்னைக்கே solve பண்ணிக்கோங்க. Next is Kolb's electrolysis method. Okay, electrolytic method. What is electrolytic method? In presence of electricity, this reaction is reaction is occurring in presence of electricity. Okay, this reaction is occurring in presence of electricity. Then what will happen? So in presence of sodium and potassium salt. Okay, in presence of sodium and potassium salt of carboxylic acid. Okay, sodium or potassium salt of carboxylic acid, same reaction will happen. Okay, same reaction will happen. So what will happen? Same reaction. Okay, same reaction. So here in the group eliminate agu. Okay, decarboxylation only, decarboxylation only. Okay, so what will happen? Decarboxylation, COO Na ingirundhu pogum. Okay, so that is called electrolytic method. Okay, then next is physical properties of alkene. Okay, we are moving to physical preparation. Clear dana? Yes, after the session I will share the PPT. Okay, after this session I will share this PPT. So physical properties of alkanes. So first point is boiling point. Okay, first point is boiling point. So boiling point is directly proportional to force of attraction, that is directly proportional to molecular weight. Okay, so we know that boiling point increase agum, molecular weight increase agumbodhu, and force increase aidichuna, obviously what will happen? Boiling point will increases. Okay, boiling point by Clavera. What? Who? Okay, so boiling point directly proportional to number of carbon atom. Okay, so boiling point, if number of carbon atom increases means boiling point will also increases. So here you can see only 3 carbon atom is there. So here 4 carbon atom is there. Here 5 carbon atom is there. So number of carbon atom increases means boiling point will also increases. So in boiling point is inversely proportional to branches. If boiling point increases, what will happen? Branches. Okay, if branches increases, boiling point decreases. Okay, if number of carbon, okay, are same. Okay, when you consider number of carbon is same. Okay, so here you can see 1 2 3 4 carbon is there. Here also 1 2 3 4 carbon is there. So here you can see 1 branch is there. Okay, so here boiling point more is for straight chains. Okay, branch irunda, what will happen? Surface area will reduces. So what will happen? Boiling point will also reduces. Okay, so haloalkanes, hydrocarbons. Then we are moving to melting point and solubility. Okay, melting point and solubility. So melting point is directly proportional to crystal lattice energy. Okay, so proper crystal lattice energy irundiruchuna melting point enna increase agum. Okay, melting point increase agum. Structure ellame proper ah irundha, what will happen? Yes, because of van der Waals force. Yes, so proper structure irundiruchuna, we know that what will be there? So if that van der Waals force is more. Okay, van der Waals force is more means, obviously force is more means melting point will also increases. Okay, melting point will also increases. Then here you can see number of even number. Okay, even number is more means crystal lattice energy is more. Okay, even number of carbon coupling means, or even number of structure means, carbon means, here you can see that crystal lattice energy is more for even number. Okay, crystal lattice energy is more for even number of carbon molecules. So next is solubility. Solubility, what is solubility? So like dissolves in like, that means polar dissolves in polar solvent and non-polar dissolved in non-polar solvent. Is it clear? So that is like dissolves in like. Okay, and next here also you can see 2024 questions. Okay, next we are moving to chemical property. Okay, next we are moving to chemical property. So what is chemical property? So first chemical property is, that is halogenation. Okay, halogenation. So what is halogenation means? Here it's treating. Okay, Normally alkane is treating with halogen in presence of light. Okay, in presence of light what will happen? Simple da, inga irundha hydrogen replace pannu halogen varum. Okay, hydrogen replace pannu halogen varum. 3 steps irukku: initiation, propagation, termination. Okay, initiation, propagation, termination. So initiation la what is happening? So halogen, okay, halogen is forming halogen free radical. Chain propagation la enna nadakudhu? So here alkane, okay, alkane is reacting with this free radical and it's forming HX, okay, hydrogen chloride or hydrogen halide it's forming, plus enna alkyl free radical. Okay, alkyl free radical. Okay, alkyl free radical is forming. So here you can see alkyl free radical is reacting with the halogen molecule. So halogen molecule kuda react பண்ணும்போது what is happening? So here you know that, so it will form free radical. So here it will form Rx. Okay, Rx. So chain termination method means last step. Okay, இங்க இருக்கிற எல்லா என்ன free radicals combine பண்ணி molecules ஆ மாறும். So RR it will form RR, XX it will form XX, RX it will form RX. Okay, so that is actually in a halogenation. So halogenation la avlodha irukku. And next chlorination, bromination ellame adile varum, iodination ellavume. So you can do maximum questions. So idla na maximum questions include பண்ணிருக்கு. So next is combustion. Okay, what is combustion? In presence of oxygen. Okay, presence of oxygen, if carbon, okay, methyl group, okay, methyl alkane is reacting with oxygen, that is actually combustion. So what will be the product of combustion? We know that carbon dioxide and water. Okay, carbon dioxide and water will be the product, and there is a limited combustion also there. Okay, in presence of some what reagent, in presence of some catalyst, they will do limited combustion also. Okay, so limited combustion. Okay, recent van der Waals force, yes, so limited combustion is also there. And here you can see hydrocarbons. Okay, hydrocarbon will be the product. Okay, so here we know that, okay, here hydrocarbons எப்பவுமே நமக்கு தெரியும் combustion நடக்கும். Okay, so here we know that alkyl, okay, alkane we are taking first. Alkane is reacting with the oxygen. So what will be the general equation? Okay, it is the general equation CXHY plus X plus Y divided by 4, that much O2. Okay, avlo O2 irukku. So what will be the product? The product will be XCO2 plus Y by 2 H2O. Okay, Y by 2 H2O. Okay, clear? Then here also guys, இது relate பண்ணிட்டு lots of questions இருக்கு. நான் already சொல்லியிருக்கல, limited combustion நடக்கும். Okay, so இங்க in presence of இங்க இருக்கு, in presence of என்ன catalyst ஓட presence ல reaction நடக்குது. So இங்க carbon and water தான். So this is not complete combustion. Okay, this is incomplete combustion. Okay, because இங்க carbon கிடைக்குது, this is not carbon dioxide. Here you can see carbon is there means it is incomplete combustion. Okay, incomplete combustion. Okay, then here also you can do maximum questions. Okay, இது எல்லாமே நான் maximum questions நான் add பண்ணியிருக்கு, and you can do maximum question. Next, aromatization. What is aromatization னு சொன்னா என்னடா? Aromatization னா என்னடா? What is aromatization? What is aromatization? Tell me quickly, what is aromatization? Yes, that questions are PYQs only. Okay, this questions are PYQs only. This is PYQ. This is JEE 2021 question. And this is JEE 2023 question. So எல்லாமே JEE question, NEET question அப்படி தான் இருக்கு. Okay, எல்லாமே PYQ தான். எல்லாமே PYQ. PYQ இல்லைன்னா அந்த டாபிக்ல இருந்து நான் எடுத்திருக்கு. Okay, so most of the questions PYQ தான். So tell me, what is aromatization? Do you have any idea about aromatization? So aromatization is very simple. Aromatization, we are converting chain into cyclic compound, okay, chain into aromatic compound, okay. So here you can see, so chain first Cr2O3 oda presence la treat பண்ணும்போது in presence of Al2O3 or molybdenum oxide or vanadium pentoxide oda presence la treat பண்ணும்போது first நமக்கு என்ன cyclohexane கிடைக்கும். So அந்த cyclohexane again treat பண்ணும்போது heat பண்ணும்போது what you will get? You will get benzene. So same way here also you can see 1 2 3 4 5 6 carbon is there and one branch is also there. So you will get toluene, okay. So that is actually aromatization. Then next is reaction with the steam, okay. So reaction with steam, okay. So CH4 என்ன steam கூட react பண்ணும்போது water, okay, steam na high temperature இருக்கும். So what you will get? Carbon monoxide and hydrogen, okay, carbon monoxide and hydrogen you will get, okay, carbon monoxide and hydrogen, yes, toluene you will get, okay. So yes, toluene, that is toluene only, okay. And here you can see pyrolysis. What is pyrolysis? Heating in absence of air, okay. So air oda absence la heat பண்ணும்போது ஒரு bigger chain heat பண்ணும்போது என்ன நடக்கும்? அந்த bigger chain break பண்ணிட்டு smaller chain மாறும், okay. Bigger chain break பண்ணிட்டு smaller chain மாறும், okay. That is actually pyrolysis, okay guys, that is actually pyrolysis. Here you can see C6H14. So here you can see C6H12. Again என்ன C4H8 C2H6 மாறுது. Again என்ன வேற different small chain மாறுது, okay, small chain மாறுது, okay. That is actually pyrolysis. Next, method of preparation of alkene, okay, method of preparation of alkene. What is the method of preparation alkene? First one is from alkyne la irundhu, what is triple bond la irundhu we are making double bond, okay. It's very simple. We are treating with hydrogen, okay, we are treating with hydrogen in presence of, okay, in presence of Linder's catalyst, okay, in presence of Linder's catalyst. What is Linder's catalyst? Palladium BaSO4 oda mixture da Linder's catalyst, okay. And here also you can see palladium carbon is there and palladium CaCO3 is there and S-quinone is there, okay, quinone is there, okay, sulfur quinone is there. So இந்த different reagent ஓட presence எல்லாம் treat பண்ணும்போது என்ன நடக்கும்? அங்க இருக்கிற one pi bond will break and hydrogen will add, okay. Yes, here the catalysts are poisonous catalyst, okay. இங்க இருக்கிற catalyst actually poison தான், okay. So Linder's catalyst எல்லாமே poisonous catalyst தான் here we are using, okay. Then Linder's catalyst, okay. So here you will get two different type of product, okay. You will get cis product and trans product also, okay. So here you will get cis product. Cis product means same side la hydrogen வருது, same side la alkyl group வருது and trans alkene branch reaction, okay. So trans alkene branch reaction la என்ன sodium or lithium presence la in presence of liquid ammonia ஓட presence la treat பண்ணும்போது, okay, triple bond alkyne treat பண்ணும்போது what you will get? You will get trans, okay, you will get trans product, okay, you will get trans product, okay. Reagent மாறுது அவ்வளவுதான் difference, okay. Reagent மாறுது அவ்வளவுதான் difference, okay. Then next is in the given reaction identify the எல்லாமே questions, you can do the questions, okay. இது எல்லாமே questions. So next method is E2. You know E2 reaction da dehydrohalogenation. What is dehydrohalogenation? HX remove panna pore, okay. HS we are removing HX, okay, we are removing HX. So what will happen? So here you can see alkyl halide da irukku, alkyl halide is there. So what is happening? So inga irukra halogen bond is breaking and இங்க இருக்கிற CH bond இருக்குல்ல, so inga we are using base. Okay, we are using base B minus. So this base என்ன is attacking hydrogen. So hydrogen attack பண்ணும்போது இங்க இருக்கிற bond என்ன இங்க வரும், அது double bond ஆ மாறிடும். So bond formation bond breaking same time ல நடக்குது. So it is elimination, E2 elimination. Okay, it is E2 elimination. Here alcoholic KOH or ROK ஓட presence-ல தான் reaction நடக்குது. Okay, alcoholic, because I told you now basic medium தான் இங்க தேவை. Okay, basic medium தான் இங்க தேவை. Okay, so here you can see bond breaking and bond formation simultaneous ஆ நடக்குது. Bond breaking and bond formation simultaneous ஆ நடக்குது. Okay, next is states of an Hoffman alkane. So what is states of rule? உங்களுக்கு தெரியும்ல, states of rule na more substituted carbon. Okay, what is more substituted carbon? So it's very simple. More substituted carbon means more substituted alpha carbon should be there. Okay, more substituted alpha carbon should be there. என்ன புரியலடா, என்ன புரியல, டாபிக் சொல்லணும். Okay, before slide doubt. Just a second. I will come within 1 minute. Okay, I will come within 1 minute. I'm here only. Okay, 7 hours completed. So I want to take one tablet. Okay, take one tablet. I feel headache. சின்ன தலைவலிடா, ஸோ அதுக்காக ஒரு டேப்லெட் எடுத்தேன். ஓகே, ஸ்டார்ட் பண்ணலாமா? சோடா states of rule means more substituted alpha carbon should be there. Then yes, Jenny, yes, we finished 7 hours. 7 hours correct எவ்வளோ ஆயிடுச்சுடா? கரெக்ட் எவ்வளோ ஆயிடுச்சு? கரெக்ட் எவ்வளோ டைம் ஆயிடுச்சு? 7.5 hours ஆயிடுக்கும்ல. So yes, so more substituted alpha carbon and less substituted alpha carbon the Hofmann alkanes. Okay, Hofmann, okay, Hofmann na less substituted, and states of rule na, states of na, oh, 7 hours 40 minutes. Oh my god, yes. Oh, after this I will take aldehyde ketone carboxylic acid. Is it okay, Ramu? Is it okay? $7.44. எல்லாருக்கும் different time ஆடா. அது எப்படி? Almost 8. Okay. So, states of rule and Hofmann. Okay. So, here you can see double bond is there. So, double bond is there means here you can see how many alpha carbons are there? 1, 2 alpha carbons are there. So, here you can see only 1 alpha carbon is there. Okay, that is states of rule. So, here it is Hofmann and this is states of. Okay, states of. Okay. So, then we are here. Ellame questions da. Okay, ellame questions da. Next is from alcohol by acidic dehydration. Okay, so from alcohol by acidic dehydration. So, this is actually E1. Okay, this is E1. This is 11th class only. Hydrocarbon is 11th only. This is hydrocarbon 11th la mattum da irukku. 11th oda last chapter da. Idukku appuram we will move to 12th. Okay, so 11th oda last chapter da. Okay, after this class 11th organic complete la. Yes, after this chapter 11th organic chapter complete da. Okay, so from alcohol by acidic dehydration. Okay, acidic dehydration from alcohol. Okay, so alcohol irukku. So protonation is there. What is protonation? So addition of hydrogen is actually protonation. So protonation will happen. So here you can see OH2 will form. Yes, so idukapra water will eliminate. Okay, dehydration means water will eliminate. So here you can see R plus will form. So rearrangement if possible. So enna inga rearrangement nadakum. Possible ah irundha rearrangement will if it is there, if rearrangement is there means rearrangement is possible also. Okay, rearrangement is possible after aldehyde ketone carboxylic acid. Okay, you want aldehyde ketone carboxylic acid? You want aldehyde ketone carboxylic acid? Okay, anyway I will check. Okay da. So எது வேணும்னு நீங்க சொன்னா போதும், I will give you. Okay, I will give you. எது வேணும்னு சொன்னா போதும், I will give you. Okay. Oh my god. So இதுக்கப்புறம் I will give you aldehyde ketone carboxylic acid da. Okay, so okay, I will give you aldehyde ketone, I will give you haloalkanes and haloarenes. Okay, no worries. So rearrangement possible ah irundha rearrangement nadakum. Adukapram what will form? It will form alkene. Okay, alkane illa alkene will form. Okay, alkene, because alkene oda preparation method dhan solludhu. Okay, so rearrangement possible na enna methyl shift irukku and hydrogen shift irukku and cycle. Okay, cycle layum change varum. Next is addition of halogen. Okay, addition of halogen. Okay, chemical reaction la irukra addition of halogen. So inga double bond break agum. Double bond break ஆனா என்ன வரும்? halogen கூட react பண்ணும்போது halogen, இங்கேயும் halogen வரும். Okay, so இதோட mechanism தான் இது. So first என்ன நடக்கும்? So halogen, okay, halogen இங்க வந்து attack பண்ணும். Okay, halogen இங்க வந்து attack பண்ணும். So இந்த double bond break ஆகும். So here you can see cyclohaloneum ion. Okay, cyclohaloneum ஒரு triangle மாதிரி ஒரு form ஆகுதுல. So ma'am 12th organic chemistry also take from basic ma'am. Yes, I will take from basic. Okay, so 12th chemistry la basic illada actually. 12th chemistry la chapters mattum dhaan irukku. Okay, chapters mattum dhaan irukku. So here you can see cyclic halonium ion will form. Okay, cyclic halonium ion will form. So next step la enna nadakum? So halogen. Okay, halogen ipo one halogen mattum dhaan ரியாக்ட் பண்ணியிருக்கு another halogen வரும். ஸோ another halogen டைரக்டாக ஃப்ரண்ட் சைடில் வர முடியாது. பிகாஸ் ஹாலஜன் வரும்போது electronegativity ஜாஸ்தியாக இருக்குது. நெகட்டிவ் ஓகே, நெகட்டிவ் வரும்போது ஸோ இங்கே டைரக்ட் ஃப்ரண்ட் சைடில் வர முடியாது. ஸோ பேக் சைடு அட்டாக்கு தான். ஸோ பேக் சைட்லேருந்து இந்த கார்பனை அட்டாக் பண்ணும். ஸோ ஹியர் ஒன் ஹாலஜன், ஹியர் ஒன் ஹாலஜன். ஓகே, கிளியர்? ஸோ எல்லாரும் சீக்கிரமாக செஷன் லைக் பண்ணுங்க. 300 லைக்ஸ் தான் நம்மளோட டார்கெட். ஓகே, நம்மளோட டார்கெட் இஸ் ஆக்சுவலி 300 லைக்ஸ். அண்ட் நெக்ஸ்ட் இஸ் அடிஷன் ஆஃப் ஹைட்ரஜன் ஹாலைட். ஹைட்ரஜன் ஹாலைட்னா HX. ஹைட்ரஜன் ஹாலைடோட அடிஷன். ஓகே, ஹைட்ரஜன் ஹாலைடோட அடிஷன். ஸோ இங்கே என்ன நடக்குது? ஃபஸ்ட்டு ஹைட்ரஜன் வருதுடா, ஹைட்ரஜன் வருது. ஸோ ஹைட்ரஜன் வரும்போது ஹியர் we can say that it will follow Markovnikov's rule. ஓகே, ஸோ Markovnikov's rule ஹைட்ரஜன் ஆட் பண்ணிட்டேன். ஸோ நெக்ஸ்ட் என்ன நடக்கும்? So next biomolecule ma'am, next I will take either aldehyde or ketone, or I will take haloalkenes and haloarenes. இதில் ஏதாச்சும் ஒரு சாப்டர் எடுக்கும்டா. ஸோ இங்கே carbocation is formed. Okay, so carbocation is formed means if rearrangement is possible, we know that which carbocation is more stable? Tertiary carbocation is more stable. Okay, tertiary carbocation is more stable. So if tertiary carbocation is possible means, so ஏதாச்சும் rearrangement possible means, so tertiary carbons பக்கத்தில் possible ஆனா இங்கிருந்து ஹைட்ரஜன் போகும். ஓகே, ஹைட்ரஜன் போகும். ஸோ tertiary carbon, ஹைட்ரஜன் அங்கிருந்து வரும், இங்கே carbocation போகும். if rearrangement possible. Okay, if rearrangement possible. That I don't know da, that I also don't know. I want to finish all the chapter. Okay, I want to finish all the chapter, that's all. So இங்கே என்ன நடக்குது? ஹாலோஜன். ஓகே, ஹாலோஜன் மைனஸ் ஃபார்ம் ஆகுது. ஸோ எக்ஸ் மைனஸ். ஸோ இங்கே சிம்பிளாக என்ன நடக்குது? ஸோ ஹாலோஜன் நெக்ஸ்ட் ஸ்டெப்பில் என்ன? ஹாலோஜன் ஆட் ஆகுது. ஓகே, ஹாலோஜன் ஆட் ஆகுது. ஹாலோஜன் குரூப். ஓகே, ஹாலோஜன் ஆட்டம் ஆட் ஆகுது. ஓகே, ஸோ ஹியர் we know that Markovnikov's rule. You know guys what is Markovnikov's rule? 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 The positive addendum. Okay, the positive part will added to carbon, that which carbon contain more number of hydrogen. Okay, so more number of hydrogen இருக்கிற என்ன கார்பன்ல இங்கிருந்து பாசிட்டிவ் பார்ட் ஆட் ஆகும். ஓகே, பாசிட்டிவ் பார்ட்னா ஹியர் இட் இஸ் ஹைட்ரஜன். ஓகே, ஹியர் இட் இஸ் ஹைட்ரஜன். ஸோ இன் கேஸ் ஆஃப் ஹாலோஜன் ஆகும்போது என்ன? it is negative. Yes, so this negative addendum, we can use negative addendum will attach to carbon. That carbon should contain less number of hydrogen. Okay, that carbon should contain less number of hydrogen. Okay, is it clear? So here you can see lots of question, lots and lots of question. So 2015 NEET question, and here you can see JEE question எல்லாமே இருக்குடா. ஸோ நீங்கள் ஜஸ்ட் ட்ரை பண்ணால் மட்டும் போதும். ஓகே, அவ்வளோ கொஸ்டின்ஸ் இருக்குது. ஓகே, அவ்வளோ கொஸ்டின்ஸ் இருக்குது. ஸோ நெக்ஸ்ட் இஸ் மெத்தட் ஆஃப் ப்ரிப்ரேஷன் ஆஃப் ஆல்கைன்ஸ். மெத்தட் ஆஃப் ப்ரிப்ரேஷன் ஆஃப் ஆல்கைன்ஸ். ஓகே, just a second. Okay, so we are next is alkynes oda triple bond oda preparation da. Okay, ட்ரிபிள் பாண்டோட ப்ரிப்ரேஷன் தான் நெக்ஸ்ட் இருக்கு. ஓகே, ட்ரிபிள் பாண்டோட ப்ரிப்ரேஷன் தான் நெக்ஸ்ட் இருக்கு. ஓகே, ஸோ ஃபர்ஸ்ட் ஒன் இஸ் ஃப்ரம் கால்சியம் கார்பைடு. ஓகே, ஃப்ரம் கால்சியம் கார்பைடு. வாட் இஸ் கால்சியம் கார்பைடு? CaC2 தான் கால்சியம் கார்பைடு. ஓகே, ஸோ கால்சியம் கார்பைடு இஸ் ட்ரீட்டிங் வித் வாட்டர். ஓகே, வாட்டர் மாலிக்யூலோட கூட கால்சியம் கார்பைடு ரியாக்ட் பண்ணும்போது வாட் யூ வில் கெட்? யூ வில் கெட் கால்சியம் ஹைட்ராக்சைடு. ஸோ கால்சியம் ஹைட்ராக்சைடு and the byproduct is ethyl. Okay, ethyne. Okay, you will get ethyne. Okay, so how you will get calcium carbide? Calcium carbide எப்படி கிடைக்கும்டா? So calcium carbide Ca2 plus. Okay, Ca2 plus and C minus தான். Okay, C minus தான் calcium carbide. So here you will get byproduct என்ன கிடைக்குது? Here you will get alkyne. Okay, you will get alkyne. Just a second, I will order some food. Okay, I feel very hungry. Okay, thank you so much Grishma இப்பதான் பாக்குது. So we are moving to preparation of alkyne. Alkyne la irundha enna? First calcium carbide la irundha we are preparing. Okay, so calcium carbide na enna? CaC2. Okay, CaC2 தான். So water கூட react பண்ணும்போது, in presence of water கூட reaction நடக்கும்போது என்ன நடக்குதுடா? So calcium hydroxide we will get. Okay, calcium hydroxide we will get. So calcium hydroxide நமக்கு தேவையா? இல்ல, we will get one more byproduct. So that is a alkyne. Okay, so you will get ethyne. Okay, you will get ethyne. Okay, clear? We will get ethyne. Okay, clear? We will get ethyne. Okay, okay, then we are moving to method of preparation of alkynes. Next method of preparation. So inge calcium carbide nu sollirukku. So may they will ask, okay, how we will get calcium carbide? Okay, may they will ask how we will get calcium carbide. How we will get calcium carbide? So calcium carbide means carbon dioxide calcium carbide. First you will get enna? Calcium carbonate எடுத்து heat பண்ணும்போது we will get carbon dioxide and calcium oxide. Okay, calcium oxide carbon dioxide கிடைக்கும். Okay, so calcium oxide carbon dioxide கிடைக்கும். So அதில இருந்து தான் calcium carbide form பண்ணுது. Okay, calcium carbide அதில இருந்து தான் form ஆகுது. Then here also lots of question. Lots of question எடுத்து வந்திருக்கு. Actually இப்ப time இல்ல, எல்லாமே question finish பண்றதுக்கு. So first we will finish. Okay, we will finish this content. Okay, first we will finish this content, then we can do questions. Okay, you can do question after the session also. Okay, you can do questions after the session also from vicinal dihalide. Okay, vicinal dihalide. What is vicinal dihalide? So it is also E2 elimination. Okay, it is E2 elimination. So E2 elimination la dihydrohalogenation da inga nadakudhu. Okay, enna nadakudhu? Dihydrohalogenation nadakudhu. Simple. Here alcoholic KOH and NaNH2 ஓட presence-ல தான் இந்த reaction நடக்குது. Okay, alcoholic KOH and NaNH2 ஓட presence-ல தான் reaction நடக்குது. Simple. இங்க இருந்து halogen போயிருக்கு. Okay, halogen போயிருக்கு. So இங்க double bond வரும். Simple, double bond வரும். Okay, so இங்க halogen போய் இங்க double bond வரும். Okay, இங்க halogen போய் இங்க double bond வரும். Okay, so that is, so actually இது 2 step reaction தான். First double bond வரும், So first double bond you can form, you can see second step la adu triple bond ah maru. Okay, second step la adu triple bond ah maru. Idudanda example, idudanda example. Second step la I will write here. Second step la NH2 reaction நடக்கும்போது இங்க என்ன கிடைக்கும்? C triple bond C bond கிடைக்கும். Okay, C triple bond C கிடைக்கும். So இங்க இருந்து first hydrogen and halogen போகும். Okay, one side ல இருந்து hydrogen and halogen போகும் first step ல. Okay, second step ல நமக்கு என்ன தேவை? ஒரு high reagent தேவை. Okay, ஒரு high reagent தேவை. So high reacting reagent தேவை. So here we are taking sodium NH2. That means NaNH2. So NaNH2 எடுக்கும்போது again என்ன நடக்கும்? இங்க இருந்து hydrogen, இங்க இருந்து halogen, இங்க இருந்து hydrogen and இங்க இருந்து halogen போகும். Clear-ஆ? Clear? So if you want we can do one question. இதுதான் இந்த சாப்டர்ல இருக்கு. Okay, இதுதான். So alkane அதோட preparation and அதோட chemical reaction and physical properties. Alkene அதோட preparation, chemical reaction, properties and alkyne அதோட preparation. Okay, so benzene is also not there. So benzene நான் இங்க எழுதல. Okay, benzene நான் எடுக்கல. So after this we can check. IUPAC முடிஞ்சதுல we can move to next chapter. Next chapter எங்க போச்சு? எந்த chapter வேணும்? next chapter சொல்லுங்க. So I will take that chapter. So what chapter you want? I will take that chapter. Haloalkanes and haloarenes வேணுமா? இல்லனா aldehyde ketone phenol வேணுமா? aldehyde ketone carboxylic acid வேணுமா? Haloalkanes and haloarenes. So haloalkanes and haloarenes I will finish. Okay, so சீக்கிரமா I will finish. So after that aldehyde and ketone we can take. Okay, because இது ஒரு base chapter தான். Okay, இது ஒரு base chapter தான். இதுக்கு அப்புறம் Kashifa, definitely I will take aldehyde and ketone also. Okay, after this chapter I will take aldehyde and ketone. Clear ada? Clear ada? Okay, clear ah? In the chapter I will finish and then I will take aldehyde and ketone carboxylic acid. Clear ah? Kashifa and Bojia. Okay, so I will give you a 15 minutes break. Okay, I will give you a 15 minutes break for you guys. Good evening Sujit. Yes, good evening. So எல்லாரும் சீக்கிரமா செஷன் லைக் பண்ணுங்க because நமக்கு என்ன வேணும்? நமக்கு 300 likes வேணும்ல. எனக்கு எனர்ஜி வேணும். ஸோ எனர்ஜி எங்கேருந்து கிடைக்கும்டா? எனக்கு எனர்ஜி உங்கள் கையில் இருந்து தான் எனக்கு எனர்ஜி கிடைக்கும். எஸ் வர்ஷிதா. ஓ வர்ஷிதா. ஸோ ஐ வில் கோ அண்ட் ஐ வில் ஹாவ் சம்திங். ஓகே, ரொம்ப டயர்டாக ஃபீல் ஆகுது. ஸோ ஐ வில் கோ அண்ட் ஐ வில் ஹாவ் சம்திங். ஸோ தென் ஐ வில் கம். ஓகே, ஸோ ஆஃப்டர் ஸோ ஏதாச்சும் சாப்பிட்டுட்டு ஐ வில் கம். ஓகே, பிகாஸ் இங்கே லைக் இப்போ ஸ்டாண்டிங் பொசிஷனில் இருக்கிறதுனால கொஞ்சம் ரொம்ப டயர்டாக இருக்குது. ஸோ இது வரைக்கும் ஓகேயாக போனது, பட் இப்போது கொஞ்சம் டயர்ட் ஃபீல் இருக்குது. ஸோ இப்போ போய் ஸோ நான் ஃபுட் ஏதாச்சும் சாப்பிட்டு ஐ வில் கம். ஓகே ஓகே ஓகே. So I will give you a 20 minutes break. Okay, I will give you a 20 minutes break. Then I will come. Okay, I will join. So ellarum proper aveno because this is very important chapter. Okay, this is very important chapter. So ellarum proper ah varano. Okay, so ellarum proper ah varano. So I will write here. What is time now? 7:02. So here I will write 7:25. And target like is there. So what is target likes? இப்போ எவ்வளோ லைக் ஆயிடுச்சுடா? இப்போ எவ்வளோ லைக்ஸ் ஆயிடுச்சு? 52. Yes, 50. We crossed 52. So target like is 275 likes. Okay. So 275 தான் நம்மளோட target like. Okay. So definitely we will achieve our target. Okay. So yes டா, நான் போய் சாப்பிட்டு வரேன், ரொம்ப பசியா இருக்கு. Okay, guys. Hello. Yes. வந்துட்டேன் திருப்பி வந்துட்டேன். ஓகே, ஹெப்சி அக்கா ரொம்ப ஃபேமஸ். Hi guys, so we can start. So 275 like ஆயிடுச்சா? So we can check that first. 275 likes ஆயிடுச்சா? Because I'm taking that much effort. Okay, I need 300 likes, no doubt. Oh wow, first then target is actually 300. Okay, 300 reach பண்ணிட்டேனா? Wow. Okay, so we can start. Soda start பண்ணலாமா? Yeah, I'm back. So hello alkenes and hello arenes. So again I'm repeating, hello alkenes and hello arenes வேணுமா இல்லனா aldehyde ketone carboxylic acid வேணுமா? குயிக்கா சொல்லுங்க. hello alkenes and hello arenes வேணுமா aldehyde ketone carboxylic acid வேணுமா? No, 130 இருந்ததுடா. 130 இருந்தது ஸ்டார்டிங்ல எல்லாம். Thank you. So எல்லாரும் நீட் ட்ரெஸ் கோட் வீடியோ போய் பாருங்க. ஓகே, பிகாஸ் தட் இஸ் வெரி இம்பார்ட்டன்ட். எது போடணும் எது போடக்கூடாதுன்னு தெரியாதுல்ல. ஸோ அந்த வீடியோ போய் ப்ராப்பராக பாருங்க. ஓகே, தட் இஸ் ஆல்சோ வெரி இம்பார்ட்டன்ட். செஷனுக்கு அப்புறம் ஓகே, போய் ஓடி போய் பார்க்கும். Hello alkenes, yes, everyone is saying. Okay, nice. Your wish. Okay, then I will take hello alkenes, hello arenes. So first one is classification. Okay, we will finish quickly. Okay, so next இது வரைக்கும் base எல்லாமே strong பண்ணிட்டேன். So அதுக்கப்புறம் we will quick finish எல்லா chaptersம் finish பண்ணும். Okay, hello alkenes and hello arenes. After that aldehyde ketone carboxylic acid and அதுக்கப்புறம் என்ன இருக்குடா? We will finish everything. ஆத்ரான. Okay, so classification. First is primary halide is there, secondary halide is there, tertiary halide is there. What is primary halide? Halogen is attached with carbon, so that carbon is attached with one carbon, that is primary halide. Okay, what is? No, there is lots of conditions are there for dress. Okay, dress code is there. Proper dress code na formal dress ஒன்னும் இல்ல. So நீங்க வீட்ல இருக்கிற dress எடுத்து போனா ஓகே செட். So floral print முடியாது, அது முடியாது, இது முடியாது. And alcohol, phenol, ethers and amines, biomolecules. So first I will finish this chapter, then I will finish aldehyde ketone carboxylic acid, then I will finish alcohol, phenol, ethers, then biomolecules and amines. Okay, set. So classification clear dana. And next classification is vinyl halide. What is vinyl halide? So here halogen is attached with sp2 carbon. Okay, halogen is attached with sp2 carbon, so that is vinyl halide. Allyl halide, so halogen is attached with sp3 carbon, so that sp3 carbon is connecting with the sp2 carbon, that is vinyl halide. Okay, that is vinyl halide. Okay, is it clear? That is vinyl halide. So here உங்களுக்கு என்ன questions எல்லாமே இருக்கு. So you should do the questions. Okay, you should do the question. I am giving questions and everything. Okay, so நீங்க தான் questions பண்ணணும். Okay, இப்போ நமக்கு limited time தான் இருக்கு, content finish பண்ணணும். So I am focusing contentல focus பண்றேன். Gene is not allowed. Genes are not allowed. So அந்த வீடியோ போய் பாருங்க. So உங்களுக்கு yes, உங்களுக்கு ஒரு proper ஒரு ஐடியா கிடைக்கும். Okay, So yes, so you should do maximum questions. அவ்வளவுதான். Method of preparation of haloalkanes. Okay, haloalkanes oda method of preparation தான் first. First one is now I got energy. Okay, so I ate some food, so I am happy. Dress code எதுக்கு அப்புறம் ஹெப்சி ப்ராப்பரா செஷன் பாரு ஹெப்சி அக்கா so first one is from alcohol. Okay, here you can see alcohol is there. So alcohol is reacting with the haloalkanes. So what will happen? So hydrogen halide, not haloalkane, hydrogen halide. What is it's not issue. Why you asking? Sorry, nothing, chill pill. Okay, so hydrogen halide. So hydrogen halide enna nadakum, we know that. So OH group is minus, R is positive. So here also H plus and X minus. So OH enna OH minus group. Okay, minusum plusum enna nadakum, minusum plusum attraction nadakum. So inga plus H plus OH minus. So it will eliminate like water. Okay, first protonation nadakum. So protonation inga varum. So adukaprom R plus form ஆகும். So R plusல rearrangement possible இருந்தா rearrangement நடக்கும். So rearrangement possible இல்லைனா, okay, if there is no rearrangement, so அப்படியே RX will form. Okay, RX will form. Okay, we already discussed this question, the same concept in hydrocarbons. Okay, the same concept we discussed in hydrocarbons. Okay da. So next, from alcohol, this is actually Lucas reagent. Okay, from Lucas reagent, you know guys, what is Lucas reagent? Lucas reagent is concentrated HCl plus anhydrous zinc chloride is Lucas reagent. Okay, concentrated HCl plus anhydrous zinc chloride is actually Lucas reagent. Okay, that is actually Lucas reagent. So primary alcohol you can see no turbidity, there is no turbidity. So Lucas reagent add பண்ணும்போது. Okay, secondary alcohol you can see after few minutes, after 5 minutes you can see turbidity. And when you consider tertiary alcohol, there is no, when you consider tertiary alcohol, immediate turbidity you can see. Okay, tertiary alcohol you can see immediate turbidity. Secondary alcohol it will take some minutes. For primary alcohol there is no turbidity. Okay, there is no turbidity. So then here also you can see some questions are there. And method of preparation of haloalkanes. Okay, next method of preparation da from alcohol without rearrangement. Okay, so last in a rearrangement irundirukku. So inga there is no rearrangement. That is actually Darzin's reaction. Okay, Darzin's reaction in presence of thionyl chloride. Okay, thionyl chloride oda presence la reaction nadakkumbodhu enna nadakkum? So here you can see RCl. Okay, very simple. Okay, OH inga irundhu pogum, Cl inga varum. Okay, so it will form RCl. Okay guys, so here the important point is, okay, so you will get retention product and you will get inversion product. Okay, thionyl chloride mattum use panna you will get retention product. Okay, do you remember what is retention product? Same side la chlorine vanda attach ana, that is retention product. If you are using pyridine in presence of thionyl chloride, okay, thionyl chloride oda presence la if you are using pyridine also, then what will happen? So you will get inversion product. Okay, inversion product you will get. Okay, so clear? So what will be the byproduct? HCl and SO2 will be the byproduct. Okay, HCl and SO2 will be the byproduct. And I want to add one more thing. So this is a good method to prepare alkyl chloride. Okay, it is a good method to prepare alkyl chloride. Why? Because here you can see SO2 is a gas, so it will escape from here. So HCl is also a gas, so it will also escape from here. So here you will get pure alkyl chloride. Okay, here you will get pure alkyl chloride. Few days back purchase pona. So எல்லாரும் சீக்கிரமா லைக் பண்ணணும். ஓகே, அவ்வளோ எஃபர்ட் எடுத்து பண்ணியிருக்கு உங்களுக்காக. So next is reaction with PX3 and red phosphorus. Okay, PX3 and red phosphorus. So what will happen? So simple. So here alcohol is there. So we are taking 3 mole of alcohol. Okay, we are taking 3 mole of alcohol in presence of PX3 and red phosphorus and halogen. Okay, PX3, red phosphorus and halogen. What will happen? You will get RX3. Okay, 3 mole of RX3. So simple this reaction. Okay, 3 mole of oxygen alcohol is there, 3 mole. So PX3. Okay, so what will happen? This P and OH3. Okay, P and OH will form H3PO3. Okay, this byproduct is actually very important. Here it will form H3PO3 and RX. It will form 3RX and H3PO3. Okay, H3PO3. The byproduct is also very important in this reaction. So here, if we are using PX3, okay, if you are using PX3, the byproduct will be H3PO3. The byproduct will be H3PO3. Okay, the byproduct will be H3PO3. Is it clear, da? Is it clear? Any doubt? Is it clear? If you are taking, okay, if you are taking PCl5, okay, that is PCl5, pentachloride, okay. So if you are taking pentachloride, what will be the product? The product will be POCl2. The byproduct is also important here, okay. Here the product is RCl and byproduct is POCl3 and HCl, okay. POCl3 and HCl. OVR, yes, OVR is back. So here everyone like the session POCl3, okay, POCl3. So HCl, okay. Then here you can see some questions are there. Questions like NEET 2024 question. So you can see questions, so you can do questions, okay. So after this session, I will share this PDF. So do the questions, okay. Just do the questions because questions are very important. Next method of preparation of haloalkanes, okay. So first haloalkanes oda preparation da, okay. Haloalkanes oda preparation la next method da from hydrocarbon la we are going to prepare. So what is hydrocarbon? That is RX only, okay. Yes, Pooja is here. So here you will get hydrocarbon. So from alkane by free radical halogenation. So free radical halogenation we discussed in hydrocarbon. Do you remember free radical halogenation? There is initiation, propagation, termination. Okay, initiation, propagation, termination method. We already discussed all the methods in hydrocarbons. Okay, do you remember? Do you remember? So all organic chapters interconnected da, okay. Most of the organic chapters interconnected da, okay. So then here you will get questions, okay. Here you will get lots of questions. So do the questions, okay. Maximum questions pannunga, okay. Maximum questions pannunga. Next is from hydrohalogenation of alkenes. So next is from hydrohalogenation of alkenes. So what is hydrohalogenation? So here I am taking alkene, hydrogen halide is there, agda. Hydrogen halide is there, okay. So what will happen? This double bond will break. First carbon, okay, so hydrogen will come and attach, okay. First that it will follow Markovnikov's rule. This also we discussed in hydrocarbons. This concept also we discussed in hydrocarbons. This concept also we discussed in hydrocarbons, okay. So what will happen? It's very simple. So here you can see rearrangement is possible, okay, because first Markovnikov's rule, okay. So hydrogen will attach to this carbon. So here carbocation will form. Rearrangement is possible if there, okay. If rearrangement is there means rearrangement is possible. Then and the carbocation la halogen will attach, okay. And the carbocation la halogen will attach. Then we are moving to next preparation method, that is allylic and benzylic substitution method, okay. So allylic and benzylic substitution method la chlorination method irukku, bromination method irukku, okay. Any reagent rule? No, reagent rule is not there, but when you consider bromination and chlorination, bromination will occur in tertiary. So it is more selective. Okay, so when you consider chlorine is highly reactive than selective. So chlorine is selective illa, it is more reactive. Okay, so அப்படி ஒரு rule இருக்கு. So அவ்வளவுதான். Okay, so allylic, and here you can see. So here you can see that. So double bond is treating என்ன இங்க chlorine இருக்கு, bromine இருக்கு. So bromineல என்ன நடக்குது? chlorine வரும்போது simple என்ன நடக்குது? So double bond break ஆயிருக்கு. double bond break ஆகி யாரு வரும்டா? So double bond CH3 remove hydrogen பண்ணிட்டு so direct இங்க தான். okay, இங்க double bond break ஆகாது. there is no rearrangement. okay, so there is no rearrangement because it's allylic and benzylic substitution da. okay, allylic and benzylic substitution. Then what will happen? So what will happen? Allylic means carbon. okay, this carbon is connected, halogen is connected with the carbon. So that carbon is sp3. So that sp3 carbon is attached with the sp2 carbon. okay, that carbon is attached with sp2 carbon. So என்ன நடக்கும்? சிம்பிளா கார்பன் இங்க chlorine வந்து so allylic carbon மாறும், allylic மாறும். okay, allylic halogen you will get. okay, allylic halogen. So here also you will get allylic. So here the reagent is very important. okay, here the reagent is very important, that is N-bromosuccinimide. okay, N-bromosuccinimide. brominationல இருக்கிற என்ன reagent is actually N-bromo. this is actually N-bromosuccinimide. okay, so here chlorine free radical and 500 degrees Celsius temperature la reaction நடக்குது. So this is actually benzylic. what is benzylic? do you remember benzylic halide? benzylic halide na direct benzene மேல என்ன ஒரு கார்பன் இருக்கும், அந்த கார்பன் மேல தான் you can see halogen. okay, you can see halogen on carbon that contain. okay, so here I will tell you, benzene is connected with the carbon, so that carbon contain halogen atom. that is actually benzylic halide. okay, that is actually benzylic halide. எல்லாரும் குயிக்கா செஷன் லைக் பண்ணுங்க, எனக்கு எனர்ஜி வேணும்ல. so bromine, so என்ன H. okay, here light ஓட presence ல reaction நடக்குது, and Cl light ஓட presence ல reaction நடக்குது. so அவ்வளவுதான். and here you can see lots of questions, and இதோட mechanism எல்லாம் detail வேணும்னா இதோட one shot, இந்த chapter ஓட one shot இருக்கு, அது போய் பாருங்க. okay, so here I am giving என்ன mechanism already hydrocarbonsல சொல்லி இருக்கு. mechanism அவ்வளோ என்ன rearrangement வரும்போது மட்டும்தான் சொல்றேன். so பாக்கி எல்லாமே அப்படியே follow பண்ணா போதும். okay, so method of preparation of haloalkenes ஓட next method தான் Finkelstein reaction. Finkelstein reaction is also a named reaction. so here you can see alkyl halide, sodium iodide and dry acetone ஓட presence ல reaction நடக்குது. okay, dry acetone means double bond. okay, this is diacetone. okay, this is the acetone. okay, so and or dry methyl sulfoxide ஓட presence ல நடக்கும். okay, either acetone இல்லனா dry methyl sulfoxide ஓட presence ல reaction நடக்கும். so what will be the product? it is very simple. so from alkyl chloride or alkyl bromide ல இருந்து we are preparing alkyl iodide. okay, from Finkelstein reaction la we are preparing alkyl iodide from alkyl chloride or alkyl bromide. okay, alkyl bromide illana alkyl chloride la irundhe we are preparing alkyl iodide. okay, so everyone quickly like the session. enoda like energy down agudhu, so energy down agudhu, enoda energy down agudhuda, so I need energy. okay, so yeah, Schwarz reaction. next is Schwarz reaction. what is Schwarz reaction? so you can use metal fluoride. here we will use metal fluoride as a reagent, and we will get alkyl fluoride. okay, alkyl fluoride will be the product. okay, alkyl fluoride will be the ப்ராடக்ட். ஓகே, ஸோ ஆல்கைல் ஃப்ளூரைட் ப்ரொடியூஸ் பண்ணுறதுக்காக யூஸ் பண்ணுற ரியாக்ஷன் தான் என்னடா? ஸ்வாட்ச் ரியாக்ஷன். ஐ வாண்ட் டு சி 300 likes. ஓகே, ஸோ வித்தின் 10 minutes I want to see 300 likes. Okay, Tata Gluco. So yes, so here you will get AgF, இல்லனா SbF3, COF2. so ஏதாச்சு மெட்டல். okay, இங்க இருக்கிற ஏதாச்சு மெட்டல் fluoride you can use. okay, you can use any metal fluoride. so here I used different metal fluorides. okay, yes Sasmita, seriously. okay, so I want to see 300 likes. okay, Manchu, come on, like the session. I want to see your likes. okay, so here I will give you one question. so it's AIMS 2017 question. okay, you can write the answer. Tell me the answer. What will be the answer? Durga, yes. okay, Sasmita, it's okay. No issue da. I believe you guys. I believe you. Option B. So alkyl fluoride is best accomplished by, yes, it's Schwarz reaction. Now only we discussed. okay, it's Schwarz reaction. yes. So and here also it's, then what will be the correct answer? Next is very important, SN1 SN2 reaction. okay, we are discussing about SN1 and SN2 reaction. We are going to discuss about SN1 and SN2 reaction. guys, are you ready? so chemical properties of haloalkanes la first one nucleophilic substitution reaction da. இங்க ஒரு நியூக்ளியஸ் வந்து ஆல்கைல் ஹாலைடை அட்டாக் பண்ணுது. என்ன நடக்குது? ஸோ இங்கிருந்து ஹாலஜன் போகும், பிகாஸ் ஹாலஜன் இஸ் a living group. so halogen will live and here nucleophile will attack here. okay, nucleophile will attack to alkyl group. so I will tell you detailing. so there is two method. okay, there is two method. SN1 reaction is there and SN2 reaction is also there. okay, SN1 reaction is there and also SN2 reaction. okay, grandpa another dad. oh my god, my 2 accounts waiting for my brothers to come to tell him to like the session. oh my god, thank you Sasmita. oh my god, she is taking this much effort. Sasmita, thank you so much. oh my god. so yes, so here what will happen? okay, this is your you can write what should I give the name? So you can give any name. Finally I found my twin, but they say Ashwati ma'am is mid. oh my god, thank you Kashifa. Sunny Bunny, yes, where is Sunny Bunny? I can't see Bunny. yes, you can give Sunny Bunny. yes, good name. This is Bunny, this is Sunny. okay, so Bunny is sleeping. so after that Bunny என்ன இங்க இருந்து Bunny போயிருக்கு. okay, so அப்போ என்ன Sunny ஓடி வந்து அங்க படுத்திருக்கு. okay, so Sunny first என்ன Bunny இங்க இருந்து போயிருக்கு. this is Bunny. okay, so Bunny இங்க இருந்து போயிருக்கு. அப்போ யாரு வந்து படுத்திருக்கு? Sunny வந்து படுத்திருக்கு. that is first one. okay, Gen Z line. yeah, I understand. Google it. okay, yeah, I will Google. Gen Z word, you guys are Gen Z kids, spookies. so next one. okay, so next one ல என்ன நடக்குதுடா? next one ல என்ன நடக்குது? Sunny Bunny படுத்துட்டே இருக்கு. so Sunny என்ன இங்க வந்து அட்டாக் பண்ணுது. okay, Sunny வந்து அட்டாக் பண்ணுது. so இங்க இருந்து Bunny போயிருக்கு, Sunny அங்க வந்து படுத்திருக்கு. okay, clear? Bunny is disappeared. Bunny is not there. so that's the reason I am saying Bunny and Sunny. okay, So இங்க என்னடா நடந்திருக்கு? So bunny is actually இங்க என்ன ஸ்லீப் பண்ணியிருக்கு, ஸ்லீப் பண்ணுது. ஸோ யார் வந்திருக்கு சன்னி வந்து பன்னியை இரிட்டேட் பண்ணிட்டு அங்கேருந்து பன்னி ஓடி இருக்கு. ஓகே, சன்னி அப்போ அந்த சேம் டைமில் வந்து படுத்திருக்கு. ஓகே, ஸோ இதுதான் SN2 reaction. This is SN2 reaction. This is SN1 reaction. Okay, we can detailedly discuss SN1 and SN2 reaction. Okay. Okay. No, this is no. No. Yeah, here I will tell you. So listen carefully da. What is happening here? You can see bromine is there and 3 other group is also there. So bromine inga irundhu pogum. Okay, bromine is a living group. Bromine inga irundhu poor bunny bro is not here. Bunny bro is not here. We are teasing bunny bro. Okay, so inga ennada? So here you can see bromine will live because bromine is a it's a living group. Okay, it's a 2-step process. Very good. So first bromine inga irundhu poirukku, appo then what it will form carbocation. Okay, it will form carbocation. This is carbocation. So carbocation, one side la hydrogen irukku, one side la methyl group irukku, one side la phenyl group irukku. So next step la who will come? Nucleophile will come. Okay, nucleophile will come. இங்க இருந்து பன்னி போயிருக்கு, அதுக்கப்புறம் யாரு வந்திருக்கு? சன்னி வந்திருக்கு. Who is bunny? Bunny is a student da. So he is a student. வீணி தமிழ்நாடு ஸ்டூடெண்ட் தான் பன்னி. ஸோ இந்த கிளாஸில் லைக் ஆல்மோஸ்ட் இவ்வளோ டைம் இருந்தது இப்போ போனதுன்னு நினைக்கிறேன். ஸோ என்ன? ஸோ நியூக்ளியோஃபைல் வில் கம் அண்ட் அட்டாக். ஓகே, ஸோ இஸ் a தெலுங்கு ஸ்டூடெண்ட். ஓகே, ஸோ இங்க nucleophile வந்து attack பண்ணும். So here you can see nucleophile is attached. Okay, nucleophile is attached. So PH means phenyl group, Me means methyl group. Okay, Me means methyl group, PH means phenyl group. Okay, so இதுதான். Okay, so here you can see first step and this is second step. Okay, this is second step. Okay, clear and is it clear? And so இங்க நியூக்ளியோஃபைல் வந்து அட்டாக் பண்ணும்போது, ஓகே, நியூக்ளியோஃபைல் வந்து அட்டாக் பண்ணும்போது, ஸோ இதுதான் புரோமினோட பிளேஸ். ஓகே, இதுதான் புரோமினோட பிளேஸ். ஸோ ஐதர் டைரக்ட் புரோமின் பிளேஸ்ல வரலாம். தட் மீன்ஸ் that is a retention product. Okay, this is our retention product. Same brominoda place la nucleophile vanda, we can say that it is retention product. So here opposite side la vanda, okay, inga vanda, that is actually this is actually opposite side la vanda, that is actually retention and inversion product. This is inversion product. This is inversion product. Is it clear, guys? Is it clear? இன்னும் எவ்வளோ இருக்கு? இன்னும் நிறைய இருக்குடா. So normally what we will think, yeah, inversion and retention product is 50% only. Okay, so actually not. Okay, inversion and retention product together we will call racemic mixture. So what we will think, yeah, inversion and retention product is 50% only, but actually what is actually correct? So here retention, okay, here the retention product, okay, here the retention product is less. Okay, retention product is less than inversion product. Okay, here the retention product is less than inversion products. Okay, so here we, not less means you don't assume like 30%, 20%, like 49%. Okay, retention product is 49% and inversion product is 51%. Okay, retention product is 49% and inversion product is 51%. Okay, clear? Then we are moving to SN2 reaction. So in case of SN2 reaction, it is a single step reaction. Okay, when you consider SN2 reaction, it is a single step reaction. What will happen? At the same time, the nucleophile will attack. At the same time, RX bond will break. Okay, so nucleophile is attacking, RH bond is breaking. Okay, here you can see only one type of product, that is inversion product. Okay, here you will get only inversion product. Okay, you will get inversion product. Clear? Okay. Ma'am, do you remember? Yes, I remember Palani. He asked what is racemic mixture. Yes, Sally gave an exam. Wow, that's so nice. Aniki na racemic mixture enna solli koduthirukilla. So happy. I'm so happy. Okay, 12th exam la நான் என்னோட கிளாஸ் லெக்சர் பார்த்த ஆல்மோஸ்ட் எல்லா ஸ்டூடெண்ட்ஸ்க்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்குது. எனக்கு டெஃபினட்டாக தெரியும். பிகாஸ் அவ்வளோ டிட்டோ கொஸ்டின் மாதிரி வந்திருக்கு. அவன் ரொம்ப ஹாப்பியாக இருந்தது, நானும் ரொம்ப ஹாப்பியாக இருந்தது. ஸோ ஐ டென்ட் எக்ஸ்பெக்ட் இவ்வளோ கொஸ்டின் வரணும். ஸோ லைக் ஐ செக்ட் லைக் 3 or 2 okay question like that code. Okay, 2 or 3 like almost 24 questions same vandirukku. I was like, oh my god, I was so happy. I'm now also I'm so happy. So you will get a transition state. You will get a transition state. What is transition state? So partial. Okay, partial bond you can see. Okay, you can see partial bond. Okay, 2 partial bond you can see. It's not complete bond. So bond forming and bond breaking. So it is a transition state. Okay, here RCB won the toss. Yeah, RCB will win the game. So yes, SN1, SN2, I hope it's clear. SN1, SN2 reaction. So here also you can see lots of questions related to SN1 and SN2. Then we are moving to elimination reaction. So everyone quickly like the session. Because I'm waiting for 300 likes. Okay, I'm waiting for 300 likes. So quickly like the session. Mixture bring. Yes, 50% retention and 50% inversion irunda, that is actually optically inactive element. Yes, correct. That is actually optically inactive only. Then elimination means here இங்க இருந்து எலிமினேட் ஆகும். ஓகே, யார் எலிமினேட் ஆகும்? ஸோ ஹாலஜன் எலிமினேட் ஆகும். ஹாலஜன் மட்டுமா எலிமினேட் ஆகும்? இல்லை, இங்கே பக்கத்தில் இருந்து ஹைட்ரஜனை எலிமினேட் ஆகி டபுள் பாண்ட் ஆகும். ஓகே, ஸோ இன் ப்ரெசன்ஸ் ஆஃப் பேஸ். ஓகே, இன் ப்ரெசன்ஸ் ஆஃப் பேஸோட ப்ரெசன்ஸில். ஓகே, இன் ப்ரெசன்ஸ் ஆஃப் பேஸ். ஓகே, தட் இஸ் ஆக்சுவலி elimination reaction. So I will tell you, so the mechanism of elimination reaction. So here base. Okay, base inga direct என்ன ஹாலஜனை அட்டாக் பண்ண முடியாது. Because base oda charge என்ன negative தான். Halogen இல்ல என்ன இருக்கு? We know that halogen contain lone pair of electron. Okay, halogen contain lone pair of electron. Oh, 8 hours 57 minutes. Oh my god. So halogen also contain lone pair electron. So what will happen? So this base will attack hydrogen. Okay, base will attack hydrogen. So here also a transition state will form. Okay, transition state will form. So bond formation, bond breaking, bond formation, bond breaking. Okay, so this bond will break, this and this bond will break. So it will form double bond. Clear? Yes, I am an RCB fan. ಈ ಸಾಲ ಕಪ್ ನಮ್ಮದು. That I know. ಈ ಸಾಲ ಕಪ್ ನಮ್ಮದು. Okay, here you can see lots of like reactions, questions, and we are moving to nitrobenzene can give nucleophilic substitution reaction. Okay, nucleophilic substitution reaction, nitrohalobenzene. Okay, this is nitrohalobenzene. So here chlorine. Okay, so chlorobenzene. Okay, so nitrochlorobenzene. Okay, nitrochlorobenzene. So and it's reacting with OH. Okay, it's reacting with OH. What will happen? It's very simple. So inga irundha chlorine pogum, adukku badila you can see OH will attach. Okay, chlorine will leave, OH will attach. So this reaction will not happen. Why? Because it is a ortho para directing. Okay, meta directing da, so meta directing la it is not possible, so ortho para directing only possible. Okay, so ortho para directing only possible. Time to solve these questions, so you can solve da, so you can solve, so that's very important. Okay da, question you should solve question. Okay, so நீ question solve பண்ணா மட்டும்தான்டா உனக்கு என்ன இங்கிருந்து இந்த செஷன் பார்த்ததுக்கு பெனிஃபிட்டே இருக்கும். ஓகே, ஸோ செஷன் பார்த்ததுக்கு பெனிஃபிட் வேணும்னா யூ ஷுட் என்ன சால்வ் ஆல் த கொஸ்டின். ஓகே, யூ ஷுட் சால்வ் ஆல் த கொஸ்டின்ஸ். நெக்ஸ்ட் எலக்ட்ரோஃபிலிக் சப்ஸ்டிடியூஷன் ரியாக்ஷன். ஸோ குளோரின், ஓகே குளோரின் அண்ட் என்ன ரியாக்ட் பண்ணும்போது, ஓகே ஒரு எலக்ட்ரோஃபைல் மேலே ரியாக்ட் பண்ணும்போது இட் இஸ் ஆக்சுவலி ஓர்த்தோ பேரா டைரக்டிங். ஓகே, ஓர்த்தோ பேரா டைரக்டிங் தான். அண்ட் ஹியர் யூ கேன் சி E. ஓகே, E பேரா பொசிஷன்லேயும் இருக்குது அண்ட் மெட்டா பேரா பொசிஷன்லேயும் இருக்குது, ஓர்த்தோ பொசிஷன்லேயும் இருக்குது. ஓகே, எஸ் அருண், வெயிட்டிங். வை அருண், வாட் ஹேப்பன்ட்? ஈஸி டு ரீட். வாட்? யா, ஸோ E, what is E da? Yeah, a channel manager is there da. So here you can see E. Okay, E is there. Okay, E, yes, so E is there. So this is actually major product. Why it is major product? Because it is para position la irukku. And one more thing, okay, there is one more thing. What is that? So one more thing, para position la irukku, edunala meta position is not major product. Why? Why meta position is not major product? Why? Because here you can see steric hindrance is more. Okay, steric hindrance is more. So yes, we need so here para position is there, so para position is more stable product, so it will form major product. Okay. Yeah, Gopika ma'am is here. Gopika ma'am only. That is okay. Okay, then we are moving to halogenation. Okay, halogenation. So that's not manager, that is Gopika ma'am, guys. That is not manager, it's Gopika ma'am only. Yeah. So here halogenation. So halogenation means treating with halogen. Okay, treating with halogen. So here we are taking halogen. So in presence of iron. Okay, in presence of iron, what we will get? So para position liyo adu madri என்ன மெட்டல்ல para position liyo ortho, because it is ortho para directing. Okay, it is ortho para directing. So ortho position liyo you can see halogen, para position liye halogen varum, and para position is major. Okay, so para position is major. Why? Because para position is major. Why? Because meta position la halogen varumbodhu steric hindrance is there. Okay, meta position la halogen varumbodhu steric hindrance is there. So para position la halogen varumbodhu enna steric hindrance kammi agum, and it is highly symmetric also, so it is major. Okay, yeah, my Vishukani was superb, you know, 1:30 live. So live watching, that was my Vishukani. Okay, clear? Then next we discussed about halogenation. So first we are discussing about nitration. So nitration means nitration will occur in presence of concentrated HNO3 and concentrated H2SO4. Okay, so in presence of concentrated HNO3 and concentrated H2SO4, concentrated H2SO4 and concentrated HNO3 oda presence la da ennada nadakku nitration. So what will happen? It's very simple. It is ortho para directing. Okay, it is ortho para directing. Okay, so ortho para directing la we know that para is major product. Okay, para is major product. Okay, ஸோ தேங்க்யூ. ஓகே, நீங்கள் இது ப்ராப்பராக படித்து எல்லாமே பண்ணால் போதும், அவ்வளோ போதும் எனக்கு. ஓகே ஓகே, ஸோ கைஸ் என்ன நடக்கும்? ஸோ யூ கேன் சி ortho and para directing. So we know that it is ortho and para directing. So ortho and para directing வரும்போது என்ன கிடைக்கும்? Which one is more stable? Obviously para directing is more stable. Okay, para directing is more stable. Why? Because எதனால? Because steric hindrance is less. Steric hindrance is less means it is more stable. Okay, halogenation, same halogenation, this only da. So halogenation means, so we are treating in presence of halogen. Okay, so we are treating in presence of halogen. So obviously what will be the product? Either para or ortho directing. Okay, the product will be ortho directing or para directing. Rudra, is it clear? Either ortho directing or para directing. So when you consider ortho directing, steric hindrance is more. What is steric hindrance? NO2 and Cl. So it's a bulky group. So it contains electron. Electron is there means, okay, electron is there means we know that repulsion is more. Okay, electron is there means repulsion is more. So repulsion is more means less stable. Okay, repulsion is more means it is less stable. So when you consider here, you can see distance is there. Okay, here என்ன? So பக்கத்துல தான் இருக்கு. இங்க என்ன? Distance is there. So distance is there means steric hindrance is less. Okay, steric hindrance is less means what will be? It will become more stable. Okay, it will become more stable. Is it clear? Yes, Rudra is saying clear. So this is nitration. Nitration in presence of HNO3 and H2SO4. Then next is sulfonation. Sulfonation in presence of H2S2O7. Okay, H2S2O7 is actually oleum. That is actually oleum. H2S2O7 is oleum. So here in presence of oleum we are treating. So same thing, we will get ortho para directing compound, and the para is more stable. Okay, para will be the major product. Okay, para will be the major product. Is it clear, guys? Is it clear? So here also you can see questions are there. Do the questions. So next is Friedel-Crafts alkylation. Okay, Friedel-Crafts alkylation. So it's very simple. So RCl, okay, alkyl chloride. Okay, here alkyl chloride is reacting in presence of anhydrous zinc and anhydrous aluminum chloride. Anhydrous aluminum chloride. So what will happen? So here R plus will form. Okay, this R plus and Cl minus. So if there is any rearrangement, if rearrangement is possible means, so rearrangement will happen. So it will attach to ortho and para position. Same way, ortho and para position. But the major product is para product. Okay, major product is para product. Yeah. Major product is para product. Shifting means it will become more stable now. So we know that carbocation, which carbocation is more stable? Tertiary carbocation is more stable. Then secondary, then primary. Okay, if rearrangement is possible means, so that way. Okay, methyl shift, hydrogen shift is there. Both shift. Okay, both shift will happens in SN1 reaction. Okay, both shift. Yeah, we finished. Then we are moving to, what do you want? You want aldehyde, yes? Where is aldehyde? Ketone carboxylic acid. Aldehyde, ketone carboxylic acid. So can we start? Yeah, that I 100 times I told you na. ராமாயணம் ஃபுல்லு சொல்லிட்டு ராமன் சீதையோட யாருன்னு கேட்குறேன். அது மாதிரி இருக்கு. Why para product is more stable? I mean major product. So para product, yes, I can see Rudra is saying steric hindrance is less. That's why para product is major product. Very good. Yeah, that is the only reason. Okay. So para product la enna irukku? Steric hindrance is less. So it is more product. Acha, more stable. Then we are moving to aldehyde ketone carboxylic acid. Guys, are you ready? Guys, are you ready? Okay, Rudra. Okay, I'm so happy. Okay, we can start. Aldehyde ketone carboxylic acid. Guys, are you ready? Super ready. I am also ready. Okay. Army is ready. Then we can do. So, aldehyde, ketone and carboxylic acid. Okay, aldehyde, ketone and carboxylic acid. We can start it off. So, preparation. நான் ஆல்ரெடி ஸ்லைடில் லாட்ஸ் ஆஃப் எழுதி இருக்கு. ஸோ உங்களுக்கு பார்க்க முடியுதுன்னு நினைக்கிறேன். So, first one is preparation of aldehyde from acyl chloride. Okay, acyl chloride we are preparing. So, what is acyl chloride? So, that is acid chloride. We will say acyl chloride. What is acid chloride? We know that acid. Okay, I will draw here. This is our acid. COOHR. This is a acid, yes. So acid chloride means inga irundhu hydrogen replace pannite chlorine is coming. Okay, this is acid chloride. So yes, so acyl chloride or acid chloride, it is same. Okay, it is same only. Oh yeah, if we give lax. Oh, thank you so much for your compliment. Thank you so much for your compliments. Thank you so much for your compliments. Okay. Yes, Stephen's reaction, Rosenman reaction. I can see lots of reactions. So first one is Rosenman reaction. It's a named reaction. Okay. So from acyl chloride, what is acyl chloride? That is acid chloride. So acid chloride we are preparing aldehyde. Okay, we are preparing aldehyde. So acid chloride is hydrogenated over catalyst palladium or barium sulfate. Okay, barium sulfate illana palladium use பண்ற. இங்க reagent is very important. Okay, brightness is high. Brightness, I think. Oh, this is brightness over ஆயிடுச்சுல. இப்போ brightness over இல்ல. கண்ணடிச்சு போகுது. Is it okay or brightness increase ஆயிருக்குல? Tonight 12. Let's go. It's not clear. இப்போ it's too bright. Blur. Words are blurred. Let me check. Hey, words are not blurred. You're using mobile phone, yes? It's clear only. Mega marathon. Yeah. எனக்கு காலெல்லாம் பெயின். Okay, I want to see 300 likes, okay? Eye protection. Yeah. I want to see 300 likes. Yukka. Okay. Dark color is not possible. We can't change the color. Okay, because I made this slide. No, I didn't have dinner, but I ate some snack. Dinner break. No break for dinner. So yeah, we can start. I think it is okay. Try to adjust. Yeah. Palani. What is your name? Palani only? Or? Okay. So we can start. So here the reagent is hydrogen, barium sulfide and palladium. So what will happen? It's very simple. So inga irundhu yaru pogum? Chlorine pogum. Okay. Chlorine poyachu. Yaru varum? Hydrogen varum. Simple method, that is actually Rosenman reduction. Okay, so benzoyl chloride da irukku. So benzoyl chloride is treating with hydrogen, palladium and barium sulfate. So what you will get? So inga irundhu chlorine poi you will get benzaldehyde. Clear? So again in the aldehyde overreact பண்ணும்போது overreaction நடக்கும்போது என்ன நடக்கும்டா? Simple டா. இங்க இருந்து இந்த aldehyde alcohol maru. Okay, so alcohol maru, but adanala this reagent is actually very important. Okay, this reagent is very important. Illa edachu oru strong reagent edutha, so again reaction nadந்து what will form? Alcohol will form. Okay, so from this method we can't prepare formaldehyde. Okay, from this method we can't prepare formaldehyde. Okay, we can't prepare formaldehyde using this method. Okay, next Rosenman is over. Then here questions allame irukku, do the questions. Okay, next reaction is Stephen reaction. Okay, next reaction is Stephen reaction. So what is Stephen reaction? So nitrile group, here nitrile is reacting with thionyl chloride. Okay, thionyl chloride and hydrogen chloride. Okay, so thionyl chloride and hydrogen chloride is a reducing agent. Okay, it is a reducing agent. So it is a reducing agent. So what will happen? So nitrile are reduced to corresponding imine. So what will be the product? The product is actually imine. Okay, the product is actually imine. So imine with the thionyl chloride in the presence of hydrogen chloride, which on hydrolysis give corresponding aldehyde. So first you will get imine. So again hydrolyze பண்ணும்போது, so again hydrolyze பண்ணும்போது you will get aldehyde. Okay, you will get aldehyde. So this is imine. Okay, this is imine. RCH double bond NH. Okay, this is imine. Okay, RCH double bond NH, or we can say that C R1 R2 double bond N R3. This is also imine. Okay, R ku H ku badala inga R vandalum, that is also imine. N ku badala R vandalum, that is also imine. Okay, imine, not imide. Imide illa imine. Okay, so it is a two-step reaction. It is a two-step reaction. Next, so here you can see another example. Okay, so this is ethyl nitrile. Okay, this is ethyl nitrile. Ethyl nitrile is reacting with thionyl chloride, hydrogen chloride, and in presence of there is two step. Okay, so in the two step we are writing in one step. Okay, so second step is water. Okay, what you will get? You will get aldehyde. Okay, you will get aldehyde. Same reaction da. Okay, benzonitrile varumbodhu, so inga irundhu CN mari anga yaru varum? CHO varum. Okay, CHO varum. Simple. It's very simple. It is actually two-step reaction. So we can write in one step. Okay, so we can write it in one step. Okay, yes, here I can see. So next is Dibal H. Okay, what is Dibal H? What is Dibal H? So Dibal H means Here, okay, I will tell you. So it is also a reducing agent. Dibal H is also reducing agent. So nitrile are selectively reduced by diisobutyl aluminum dihydride. Okay, diisobutyl aluminum hydrate தான் Dibal H. Dibal H ஓட full form. Okay, this is very important. Okay, Dibal H ஓட ma'am hydroboration oxidation. Yes, hydroboration oxidation also we will discuss. Don't worry. Okay, so that too also we will discuss hydroboration oxidation. So Dibal H is, what is the speciality of Dibal H? So normally here we are using, okay, here we are using HCl and thionyl chloride. Okay, HCl and thionyl chloride. So thionyl chloride and HCl use பண்ணா என்ன நடக்கும்? So அது complete reduction நடக்கும். அங்க double bond இருந்தாலும் அதை reduce பண்ணிட்டு single bond மாற்றும். Okay, what is the use of, what is the main purpose of Dibal H? So Dibal H will reduces. Okay, Dibal H selective reduction நடக்கும். Dibal H you can see selective reduction. Okay, you can see selective reduction in Dibal H. So first என்ன நடக்கும்? Same imine will form. Okay, imine followed by imine hydrolyze பண்ணும்போது you will get aldehyde. So here you can see double bond is there. Okay guys, double bond is there. So in the double bond அப்படியே என்ன reduction நடக்காது. டபுள் பாண்டுக்கு ரிடக்ஷன் நடக்காது. நார்மலி ஏதாச்சும் ஸ்ட்ராங் ரெடியூசிங் ஏஜென்ட் எடுத்தா என்ன டபுள் பாண்டுக்கு ரிடக்ஷன் நடக்கும். இங்க டபுள் பாண்டுக்கு ரிடக்ஷன் நடக்காது. ஓகே, டபுள் பாண்டுக்கு என்னடா ரிடக்ஷன் நடக்காது. ஸோ டபுள் பாண்ட் அப்படியே இருக்கும். ஓகே, டபுள் பாண்ட் அப்படியே இருக்கும். ஸோ ஹியர் யூ கேன் சி selective reduction. Okay, selective reduction. So what will form? It will form imine. Okay, first it will form imine. Imine hydrolyze பண்ணும்போது you will get aldehyde. Okay, so here you can see Dibal H does not reduce C double bond C. Okay, Dibal H does not reduce C double bond C, and esters are also reduced to aldehyde with the Dibal H. Esters you convert பண்ண முடியும். Okay, so esters are also reduced to aldehyde with the Dibal H. This is ester, Dibal H, water. So first you will get imine. Imine என்ன hydrolyze பண்ணும்போது you will get aldehyde. You will get aldehyde. Okay, so next, so questions irukku, question you can do. Okay, question I'm not doing questions, you can do the questions. Okay, so from hydrocarbon, okay, from hydrocarbon, oxidation of methyl benzene. Okay, oxidation of methyl benzene. So first one is uses of chromyl chloride. Okay, what is chromyl chloride? CrO2Cl2. Okay, that is a chromyl chloride. Okay, that is chromyl chloride. So chromyl chloride oxidizes methyl group to chromium complex. Okay, so inge enna kadaikum? You will get chromium complex. என்னடா chromium complex? So CrO2Cl2. இங்க என்ன இருக்கு? toluene இருக்கு. Okay, so toluene is treating with the chromyl chloride. So you will get chromium complex. என்னடா chromium complex? So இங்க இருக்கிற CH3 இருக்குல்ல, so அங்க இருந்து 2 hydrogen replace பண்ணும். 2 hydrogen replace பண்ணிட்டு you can see OCrOHCl2. Okay, OCrOHCl2 2 times. Okay, OCrOHCl2, that is actually chromium complex. Okay, that is actually chromium complex. Okay, so chromium complex form ago. So again acidic reaction, like acidic solvent illa, okay, acidic reagent illa hydrolyze பண்ணும்போது you will get aldehyde. So here you will get benzaldehyde. Okay, here you will get benzaldehyde. Okay, here yes Pooja. Then next reaction is uses of chromic oxide. Uses of chromic oxide. Toluene or substituted toluene. Toluene illana substituted toluene is converted to benzyl diene. Okay, benzyl diene convert பண்ணும். Benzyl diene diacetate. Okay, benzyl diene diacetate. So in the benzyl diene diacetate, so it's treating with the chromic oxide which treat பண்ணும்போது what you will get? You will get chromic oxide in acetic anhydride. Okay, acetic anhydride la which treat பண்ணும். So you will get the benzyl diene diacetate can be hydrolyzed to corresponding benzaldehyde மாறும். Okay, simple, same reaction தான் benzene. So this is toluene. Toluene is treating with the chromic oxide. Okay, chromic oxide acetic anhydride. This is actually acetic anhydride. Okay, acetic anhydride is also there. So enna kadikide? Benzaldehyde diacetate. Okay, here you can see benzaldehyde diacetate. Okay, this is benzaldehyde diacetate. So இது acidic mediathல treat பண்ணும்போது you will get benzaldehyde. Okay, you will get benzaldehyde. Benzaldehyde, benzene, benzaldehyde, benzaldene diacetate. This is actually benzaldene diacetate. Clear? I hope it's clear. Clear, guys? Clear? And temperature important da, reagent important da. Okay, reagent and temperature எல்லாமே important da. Next, preparation of ketones. Okay, we are moving to preparation of ketone. So first one is acyl chloride oda preparation. Acyl chloride oda preparation enna? Grignard reagent. Okay, so I will tell you Grignard reagent உங்களுக்கு தெரியும்ல. So first one is acyl chloride. Acyl chloride na என்னன்னு சொல்லி இருக்கு. So இல்ல, so acid chloride ல இருந்து acidல இருந்து ஹைட்ரஜனை replace பண்ணிட்டு அங்க யார் வருது? chlorine வருது. That is acyl chloride. Okay, that is actually acyl chloride. Okay, so treatment of acyl chloride with the dialkyl cadmium gives ketone. Okay, so inga enna pannanum? So first here you can see that alkyl is reacting with the, this is a magnesium, 𝐷𝐼𝐺𝐴𝑥. What is 𝐷𝐼𝐺𝐴𝑥? That is a Grignard reagent. So Grignard reagent is reacting with the organocadmium. Okay, organocadmium means CdCl2 the organocadmium. Okay, organocadmium கூட react பண்ணும்போது என்ன கிடைக்குது? alkyl cadmium கிடைக்குது. This is actually alkyl cadmium. So alkyl cadmium தான் நம்ம யூஸ் பண்ண போறேன். Okay, so acyl chloride கூட alkyl cadmium யூஸ் பண்ணும்போது what you will get? You will get directly you will get aldehyde. Okay, you will get aldehyde. Clear? 𝐷𝐼𝐺𝐴𝑥, 𝐷𝐼𝐺𝑥, 𝐷𝐼𝐺Br or 𝐷𝐼𝐺Cl, anything. Okay, okay. Halogen group. Okay, then next is from nitrile. இதுக்கப்புறம் actually 3 chapters இருக்குல்ல. இதுக்கப்புறம் next எந்த chapter வேணும்? அமீன் வேணுமா ஆல்கஹால் வேணுமா? அமீன் வேணுமா ஆல்கஹால் வேணுமா? நெக்ஸ்ட் எந்த சாப்டர் வேணும்டா? அமீன் வேணுமா ஆல்கஹால் வேணுமா? அமீன், ஆல்கஹால், அமீன். So priority biomolecules we can take last da. alcohol, I don't know, just count எவ்வளோ alcohol இருக்கு எவ்வளோ amine இருக்குன்னு யாராச்சும் count. Oh, I think alcohol தான் major students. So alcohol, yes, amine is small chapter only. Okay, from nitrile group. Okay, from nitrile group, so same, treating a nitrile with the Grignard reagent 𝐷𝐼𝐺𝐴𝑥. Okay, so you will get imine. So followed by hydrolysis will give ketone. Okay, will give ketone. Okay, so we can do. So this is a propane nitrile method, the propane nitrile, and it's treating with Grignard reagent in presence of ether. So what you will get? You will get imine. Okay, it's a imine salt. It's a imine salt. Okay, it's a imine salt. So again in the imine salt hydrolyze பண்ணும்போது, okay, imine salt hydrolyze பண்ணும்போது what will happen? You will get your ketone. You will get the ketone. Okay, you will get ketone. Okay, you will get ketone. Clear? Same reaction. Benzonitrile is there. So benzonitrile kuda என்ன 𝐷MgX and hydrolyze பண்ணும்போது you will get ketone. Okay, you will get ketone. Okay, clear? Okay, you will get ketone. You will get ketone. Okay, I hope it's clear. Then we are moving to chemical properties. So first one is tolerance test. What is tolerance test? That is silver mirror test. Okay, tolerance test also called silver mirror test to identification of ketone. Okay, for the identification of ketone. So tolerance reagent is actually mild oxidizing agent. Okay, tolerance reagent is actually mild oxidizing agent. So what is actually tolerance reagent? A warming an aldehyde with freshly prepared ammoniacal silver nitrate solution. This is actually tolerance reagent. Okay, tolerance reagent. So tolerance reagent, a bright silver mirror is produced due to the formation of silver metal. So you can see a bright silver mirror will form. Okay, and the solution mele a bright silver mirror will form. Why? Because of the production of produced, it will produce silver. Okay, it will produce silver metal. So because of that silver metal, silver color da irukula, so a silver mirror madri it will act. Okay, so the aldehyde are oxidized to corresponding carboxylate anion. Okay, so that aldehyde are oxidized to corresponding carboxylate anion. Okay, ketone does not give tolerance test. Actually identification of aldehyde illa, identification of ketone illa, identification of aldehyde. So identification of aldehyde and ketone nu sollalam. Aldehyde and ketone identify பண்றதுக்காக. Okay, black precipitation illada, not black precipitation. No, not black precipitate. You can see silver mirror. Okay, you can see silver mirror. Okay, because you can see the formation of silver metal will form. Okay, silver metal will form. So because of that silver metal you can see. Okay, next, Felling's test, Felling solution, Felling test. So when you consider Felling test, there is Felling solution A and Felling solution B. So Felling solution A is a aqueous copper sulfate. Okay, aqueous copper sulfate, and Felling solution B is a alkaline sodium potassium tartrate. Okay, that is actually Rochellate salt. Okay, Rochellate salt. So inga Felling solution A யும் இருக்கு, Felling solution B யும் இருக்கு. Okay, so these two solution are mixed in equal amount before test. So test நடக்கிறதுக்கு just before the இந்த two solutions mix பண்ணணும். Okay, so mixture of Felling solution A and Felling solution B. So on heating aldehyde, so aldehyde la Felling solution and add பண்ணிட்டு heat பண்ணும்போது, if you can see a reddish brown precipitate. Okay, here you can see reddish brown precipitate. Here தான் என்ன, you can see reddish brown precipitate. Okay, reddish brown precipitate, you can see that. So you can identify that the presence of aldehyde. Okay, you can identify if reddish brown precipitate is there, you can see the, you can identify the aldehyde presence. Okay, aldehyde oxidize into corresponding carboxylate ion. Okay, and aromatic aldehyde and ketone does not respond to this test. Okay, aromatic aldehyde ketone does not give positive result for this test. Okay, aromatic aldehyde ketone does not give positive result for this test. Then we are moving to reaction due to alpha hydrogen. Reaction due to alpha hydrogen. 𝐂𝐴 reaction from start panlamada. I want to see 300 likes. 2 more likes. Oh, ice pain. Yeah, 3 more likes. I'm waiting for that 3 likes. Now 2 more likes. I'm waiting for that 2 likes. 9 hours 30 minutes. Oh my god, 9 hours 30 minutes. Reaction due to I'm starting. Reaction due to alpha hydrogen or aldol condensation. Okay, this is aldol and cross aldol condensation. It's very important, guys. It's very important. Proper paakano. Okay, so aldol and cross aldol mattumda irukku. So aldehyde and ketone having at least one alpha hydrogen irukano. So aldehyde ku ketone ku aldol cross aldol condensation nadaku, but it should contain at least one alpha hydrogen. Okay, it should have at least one alpha hydrogen that undergo reaction in the presence of dilute alkali as catalyst to form beta hydroxyaldehyde, that is aldol, and beta hydroxy ketone, that is ketol, respectively. So pakalama enna alpha hydrogen aldol condensation pakalama. So this is very important, guys. This is very important, guys. So proper parunga. Proper parungada. So this is a aldehyde. So aldehyde. Okay. So it's a aldehyde. So aldehyde la enna irukku? Oxygen is there. Okay, oxygen is there. So in here also first enna nadakudhu? I want to write in a fresh page. Okay, I will write. Here I will show you. Okay, here I will show you. So here you can see ethanol. So here you can see 2 ethanol is there. Okay, so minimum you should have 2 ethanol. Okay, 2 molecule. Okay, 2 molecule should be there. So here we are taking ethanol. So 2 ethanol molecule. So in the 2 ethanol la enna nadakudda? So idudha. So one I will draw here. CH3 CHO and again enna irukku? CH3 CHO. Okay, so in the CH3, okay, inga irundhu 1 OH, okay, 1 carbon, 1 aldehyde la irundhu 1 OH and inga irukra 1 hydrogen eliminate ai water molecule inga irundhu pogum. Okay, clear? So inga irundhu enna pogum? Inga irukra 1 hydrogen and inga irukra 1 OH inga pogum. Ivada inga enna varunda? Inga enna varum? It's very simple. It will form double bond. It will form double bond. Okay, it will form double bond. Simple. Okay, it will form double bond. Okay, clear ada? Clear ah? So simple na. CH3 CHO one side la irundhu OH, other side la carbon la irundhu hydrogen poi water molecule anga irundhu eliminate agum. So water molecule eliminate agumbodhu enna varum? Double bond form agum. Clear ah? So you will get but2-enol. What is enol? So double bond irukku and inga ஆல்டிஹைடும் இருக்கு. ஓகே, ஆல்டிஹைடும் இருக்கு, டபுள் பாண்டும் இருக்கு. ஸோ தட் இஸ் ஆல்டால். ஓகே, ஆல்டிஹைடும் இருக்கு, டபுள் பாண்டும் இருக்கு. ஸோ ஆல்கஹாலும் இருக்கு, டபுள் பாண்டும் இருக்கு. ஆல்டி ஓகே, OH group is there. Okay, double bond and aldehyde. Okay, double bond and aldehyde is there. Okay, double bond and aldehyde is there. Clear? No, not clear. Or is it clear? Tell me, clear or not? Clear or not? Tell me if it is clear. Tell me clear. If it is not clear, write not clear. Okay, if you are saying yes, no, I can't understand. Okay, if you are writing yes, no, I can understand. If it is clear, write yeah. One more like only. Yeah. Clear? Ma'am, first step. Not clear. Okay. So I will tell you again. So here you can see CH3 CHO. Okay. So there I'm taking 2 ethanol. Okay. 2 ethanol, not ethanol, ethanol. So here also CH3 CHO. So what will happen? So inga irundu. Okay. Inga irundu. இங்க இருந்து 1 OHும் போகும், இங்க இருந்து 1 ஹைட்ரஜனும் போகும். ஓகே, ஸோ இங்க இருந்து 1 ஹைட்ரஜன் இல்ல 2 ஹைட்ரஜன் போகும். ஓகே, இங்க இருந்து 2 ஹைட்ரஜன் போகும். ஸோ ஃபர்ஸ்ட் ஸ்டெப்ல 1 ஹைட்ரஜன் போகும் and it will form double bond. Okay, here 2 hydrogen போயிருக்கு. So 2 hydrogen eliminate ஆகும், இங்க இருந்து OH eliminate ஆகும், it will form double bond. Last product I am saying. Okay, in between la one more step irukku. I am just writing in one step. Okay, one step la I am writing. Okay, one step la I am writing the answer. Okay, one step la I am writing the answer. So this is the one step. Okay, idu onnum thevayilla, we just need one step. Okay, so this is actually condensation step. Okay, second step is condensation step. So this is so and second இதோட எக்ஸாம்பிள் அதுவும் எக்ஸாம்பிள் தான். ஓகே, இதுவும் எக்ஸாம்பிள் தான். இங்க இருந்து ஹைட்ரஜன் போகும், இங்க இருந்து ஹைட்ரஜன் 2 ஹைட்ரஜன் போகும், இங்க இருந்து OH போகும். கிளியர்? ஸோ அதுதான் எதோட கேஸ்ல, ஆல்டிஹைடோட கேஸ்ல. ஓகே, ஆல்டிஹைடோட கேஸ்ல. தென் வாட் அபவுட் கீட்டான்? வாட் அபவுட் கீட்டான்? This is ketone. Here you can see ketone molecule. Okay, here you can see one ketone molecule. So ketone molecule la irundhe inga irundhe same 2 hydrogen pogum. Okay, so inga irundhe 2 hydrogen pogum, ana inga irundhe inda oxygen dhaan pogum. Okay, inga irundhe oxygen pogum. Okay guys, inga irundhe oxygen pogum, inga irundhe hydrogen pogum. ஸோ எல்லாருக்கும் ஒரு டவுட் இருக்கும். ஓகே, எல்லாருக்கும் ஒரு டவுட் இருக்கும். ஸோ இங்கே டைரக்டாக யார் வந்து அட்டாச் பண்ணும்? இந்த கார்பன் டபுள் பாண்ட் ஆகும். ஓகே, இந்த கார்பன் டபுள் பாண்ட் ஆகும், இந்த கார்பன் இங்கே வந்து அட்டாச் ஆகும். கிளியரா? இந்த கார்பன் இந்த ஓகே இந்த 2 ஹைட்ரஜன் எலிமினேட் ஆகிருக்கிற இந்த கார்பன் எங்கே வந்து அட்டாச் ஆகும்? ஸோ டபுள் பாண்டட் O, இங்கே O எலிமினேட் ஆகிருக்குல்ல, ஸோ அங்கே வந்து அட்டாச் ஆகும். ஸோ இங்கே இருக்கிற CH3 will form here. Okay, this CH3, in the CH3 da inga irukku. Okay, so here you can see double bond CH, double bond CH. Okay, this is CH and after that C double bond O, C double bond O. Here you can see CH3. Okay, 4 methyl pend 3 in 1 on. Clear? 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 Target achieved. Wow, that's so nice. Okay, clear? Is it clear guys? Is it clear? Is it clear? Then we are moving to cross aldol condensation. Okay, what is cross aldol condensation? So now we discussed about same aldehyde. Okay, same 2 same aldehyde we are taking, 2 same ketone we are taking. Okay, so 2 same aldehyde, 2 same ketone we are taking. Here you can see. So cross aldehyde means two different aldehyde and two different ketone. Okay, two different aldehyde, two different ketone. Okay, two different aldehyde, two different ketone. So then what will happen? So you will get four different product. Okay, you will get four different product. Every four different product kadaikum. Same aldehyde oda product onnu, same ketone oda like same aldehyde oda product onnu. Okay, and same aldehyde oda product rendu. Okay, so when you consider, here we are taking, yes, propanol and ethanol. Okay, so two propanol oda product is this, two ethanol oda product is this. Okay, two ethanol oda product irukku, two propanol oda product irukku. So adu illama one propanol and one ethanol oda product irukku. One ethanol la first enna inga irundhe, this is ethanol. Okay, ethanol la irundhu O pogudhu and propanol la irundhu O pogudhu. Okay, so four different product you will get in cross aldol condensation. Okay, in cross aldol condensation you will get four different product. Is it clear, guys? Is it clear? Is it clear, guys? Is it clear? Then we are moving to 𝐂𝐻𝐸𝐻 reaction. After that chemical properties irukku. So chemical properties முடிஞ்சதுக்கு அப்புறம் முடிஞ்சாச்சு. Okay, so we can do 𝐂𝐻𝐸𝐻 reaction. Okay, then we are moving to 𝐂𝐻𝐸𝐻 reaction. Okay, aldehyde. So what is 𝐂𝐻𝐸𝐻 reaction? So aldehyde which do not have at least one alpha hydrogen illa. So it undergoes self reduction. Okay, idukku enna nadakum? Self reduction and self oxidation. That is actually disproportionation. Nama enna solluvadhukku? Disproportionation. Okay, there is no alpha hydrogen, so what will happen? Self oxidation and self reduction will happen. That is actually disproportionation sollu. Okay, that is actually disproportionation. Reduction on heating with the concentrated alkali. Okay, so enna? So self like oxidation and reduction nadakudhu, and here we are treating with concentrated alkali oda presence la treat பண்ணும்போது. So one molecule of aldehyde is reduced to alcohol while another is oxidized to carboxylic acid. One reduce பண்ணி என்ன alcohol ஆ மாறும், another will become carboxylic acid salt. Okay, carboxylic acid salt. Okay, clear? Self oxidation, self reduction nadakum. Like aldehyde ku oxidation nadande enna aldehyde ku oxidation nadande enna alcohol ah marudum, and innonne reduction nadande carboxylic acid salt ah marum. Okay, clear? That is 𝐂𝐻𝐸𝐻 reaction, a method of preparation of carboxylic acid. Now we want to finish 3 chapter. So and the 3 chapter oda questions paatha poduma illana and chapter edukanuma? Yo, thank you Ritesh, thank you so much. So alcohol irukku, amine irukku, adoda like note என்கிட்ட இருக்கு. So note போதுமா? And அந்த question timeல அந்த questions with content பண்ணா போதுமா, இல்லைன்னா இப்போ content பண்ணணுமா? questions பண்ணா போதுமா? questions பண்ணா போதுமா? question. Then we can alcohols and biomolecules and amines order questions we can do. Oh, alcohol phenol I will take now. Then I will take alcohol phenols also. So baki amines and biomolecules order question I will give you. Okay, question na I will give you content. Okay, content PPT irukku, idukapram question. Okay, biomolecule mattum content ma'am. Biomolecule oda PPT irukkuda. So biomolecule actually romba easy ana chapter, adula avlo like difficulty illa. Okay, so avlo difficulty illa biomolecules. ஸோ ரொம்ப ஈஸியான, அதுவும் இதில் கண்டென்ட் எல்லாமே இருக்குது. ஓகே, இதில் கண்டென்ட் எல்லாமே இருக்குது. ஸோ யூ கேன் செக். ஓகே, தேங்க்யூ வேந்தா. எஸ் வேந்தா இப்போ தான் பார்க்குது. வேந்தா பார்க்கவே இல்லை இன்னைக்கு. வேந்தா இருந்ததா மார்னிங்? So method of preparation of carboxylic acid from nitrile and amide. So nitrile and amide la irundhu we are preparing carboxylic acid. Okay. So nitrile are hydrolyzed to amide. என்ன first nitriles are hydrolyzed பண்ணிட்டு we will form amide. Okay, we will make amide. Okay. Yeah. Okay. So amide and then to acid. Okay, amide என்ன again acid convert பண்ணும் in presence of H plus or OH minus as catalyst. H plus or OH minus catalyst பண்ணிட்டு catalyze use பண்ணிட்டு என்ன amide ல இருந்து we are preparing acid. Okay, so this is the reaction. Ethanoic acid we are preparing from ethanamide. Okay, ethanoic acid we are preparing from ethanamide. Next is Grignard reagent. So Grignard reagent என்ன carbon dioxide react பண்ணும்போது என்ன கிடைக்குது you will get carboxylic acid. Okay, you will get carboxylic acid. Thank you so much. Yeah, chemistry la biomolecule da, it's very easy. When you consider organic chemistry, biomolecule is most easiest chapter. Okay, it is very easy. Okay, it is very easy, no doubt. So next is from acyl halide and anhydride. Okay, from acyl halide and anhydride. Acyl halide, acyl chloride தெரியும்ல, so acyl chloride தான். So we are taking acyl chloride. So acyl chloride water வச்சு treat பண்ற and acyl chloride OH minus basic solution வச்சு treat பண்ற. So you will get here, you will get acid. Okay, carboxylic acid. Here you will get என்ன acid chloride. Okay, acid chloride கிடைக்கும். அந்த acid chloride again water வச்சு treat பண்ணும்போது you will get acid. Okay, you will get acid. So alcohol எடுக்கணுமா? இப்போ alcohol எடுக்கணுமா இல்லனா questions போதுமாடா? Biomolecule, you can expect maximum one question. More than one question, no. One question from biomolecule. And amines, from amines also you can expect one question. From alcohol, you can expect 2 question or 3 question. Fresh ma'am. So question போதும்ல alcohol question. Okay, then உங்களுக்கு in the PDF la, okay, I will share this PDF after the session. Ma'am, alcohol la physical and chemical properties மட்டும் சொல்லுங்க ma'am. Okay Kashifa, I will share. Okay, so Kashifa இந்த PPT share பண்ணா போதுமா? இந்த PPT share பண்ணா போதுமா? இந்த PPT ல எல்லாமே இருக்கு, எல்லா organic chapterம் இருக்கு. இந்த PPT மட்டும் போதுமா? To Gopika ma'am, can we start biology class tomorrow earlier? Okay. I will. So 10 o'clock or 11 o'clock start பண்ணுண்டா நாளைக்கு biology class. Okay, so இந்த PPT ல எல்லாம் actually எல்லாமே available தான். Okay, இந்த PPT ல எல்லாமே இருக்கு. Okay, எல்லாமே இருக்கு means எல்லாமே இருக்கு, எல்லா organic chapters இருக்கு with questions எல்லாமே இருக்கு. Okay, clear? So இது உங்களுக்கு யூஸ்ஃபுல்லா இருக்கும். நீங்க இதுல okay, actually 3 chapters மட்டும் தான் இருக்கு. அதுல 2 chapters ரொம்ப சின்ன chapter தான் and 1 mark very weightage and a very less chapter தான். weightage ரொம்ப less தான். Ma'am, I asked doubt before, please reply ma'am. Yes, என்ன doubt கேட்டிருக்குடா Kashifa? What is your doubt? Tell me. Next bio approve என்ன class நாளைக்கு எப்போ class? ஆமா bio class ஆடா. bio class 11 o'clock இருக்கும். 11 o'clock dinner break. இப்போ I will finish this chapter da. Yeah, this PPT is enough. எல்லாமே இருக்கு இந்த PPT ல. Okay, dinner break எதுக்குடா சாப்பிடணும், எதுக்குடா சாப்பாடு? நீட் எக்ஸாம் தானே இம்பார்ட்டன்ட், எதுக்குடா சாப்பாடு? From ester. Okay, we are preparing acid from ester. Okay, so acid ester la irundhu eppadi prepare panna mudiyum? So first we will take ester and we will treat with sodium hydroxide. So sodium hydroxide treat பண்ணிட்டு so adula irundhu you will get sodium salt. Okay, sodium salt of carboxylic acid. So we will hydrolysis. Okay, hydrolyze பண்ணும்போது அந்த sodium salt of carboxylic acid hydrolyze பண்ணும்போது you will get carboxylic acid. Okay, ma'am water ஓட react ஆனா acid and base ஓட treat பண்ண salt and acid தான் வரும். Yes, acid and base. Okay, acid and base treat பண்ணா you will get salt and water. Okay, acid and base together react பண்ணா salt and water we will get. Okay, that is actually neutralization reaction. Neutralization reaction la you will get salt and water. Correct. So chemical properties. So acid is reacting with the sodium chloride, sodium carbonate, sodium bicarbonate. Okay, so what will be the product? Acid. So acid NaOH. Acid here only you told. Kashifa, acid is base. What you will get? Salt and water. Acid and metal. What you will get? Salt. Okay, acid and sodium bicarbonate. What you will get? Salt, water and carbon dioxide. So acid and sodium carbonate. What you will get? Salt, water and carbon dioxide. Clear? Clear? Kashifa, clear danada? Then next is reaction with ammonia. Okay, reaction with ammonia. Okay, so carboxylic acid react with ammonia to give ammonium salt, which on further heating at high temperature give amide. So amide கிடைக்கும். So first என்ன நடக்கும்டா, இதோட chemical reaction தான். Okay, so acid என்ன வச்சுட்டு ammonia வச்சு treat பண்ணும்போது you will get ammonium salt. So which is further react பண்ணும்போது, further heat பண்ணும்போது you will get high temperature heat பண்ணா you will get amide. Okay, acid salt ல இருந்து you will get acid amide. Okay, acid salt ல இருந்து you will get amide. Okay, so இதுதான் reaction. இதுதான் reaction. And இவ்வளோதான் இருக்கு. reaction questions இருக்கு. and aldehyde ketone carboxylic acid ஓட இது எல்லாமே delete பண்ணணும். unnecessary PPTs இருக்கு. Okay, so clear இது வரைக்கும் clear we finished alcohol, phenol, ethers. ma'am எதுக்கூட சாப்பாடு நீட்டு தான் முக்கியம். myself அப்புறம் எனக்கு பசிக்கும். எதுக்குடா சாப்பாடு நீட்டு தான் முக்கியம். myself அப்புறம் எனக்கு பசிக்கும்ல. oh my god, எதுக்கு? I'm taking screenshot. oh my god, I really enjoyed this marathon da. So really enjoyed. I'm so happy. Okay, so thank you so much. So உங்களுக்கு ஏதாச்சும் டவுட் இருந்தா கேளுங்க. bye bye guys. bye bye. bye bye. எனக்கும் சாப்பாடு தான் முக்கியம். எல்லாருக்கும் சாப்பாடு தான் முக்கியம். எஸ் எனக்கும் சாப்பாடு தான் முக்கியம்டா. ma'am last point can you explain this point ada? so yeah carboxylic acid with react with ammonia. Okay, ammonia கூட react பண்ணும்போது என்ன கிடைக்கும்? so ammonium salt கிடைக்கும். so ammonium salt strong heat பண்ணும்போது ammonium salt ல இருந்து you will get amide. Okay, ammonium salt ல இருந்து you will get amide. lots of love. remember me Shweta. okay Shweta, okay da. so Shweta, yes, last 5 minutes ஒரு class life last 5 minutes ஒரு class ஆடா. so இப்போ class இல்லை, என்னை டைரக்டா ஆம்புலன்ஸ் விழிச்சு கொண்டு போகணும்னு நினைக்கிறேன். என்னையே நான் கொண்டு போகணும் for last 1 minute. yeah, so yeah, I want to see your love in last 1 minute. yes, bye bye guys. bye bye guys. thank you so much. yeah thank you so much. இனி அப்புறம் பர்த்டேக்கு அப்புறம் தான் பார்க்க முடியும். okay, thank you so much. thank you so much. yeah bunny. so bunnyயை வச்சு we make a story. bunny, we made a story. so bunnyயை வச்சு we made a story இல்ல. so some students asked who's bunny. so I told bunny is my student. Suresh is my dad. My dad. My surname. My dad. Ashwati Suresh. Thank you so much, guys. Thank you so much. Thank you so much for your wishes. Thank you so much. Thank you so much. Yeah, we missed Bunny. Yeah, we missed Bunny. We really missed Bunny. We made a story. We made a whole story of your. Thank you so much, guys. Thank you so much. That is surprise. That is surprise, Bunny. So, okay. So, everyone is asking who's Bunny. This guy is Bunny. This guy is Bunny. By Bunny Maharaj. Okay, guys. Bye. See you after like 2 days. Okay. உங்களுக்கு நாளைக்கும் and after tomorrow உங்களுக்கு class இருக்கு. So, we can meet on 19th. Okay. 19th எனக்கு class இருக்கு. We can meet on 19th. Okay. Bye. Thank you so much for your love. Thank you so much. So, I will share this PPT. So, thank you so much. Yeah, sure. So, sacrifice பண்ணாலும் நீங்க நல்லா மார்க் எடுத்தா I'm so happy. Okay. நீங்க நல்லா மார்க் எடுத்தா I'm so happy. So, I'm so happy, ma'am. So, இல்லடா அன்னைக்கு நான் இங்க இருக்காது. Okay. Drink boost. Okay. Definitely I can't say I don't drink boost. I need more. Okay. Gen Z word I can see here. Chill. Yeah. For me also it was very wonderful session. I enjoyed a lot. Okay, bye. So எல்லாரும் போய் சாப்பிட்டு தூங்கி படுங்க. Okay. Thank you so much, Rudra. Thank you so much. Bio live tomorrow like 11 o'clock. 11 o'clock இருக்குண்டா. Bye, guys. So, இது end பண்ணட்டுமா? Session end பண்ணட்டுமா? Bye. Tata. Bio live நாளைக்கு 11 o'clock. Bye, guys. Good night. So, போய் சாப்பிட்டு தூங்கி